All right, sound check. You guys should be able to hear me pretty all right. That's good. All right. See how this is all going then. You guys should be able to see that. Sound seems like it's a little high, but that's fine for the music, I guess. Let's give it a few down. There we go. Okay. So, what are we working on today? We're doing Linux. We're always doing Linux. Here, pop me up on here. We're always doing Linux. That's kind of the standard activity around here, but we're going to do it. Oh, I didn't realize I'd yawn the first thing on stream. We're going to do it by the Socratic Method again and doing just Linux labs and running through a bunch of things like we normally do on Sundays. But this will be absolute beginner stuff. This will be as early as it goes. But I find a lot of times as we iterate through things, even those of us that have been around and done it, we still pick things up. We learn things. We're like, that's how that person did it. I never did that before, you know, and that kind of stuff. Yeah, the real Sega. Date night's always good. Yeah, date nights are Friday nights. Last night the wife had some of her friends over and they were doing game nights. So I actually almost streamed last night. And then I didn't. I was like, I'll hang out and just work on stuff. So I was studying last night a little bit, writing some college stuff up. So I tried to stay busy. But okay, so here's what I wanted to talk about a little bit before we get started. We do have a Discord. You guys are welcome to hang out down in there. And we've got an event coming up on the August 3rd and 4th, which is our Prolog Discord. That's a professional Linux users group. Is turning 5 years old. So we got a bunch of different people coming to talk. These are all different talks. They're all free. All of these people have come in and talked before in some capacity, or they're otherwise experts in their field. So I'm kicking it off. I'm an expert at getting people to come do Linux, so that's why I'm talking. And then my brother, who's been doing data analytics for a while, he's going to come talk shop on those topics and how he got into that space and what it took and what it's continued to take for him to move up there, which he has. We're going to bring one of our resident SREs in, Michael Pessa, and he's going to talk about eBPF and tracing what's happening between some of the Kubernetes and Docker stuff he does and the kernel, right? That's a very useful and valuable topic. Reed's going to come in and he's going to talk about CI/CD and DevOps. He just recently came and talked to us, so a lot of people know him, and they're really interested. But then there's all kinds of different people. We've got a couple of people that are from AWS coming out to talk. They're actually systems engineers and solutions architects with AWS with all various levels of certifications and stuff. So if you want to ask them about getting the job in that space, keeping the job in that space, getting certifications, that's what a lot of these guys are here to talk about. And then a couple of guys that I know that are real into mathematics and data analytics and stuff. So if people want like an overly technical look at some of this stuff, that's what some of the guys are going to come out and talk about. All right, so what are we doing today? We're working on systems, as always. I'm going to pin a lab for you guys, and we're just going to stay in this lab all day, whether or not we use the lab the way it's going to be meant to use, or if we just kind of hang out and do whatever we want in there. And I got to move it up on the Twitch or on the YouTube side, so that's why I added a character. So I'll pin the message over there, and I'll pin the message on the Twitch side. So there we go. Everything's pinned. Everything's there. Om Baffy, hopefully this stuff's useful to you. Hey man, join Twitch, talk to you. Love you, man. Keep up the good work. Well, yeah, thanks. You're welcome to hang out, talk shop. We're going to work through, let's make this a little bigger so everybody can see it. And we're just going to work through some labs today. So, again, I think that for all the things that you can do in the systems world, right? For all the things you can read and study and watch videos on, and there's so much information out there, right? But I think the most valuable thing, maybe the like as watching, having over 5,000 college students, having hundreds of engineers I've trained and mentored over the years, that I think the most valuable thing, like the thing that changes you most in systems engineering world is getting your hands on stuff. All the other stuff comes with it. All the other stuff, I mean, you have to read the manual, you have to ask the right questions, and you have to think through your troubleshooting and all that stuff. But getting your hands on the system, this is really, I think, like what kind of changes the way, the way you view everything. Your confidence in the system is directly tied to how many hours you have on the command line and all that stuff. Somebody said, question, the prologue book is missing a lot of labs going from 9 to 100. Any reason why? PyGamer, the reason the book does that is those are just for the settings of the labs. It has nothing to do with the actual numbering of the labs. The numbering where you do the 1 to 9, those were all the system level labs. The 100 to whatever are the configuration type labs. 200 level labs are all of the security labs. And then in the Ansible space, I think I skipped that. I might have still kept that in the Ansible space. But the point is, I just wanted more room to add labs later as we go. So that's the answer to that question about the book. It's not really missing the labs. It's just that those are like the general. It's kind of like if you ever go to a college and there's like a 100 level and a 101 and a 102. And 100 level just denotes that it's a freshman level. And then the 101 and the 102 of a topic are like, we're focusing on, maybe in engineering, we're focusing on process improvement, and then we're focusing on troubleshooting, and those are two different areas of engineering, so those are subclasses, but you're never going to get all of the 100s. There's not all the way up to 199 and then 200, and then we jump to 200 for our sophomore level engineering classes, and then we have like a 101 and a 102, or a 201 and a 202, and those, by the way, do mirror the previous, numbers as we go down. And anyways, the point is, those numbers are non-ordinal. If that makes sense. We're not using them to count up all the things. So hopefully that makes sense. Okay, so we're in a lab. You guys can jump in the same lab with me. You can jump in any of the Killer Coda labs that have at least 2 nodes, because on some of these you're going to need more nodes. You need 2 nodes to talk on some of these. So we've done this before. We've walked through this, but I still think there's a lot of value for, especially the newer people. Like, hey, I've never sat with another engineer or group of engineers, because all of you can contribute on this, and like answered these questions. Do I know how to do these things, right? There's all these things, and we're going to basically be asking ourselves, and we're going to be asking the group, do we know how to do these things, right? I highly advise pulling out a notepad. Grab a notepad, throw it out. So I use Notepad++. You could also use a tool called Excalidraw. So you could take your notes right in Excalidraw if you wanted to. You could grab a little thing here and just start putting the notes together if you wanted to. That's an acceptable way. You could also draw things up in Excalidraw, so that's an excellent tool to use as well. Understand where is 10, 11, 12, 13, 13. Yeah, so PyGamer, those don't exist. That's the thing. I did the first 9 labs on system stuff, and then we jumped down and we did some NFS and some system setup stuff, and there are labs to be added to that, but they're not created yet, or they don't exist in the Killer Coda space yet. So if that makes sense. So the question says you don't understand it. So you could think of that as 0, 1, 0, so it would be like the 0 level, which are just like looking around the system, and those would not count all the way to 99 or 099, I guess. I hope that answers the question, because the question sounds like you think we should count from 1 to 100 and then start at 100, but that's not what the labs are doing. In fact, I am sure that it explains it right here. Let me see. Hold on, because this is making me question if I explained it. I definitely did. Yeah. Oh, I see what you're saying. You think these should keep? Yeah, no. That's the numbering of the labs. That's the numbering of the labs there. There's not 300 labs in the book. Here's all the list of the labs right there. All right. Hopefully that's clear. Okay. So let's go on with this. So some of you guys have been here before for this, and you might have remembered the things that we did. And I've added a whole bunch of these. In fact, I've got 105 slides on this one now. So let's go through it. You can add anything that you guys are, that you know about it, because some of you are engineers or admins and hobbyists and those kind of things. But the goal of this is to kind of sit through and understand. I'm going to keep my notes down here as I go through it as well. But this is for you guys to think through. And the Socratic method, people sometimes ask, what the heck's the Socratic method? It's a method of questioning what we understand about a thing, why we think of a thing. A lot of people think of it for like law and ethics and even medicine, but it's a effective method for you to think through if you do really understand something or not, right? And if you've never had a college professor do this with a class and sit down and talk with you this way, this is a way that resonates with a lot of people for how we learn stuff. And hex after 9A, het after. Fair enough. All right. So CPU topics. Some of you guys have been here for this again. Can you list the number of CPUs in a system? By the way, this should have, yep, we got 2 nodes. So, oops, if I could type. What are the list? How do we list the number of CPUs in a system? How might we do that? Who knows? There's some commands that do it. What if I cat proc cmd line, cat proc CPU info? And I can see a bunch of stuff. And maybe if this was the first time I ever looked at this, I wouldn't know that it's going to enumerate over all the processors, but in this case, there's only one. LSCPU, okay, let's see, what's LSCPU? LSCPU will tell us information about the CPUs. Specifically, I have just this one. Okay. How about nproc? Nproc's good. So we got LSCPU. We've got nproc. And these are my own little notes, so I'm just keeping. And we have cat proc CPU info. And then maybe I pipe that to a grep for proc. So let's do our cat proc CPU info, grep-i proc, and that'll tell me the one. And then maybe if I have a bunch, I'm too lazy and I just let it count them for me like that. That's actually how I used to do this back in the day, because I didn't have and I didn't know about nproc back in the day, and maybe different versions of operating systems that I had didn't have it, because when I first started, I was in very early Red Hat. I was in HPUX, AIX. Solaris was still kicking back when I started. Solaris was big when I started, in fact. But I would this is how I would do it. I would run a list against my servers, and I would find something like this and figure out how many CPUs I had. And then maybe I would do something like this. I would say for server in, and I've got control plane and node 01, do echo. I am checking. We're running before we're walking. We should be walking to start, but I'm showing you guys some stuff that we'll get into. I am checking server, right? Done. I can do that, and it says I'm checking the server. Then I'll actually go check the server. SSH to $server, and then in there, I might just go drop any one of these monstrosities, but I could drop. Let's just get one of these short ones here. Right, mouse over, Control Shift V. And then I can just do an nproc on both of the servers, and I see that the servers are the same size. Top and htop can also show cores. Okay, good. Nice. Let's see, I got top on the box, and top will show me, let's see. If you ever are in top, not everybody uses top, but if you use top, you can type H to get help. And the main ones that I know of are the L, the T, and the M right here. LTM, these are kind of the main ones, but look at all these other things that you can look through. If you want to see for the CPUs or I for IRIX mode, there's a ridiculous amount of things, right? And then maybe as Icy Boy X said, I hit 1, and then maybe it shows my different CPUs. So 1 would show me CPU 1, 2 would show me all CPUs, it looks like in this one. But that could let me know that, yeah, there's really only 1, because otherwise I would be. And then W would do it as well. Oh, oops. Let's say, and then you can always hit Q to get out of it if you're not a top person. And then what's that one? W to save. I think 1 looks like it would do what I wanted, but the point is, like we can see what's going on kind of in the system. So can we list the number of CPUs? I think we can, and we know that it's 1 on this system now, and we know it's 1 on the other system because we ran something like this and just checked the command. By the way, this loop would work all the time for anything we wanted to check. We would just drop whatever we needed to in here. I'm Baffy. Thanks for the subscription. Hopefully this stuff's useful to you. Let's keep going. So can you tell me the speed in megahertz of the CPU or CPUs that we have? We only have the 1 CPU in this case, and that's fine. But what's the speed in megahertz? And if you want to think about it, what are megahertz? This is something to go play with later, but what does it mean to be a megahertz? What is a hertz? What is a sine wave, right? Like, what are all these things? But can you tell me the speed in megahertz? It's got some of those other commands would probably help us again. ls CPU. There's my CPU megahertz right there. Cat CPU info. Cat proc CPU info will tell us some of that same stuff. Yeah, look, there it is right there. Okay. Any other commands people know? I know those 2 work. I might be able to grab. Check this out. I might be able to do a demessage. Demessage is the ring buffer from when the system started. I don't know if this is going to work, but I might be able to grep -I. I'm doing a -I to ignore the case. Linux is very case sensitive. If you're used to Windows and you can just type upper and lower case however you want, you can't do that in the Linux world. It's the upper and lower cases are different character sets, and it does matter. Let's just say MHZ. We're ignoring case, but oh look, there as the system started, as the demessage started. By the way, do demessage by itself if you want to see what it does, and pipe demessage to like head if you just want to see the top 10 lines. But yeah, we can see the speed there. So the question was here, can you tell me the speed in MHZ, megahertz? And yes, the answer is yes. I'm doing this for my own notes, just so I have it. I'm going to drop these down in the Discord later. But this is the idea that you walk through and think through this stuff and maybe work with other engineers that, you know, this is me. It's like sitting around and hanging out with another engineer. The amount of cores, which commands would do it? Would you go through the man pages or Google search initially? So I had a question on the YouTube side. If you had no idea the commands, what would you do? You'd probably go look it up on Google. Yeah, Google's an excellent tool. I call it going on like a Google Safari or DuckDuckGo Safari. So yeah, we're going to do more loops later, Heather, so don't worry about that. But there's also DMI decode. Yeah, DMI decode is an excellent tool. We are root in this environment too, by the way. If you're in the environment, you are the root user. Although we got the $sign. And I ask you this later in the lab, well, in this little practice, but does anybody know how we can change that? Does anybody know what that variable is that defines this on the command line? That's something to think about. But over here, can you tell me the speed in megahertz? Yeah, you got demessage with a grep-i for MHZ. You had your ls CPU. You had your cat proc CPU info. Yeah, that's a pretty good amount of commands to tell us what the speed was in megahertz. I think that's pretty good. Yeah, DMI decode's great. Definitely gives you a lot of information. Does anybody want to? Is that bugging anybody? By the way, I've been using these labs for so long that it doesn't really bug me. But yeah, I'm the root user, but I don't have a £sign next to my. And yeah, it's the PS1. So echo $PS1, and I can see my PS1 variable, and then I can set PS1 equal to, and I'll just do this, and there we go. Now we're right. So if you ever need to change the PS1 variable, that's what it is right there for your command. And by the way, there's a bunch of other things besides just hostname. Sometimes in file systems, in fact, let me pull up my home lab stuff. I think I have this over here. I'm going to move my home lab stuff over here so it doesn't cover my notes. But I'm in one of my dev boxes here, and it says who I am and the box. So if I were to echo, clear the screen, echo $PS1 here, that's That's how Debian does it. That's well, it's an Ubuntu box, but that's what that is. That's my PS1 right there. Isn't that wild? Kind of funny, but that's what it is under the hood. So if you ever need to go change that, that's how you do it. I think that comes up later in the labs. All right, can you tell me speed in megahertz? Yes, we did it. Okay, so we come back here, and we're done mucking around. Can you tell me the manufacturer of the chip? So the chip that you're using, who's the manufacturer? Inspector's here. How's it going, Inspector? Have you been to any Wendy's lately? Have you caused any major problems or outages on the internet? But what's the manufacturer of the chip? And some of these may look like what we've been doing before, but LSCPU will tell me, there we go. There's the model name and the vendor ID. So LSCPU will do it. That's good. What about, uname? Uname by itself will only give us the version, but what about a uname-A? That tells me about the kernel. It tells me everything that the system knows about the kernel. Here's one. DMI decode -T CPU. Let's make sure we spelled DMI decode right. Ooh, invalid keyword CPU. My DMI decode, and maybe we'll grep vendor. Maybe we'll grep chip. Maybe we'll just grep Intel. It doesn't even say Intel in there. That's fine. That's fine. We're figuring stuff out. This is part of how the Socratic method works. It's in engineering, I'm always telling you guys about the methodology of how we loop through things and iteratively fail fast and then build again and fail fast and build. And this is like a whole process for engineers. It's actually where CI/CD comes from, is this idea. With the processor. Let me see. There you go. Boom. Yeah. Oh wow, that one's nice. I like that. It tells me. Wait. Does it tell me though? It tells me the socket designation, and it tells me that I'm on Red Hat. But this doesn't give me. Hold on. Am I seeing? I'm not seeing the Intel, because this is actually an Intel-based system. What I'm seeing here is how I was booted inside of a virtual machine under RHEL, which is pretty good. NK Coder, this is not pre-recorded. No, this is not pre-recorded, guys. No, I'm talking here. Hostname CTL will not give me that. Hostname CTL. Oh, well, actually, maybe it will. No, that will give me some good information about the system, though. I've used hostname CTL to set hostnames. I've never used it to pull info like that. That's really good. I like that. But that one's a good mention. Catproc CPU info with grep-I for maybe Intel. In this case, would work. But maybe just catproc CPU info for everything. Okay. Yeah. No. NK Coder. If you got questions, or if you got, if you want to throw in on any of this, let me know. ISHW, what is that? Or LSHW. That might give us some good information. What is that? And then let's look for Intel, because we know it's Intel. Oh, okay. I like that. I've never used that. That's pretty cool. You guys, you see, I tell you guys all the time, you can do this for a long time and still see commands that you've never seen before. So I think we found the manufacturer of that chip pretty well. Okay. I think at least in our own head, we've been able to figure out that we can find that. Is that a killer code of VM? Yeah, Inspector. This is a killer code of VM up here. Yeah. We are going through, and it's pinned on both sides. This is just a killer code of lab. We're not even doing the lab. We're just asking ourselves questions and figuring stuff out. So, and I'm gonna throw these notes up in the Discord, because I've done this a lot and I've never actually written down any of the things. Like I've asked all the questions, and then I never bothered to actually like put it together and say, well, these are the actual things that we came up with. All right, so we know the manufacturer of the chip. What, by the way, we do a lot with virtual space, right? Like a lot of us work inside of ESXi, and then we've got our hosts and then our guests and stuff. For most of us, it's a lot of virtual machine work. But if you work in the high performance compute space, or some of you probably work maybe even in data centers where you actually have these systems hanging around, if you ever work with physical servers, why might some of this stuff be important to you? Does anybody know, like, why might I care if I know the serial number of a box or something like that? Why might that be valuable if I'm dealing with physical hardware? Anybody know? Anybody work with hardware enough? I work in high performance compute space, so I touch individual physical machines almost exclusively. I deal when I used to work out in like at AAA, I worked in 95% virtual machine space and like 5% physicals. But in high performance compute, I work in probably like 98 to 99% physical machines. Every single thing is a big physical box, because workloads for high performance compute are still optimized for high speed networking connected to a InfiniBand network or whatever on the back end. So it's still optimized, and these pass through VMs can't handle the speed and the load and the distributed nature of them yet. It's not there. We do tests. My company does tests every year, putting them up into like Azure and AWS space, and the back end speed for the network is not there yet. So you can output or type, something like that. It's good to know all the alternatives. Yeah. A lot of this stuff is really just about it's not even knowing all the ways to do something. It's just knowing the one or two ways that works for you guys. Yeah. I'm just gonna call you malicious instead of malicious, but yeah, malicious. That's pretty accurate, I think. Also, I wonder if this thing's gonna be able to. It's gonna call you malicious no matter what. Yeah, it's exactly right. Looking up service tags for support. You've got a Lenovo branded IBM machine, or Lenovo has sold you something as a like a supplier from IBM. So now you have to look up and make sure you don't have the IBM serial number, but you've got the Lenovo branded version of the serial number in the system. All of that information tends to be held here. Now, you might say, well, Scott, shouldn't you have that somewhere? Oh, of course. You probably should have all kinds of things everywhere. But if any of you have ever worked with the document goblins, you know that anytime you go put some documents away, they disappear. Or the one person who had that tribal knowledge has left the company, and you know, these things. So we have to know a lot of the time, and this may sound silly, but you have to know how to pull these things out of the system if they're there, if they're available. And good systems like this tend to be stamped with all the information on them. So that's exactly right for malicious. Sometimes you need to look up service tags for support. Yeah, let's see, what was this one? For serial DMI decode ST, and would you say 2? Boom. There's a bunch of information about the system. Yep. And in this case, we know we're on a virtualized box, that because we're on Ubuntu, but look, under the hood, it's RHEL 8.6. So that's kind of, there you go. Some stuff's so overwhelming. Where should I start to gain speed and knowledge to need to follow along? OM, I'm just going to call you OM. You just need to get hands-on. Just hop in one of these shells with us. The shell is right here. I've got it pinned. It's free to get in there. Killer Coda gives you a free lab for an hour. I'm going to have to restart this at some point today. Probably a few times. But yeah, you can just get in here and start doing the commands with us. All these commands over here, they don't cost you anything but the time that you were wasting hanging out with me anyways. So that's what I would tell you, is just get your hands on it. It's the same. So the question for you guys over on the YouTube side, the question was, you're feeling overwhelmed. What do you need to do? Like how are you gonna get into this? Well, I always use this example. But let's say you want to go work out at the gym. You got two friends and they're going to the gym and they're having a good time, and you're like, oh yeah, you know, they're getting a lot of good gains. So you go ask them, hey, can you help me like learn about the gym? None of those friends, I don't care who you are across what culture, none of those friends are going to sit you down for 6 hours in the locker room, drawing up on a whiteboard and teaching you about the gym. This is gym etiquette, and don't walk between this and this, and don't, you know, if somebody's using the weights already, you don't take them from, like, nobody's going to do that. They're just going to tell you, yeah, hey, come follow us around the gym. And that's kind of how I do this. It's kind of how the Socratic method works. You just kind of sit with the philosophers. You sit with the people that are doing it, and then you just get your hands on the keyboard and start doing it. Every one of these commands that I've typed so far and everything we've talked about, completely free. I mean, aside from the time it takes you to go type it in the system, there's always an opportunity cost of time. Nothing's really free, right? Like you could be out doing yard work, or you could be watching somebody else on Twitch or YouTube right now. But what we're doing is getting our hands on a system. Yeah. So just literally get in one of these shells and start typing it. Because before I typed this command a few seconds ago, somebody put this in chat, DMI decode -T2. I didn't know exactly what was going to come out of there. I knew that it was going to be a DMI decode output, but I didn't know it was going to show me this. And I use DMI decode all the time with grep, but I don't use it with these T. So that's something I'm kind of learning and trying to get a little better with. Now, if I needed to dig in on it, I would read the man pages for it, right? We call it RTFM, read the field manual, right? That's not what it means. You can go look it up if you need. But we understand and we build, and the point is I'm just showing you guys that you could follow along with me and do these. And at the end of the day, I've only done like 9 commands so far. So while I've been talking here, anybody could be typing those commands in. All right, so let's go a little more. Can you tell me the architecture of this chip? So probably all the same stuff, right? Cat proc CPU info. And there's the architecture and the model name. It's a Sandy Bridge. And what about, can you tell me the flags and information that may be useful for me to know if I was sending this up to a vendor? Is there things in here that might be useful for me if I'm trying to set up a specific type of compiler or a very specific software package for one of my scientific researchers? You guys got to remember, when I do stuff at the bottom, please increase the font size and audio quality also, not on a mobile device. I don't know if I'm literally talking directly into my microphone. I think you should be able to hear me. In fact, I used to leave my microphone over here and people didn't like all the sound differences, but I mean, I think you guys should be able to hear me pretty well. Plus I have at the bottom of the screen closed captioning, so hopefully that works. This is as big as I can make it here. This is as big as I can make it here without, I guess, zooming in. And these are just my notes. So anybody that was doing this should make their own notes. You shouldn't just, I mean, you could copy my notes if you wanted, but you shouldn't have to. So anyways, hopefully that makes sense. Can you tell the architecture of this chip? The system is running on some type of processor. Can you tell me what that processor architecture is? Yeah, we know it. Cat proc CPU info. Let's look at the LS CPU. Does that give us it? LS CPU as well. So cat proc CPU info and the LS CPU. Let's see if any of those DMID codes give us that same thing. Okay. Yeah, well, thanks guys. Hopefully this is good. Let's do a DMID code again, right? Because again, and the guys used to make fun of me. I worked at a company years ago, and it was actually funny. Management would always yell at us because they'd be like, everybody's always hanging out at Scott's desk. And I'm like, the guys are asking me questions. I'm actually doing work. And they're like, yeah, you got to stop letting all the engineers hang out at your desk. And I'm like, yeah, well, we're hanging out, but like I'm doing work and they're asking me questions. Well, anyways, the point is, one of the guys always made fun of me because somebody asked about like checking something on the system. And I said, well, you just do this and you type it in because it's free. It doesn't cost anything. And he always made fun of me after that. He's like, oh yeah, Scott's talking about how free the commands are. These commands, minus the time it takes you to either listen or type them, are completely free to the system, right? It doesn't really make any kind of... Uh-oh, I got to text the wife real quick what I want from Jack in the Box. Let's see. 1 second, guys. Two breakfasts, Jacks. Anybody here live where there's a Jack in the Box? I mean, people are all around, so they're not international or anything, but let's see. All right. Wife's going to run and grab food in a little bit. Yeah, it's. I know they're on the southwest and like the west side of the U.S. But anyway, so can we tell me the architecture of the ship? Yeah, yeah. We don't have to dig too much into that, but I think that we can see the architecture. We can see information about flags, and these flags become very important later on if you're trying to compile things, because sometimes there are assumptions made about the type of system you're on, and if you have to compile. So nowadays, most all of the things you're going to do in the systems administration and engineering world is just add packages to a package manager. That's true. But sometimes, and this still happens in the high performance compute space somewhat regularly, we have to compile our own stuff. We will get the base packages and we'll do our make, we'll do our configure, our make install, and our build and all that stuff. Yeah, Jack in the Box does have pretty good tacos. I grew up on those, right? Especially back in the day when they were 2 for 99 cents or whatever. And you'd go get them when you were drinking. Yeah, when I was younger and I drank. But anyway, so over here on the flags, you have all these flags that they come up when you start to compile stuff. Let's say that. For the most part, your package manager is going to sort a lot of that stuff out for you. But if you do find yourself compiling code that you find on the internet and doing all the package dependency nightmare stuff that we used to have to do in the systems world, and thankfully we don't have to do much of that anymore, these flags all become very, very important to you. They become very important to you to the types of systems that you have. They become very important to you to the differences in architecture. So I run a big high performance cluster that is a Frankenstein's monster. So if you're familiar with who Frankenstein was and who his monster was a collection of body parts, right? And this cluster that I'm on has multiple generations. They bring new drops in every year. And every time they bring in those new drops of equipment, there's slight differences. Sometimes there's a whole new architecture because it's a whole new year's worth of equipment. Sometimes there's just differences in like the underlying InfiniBand cards, which are called Mellanox cards. They're these HCA cards. And then all these other things. But the point is, when we do stuff as engineers, we have to understand what the systems are set at and what the differences are. So a lot of the stuff when I'm saying to show me things, you're showing yourself so that you can go look in the documentation and go find out if this thing can handle the package or whatever you're trying to build on it, if that makes sense. What does virtualization type mean? Where? Virtualization type. Right here. It probably just means that we're a fully virtualized server. I'm not sure exactly what it means in this context. I can tell you that this is a virtual guest. So we know that we're on KVM, and then we are fully virtualized. So, we know that anyways about this system, and we're going to find that out as we go. But yeah, I'm not sure exactly what that context is, but I would guess as educated a guess as I could make, we are fully a guest on the system. So, we do know that about the system. All right, so let's keep going. Can you tell me if the system, that's the next question. Can you tell me if the system is physical or virtual? Can you tell me if the system is physical or virtual? What commands might we use for that? We've had some pretty good ones for this one over the years. Oh, let me get that out of the way. But what are some ways that we can tell if the system's physical or virtual? Install Linux, break it, try to troubleshoot, reinstall Linux, and every time troubleshoot lets you learn something new. Yeah, ICS, that's what we used to do. I tell people, back when I started, somebody would just throw you a disk, an actual CD, and tell you to go install Linux. And if you couldn't install Linux, you couldn't be a Linux engineer. Nowadays, it's you could just jump into a shell and at least start learning some of the basics. But back when I started, yeah, if you couldn't get it to work and get it installed on your system, guess you're going to go be a Windows person. And that's sad, but that's the way it was. Now I think there's a lot of avenues to get into this. And I think, I told you guys my philosophy on this. I think that all engineering leads back to Linux anyways. Like storage engineering and security and just all kinds of engineering that you can do and things that you can touch and little Raspberry Pis and ARM architectures and all these things tie back to Linux in some way eventually. What was my first distro? Oh gosh. First let me start with, we used to have linuxdistros.org. So linuxdistros.org was a site that just had all the most recent distros. So I've installed Yellow Dog, which is where Yum comes from. I've been on Blue Dog Linux. I was on early Red Hat. I've been on Solaris since maybe 4. So I've been playing with Linux. The first official like thing I ever did professionally on Linux, I think, was Red Hat 4. So what is this? What is this one? LS W-C system. Oh, that's really excellent. I like that. You're giving me a lot of NK Coder. You're showing me stuff that I have never used before. I've never used ls show like that, or I've never even used that command. I didn't even know that was a command. Look at that. That was checking. If you guys didn't know, that was checking everything and only giving us the components of whatever it wanted. So that's excellent. How about do I have any? Oh, whoops. Do I have any vert commands on here? Let's see if I have any vert. I don't have vert on here, but you can typically do like a vert what. Let's do app-y install vert what. And you can just install stuff on this. This is a lab environment, so you do whatever you want. In the enterprise, you don't do this. You don't do whatever you want in production. But down in like your dev, if you've got your own little dev boxes, you can just install stuff whenever you want. So like for me, I always have, so it's like I've got my prod environment, and that's where, you know, customer facing, you don't take that down. Then you've got like sometimes all the way from prod back to dev, and sometimes you'll have test, QA, acceptance. I've seen 15 to like 17 different things in here. I think at Lockheed Martin we had like 17 between that. Let's see this one. System manufacturer, DMI decode -S system manufacturer. KubeVirt. Okay, that would work. That's excellent. Like that. I get, those are two ones that I have not seen before when I've done this, so that's excellent. How about vert what? That tells me that we're on KVM. That lets us know that we're on a virtualized system, so vert what would work. How about, what other things might help? What if I did like an ls mod and looked for vert? And then, well, look, this is a bit of a jump. This is a little bit of a jump. This is like a, maybe if you've been in the environment for a long time and you know. What if I told you that you looked at all the modules that were loaded for the kernel, and you just happened to see that you're using a bunch of virtual modules? Let's look at these ones. So we've got ls sys devices virtual. Now, does that for sure? So I guess those are virtual devices. So I guess, but much like mine, you have to make like a there's a step in logic. Does that make sense? This tells me I'm on KVM, and I guess I had to know that KVM was a virtual machine, and I guess with this one I did have to know that. But let's say that that's like a straightforward, like that's like directly hearing it from the command. These commands are kind of like, and then I had to know something. Like I had to know that virtual modules loaded means that I'm probably on a virtual machine. Let's see LSPCI. LSPCI is excellent for seeing what's going on. QEMU, that's another one of those ones that you just kind of had to know. But yeah, QEMU is one of our it's like a virtual tool. So yeah, I would buy any of these for PCI, and then look, you know, then you would look for something like QEMU, right? And then what are these other ones? Yeah, I mean these ones are okay. We'll leave them out, but they're okay. This is one, somebody always has this one. Systemd detect vert. That's pretty good. Yeah, there you go. So Systemd can detect virtualization. Systemd can do so many awesome things. We're gonna play with some Systemd here in a little bit. But can you tell me if this system is physical or virtual? I would say that we can conclusively say that this is a virtual machine that we're in. Makes sense. They weren't going to give us a physical box, but that's fine. You will find, and you guys hear me talk about this scenario often, but I've talked about the scenario because I've been doing this for a long time. You get called in the middle of the night and you get asked about a server. You know, you get on this call and there's already 20 people and you're still like rubbing the sleep out of your eyes, and they're like, what's going on with this set of servers, and you've never been in them before. And this is a scenario like when I do the incident management stuff, we talk about like, what do you do? Like, what, you've never been in these systems before. I mean, do you start going and looking at documentation, or do you immediately check if you can get in all those servers? And they're telling you the servers are up, they're telling you the servers went down. How do you start to like sift through all of this? And I've got a whole process for that. Like I make sure I can get into all the servers. I check their uptime. I check who's logged into them. But if I've never been in the server before, maybe I want to know, is it one of my physical machines or one of my virtual machines? By the way, in some companies, like when I worked at AAA years ago, you used to getting your bearings. You've never been in this tool, but again, it's like that gladiator scene where the hordes are going to come out. They're the barbarian hordes, and they're about to be destroyed by the Roman legions, right? And Marcus Aurelius tells them, no matter what comes out of that gate, stick together. Like, know what commands you're going to do to test these things about the system. It doesn't matter. Like, it doesn't matter what environment you throw me in. I will do the same exact things. I won't sit around and flounder for 10 minutes because I know exactly what I want to figure out. Now, look, I'm not saying I'm going to solve it in 10 minutes. I'm not saying I'm even going to be able to. I may have no idea after 10 minutes, but I know I will do the same exact things every time, like a checklist in my head. Okay, how long has the box been up? Who's been logged into it? Is it physical? Is it virtual? What networks are it on? Does it have routes out to the internet? Did it ever have routes out to the internet? And I'll just start checking these things, and I have these things that I go through all the way, and then as you see things that move off of what you consider a baseline in the system, those are the things you go start to dig into. And you listen to what the people say. You listen to what they say on the call. But I tell you all the time, I get told all the time, the server is down. And then I get to the server, and they're like, oh, no, sorry, we meant the service is down. And I'm like, those are two completely different things to me, right? And then when I'm inside the server, the service not being reachable from the outside and the daemon being down are two completely different things as well. So, like, as engineers, there's this idea, and it comes from a lot of different things, but it's called thinking slow and thinking fast. You've got the things that you want to step through and think about, and then you've got like where does it send you off to? IO fault. We've got a set of labs that Fisherman keeps. One of our guys is Fisherman Guy Bro. He has a set of labs, and I'll link all the labs for people that want to go play with the labs. But his labs are very much like you're just getting bad information in service tickets. So I'll link you guys the labs over on the YouTube side as well. You don't have to go do those now, but bookmark Fisherman's labs, because his labs are like you're a sysadmin just trying to get through the day. So there's that. All right, I'm missing chat. Sorry, hold on. Let me go look. I never say the box is down. All I know is if I can't reach it. That's true, Inspector. You never know if a server's down. Funslot said, I have Linux system which I use real, or when I boot to Windows using PCI right through VMware, or when I boot to another Linux using using KVM. So from my perspective, it does not matter. Also, could be considered virtual OSs. Does use abstraction level of some sort. I could not distinguish all the drivers exists at the same time. Sorry, I'm like, my eyes I'm still waking up. Despite I have a real SSD and everything itself is virtual component. Yeah, virtual components are excellent. The reason a lot of times some of this stuff that I'm showing you too, it doesn't matter unless you're troubleshooting. Like, I don't care. Like, if I'm just sweeping across a bunch of servers and somebody's like, hey, the NFS mounts are being weird, and I hit all those servers, I make sure they're up and they haven't changed, and then and we have different techniques for hitting all the servers. I use Ansible, but you could also use like sweeps over like SSH with loops and stuff. But I don't necessarily care if all of those boxes, if I check and all the boxes are virtual, but like 3 out of the 7 can't reach it anymore, then I'm not going to really dig in on the virtual piece of it, right? I'm going to go somewhere else and try to figure why those 3 nodes, which maybe they're new nodes and they can't connect, and I go, are they in a different subnet? Are they in the same subnet? And are there firewall rules that are blocking them? These are all these things that I can start to figure out very quickly once I kind of have eliminated other things. Like the first thing I eliminate is the box on and is it reachable, right? Then I see if it's always been up and all these kind of things. Things get sketchy when you need to troubleshoot inside Docker. Docker does present any Docker and any of the software-defined networks, SDN, present very unique challenges. So Docker itself isn't software-defined networking, but once you get up into Kubernetes and it's doing all the networking for you, you're just defining the stateful, the way it's supposed to work. It starts to get messy. Thanks for doing this. Commentary based on the real-world experience is valuable. Yeah, Manuel. Hopefully this stuff's useful to you guys. That's why we do it, right? I do this stuff. The official reason I do this is to get people down into the professional Linux users group. The professional Linux users group reason to exist is to take you guys from being amateurs and make you professionals. Like, show you that you have a path to doing this stuff for money, right? If you want to, where's it at? Nope, wrong one. This one. I can answer that. For money. All right. Spin up the CPU to a high load for 3 minutes. Can you do that? Can you, so let's say can you, in my notes, spin up the CPU to high load for 3 minutes. How might we do that? Software defined network. Yeah. Where's my gateway? Where is anything? And it's like you're trying to like feel like, when they push air through sand and then you're like going like this and you could like feel the sand moving. Like, you guys ever seen how like sand becomes almost a liquid when you pass air through it? Have you guys ever seen that before? There's some cool projects with that. I've seen that stop trucks before. Yeah, there's a DD command that'll do this. Yeah. And then there's also supervisor D. I don't know about that. I don't know about IO dash. I know we may have stress. There's a stress tool that'll do this for us. So apt-y install stress. Is it already there? No, we'll install it. And then if you just type stress by itself, this is a way to do it. I'm going to show you another way here in a second, but stress will say, okay, well, we could do the number of CPUs. Now, I know I have one CPU, so I may say stress-C4, so we'll make like 4 CPUs, and then the timeout of 180. Because isn't 180 3 minutes? Whoops. Oh, it would help if I it would help if I spelled stress right. And this will go spin up the box. And I've got these other terminals here. I can open a new tab over here. And I can go to this tab, and while that's spinning, I can make this, while that's spinning over there, I can say while true, do uptime sleep 2 done. And now I can start to watch the uptime really shoot up in the 1, the 5, and the 15-minute load averages for the system. I think it's the same under the hood, Malicious. Is stress the same as stress NG? I think they may be the same under the hood, but I'm not 100% sure. But now look, I'm watching that system spin up to like a high load. And like, is this the best way to watch this over time and hand this off to a network operations center? No. The best way to do something like that would be when we spin up like in our monitoring. I got our monitoring somewhere. Like in my home lab server, when I spin them up, you can watch the Grafana graphs actually go up and down as we do this type of stuff. But that's going to spin for a while. We're going to watch that go up to a pretty high load. The server's under a bit of that. So we'll say stress dash C for timeout 180, right? Boom. That would work. But we're also going to use the DD command. So let's let that system go. It's going to spin up to a high load. We only have 11 minutes left of this lab. And then this lab will reset, and I'll have to hit the button and restart it, which is fine. I love that Killer Coda gives you environments for an hour to go mess around with. We've gotten a lot of messing around done in only the hour where we've been talking a lot. But so this is going to run. It's doing its thing. It's spinning up. I'm clicking the tab here at the top to go to the other terminal. And yeah, this machine's about to be as high as it can go. Well, not as high as it can go, but it's about to be as high as it's going to go. And then we're going to watch it start coming back down. Yep. As soon as this finishes, we're going to start watching those numbers drop. Because I switched from industrial PLC to IT working with Ansible. Oh, nice, Stefan. Hopefully the Ansible stuff works well for you. I think Ansible is just, it's one of the best tools ever made for hitting all of these things and reproducibility and all that stuff. So hopefully it works for you well. And feel free, if you are ever down in the Discord, or if you ever play with Discord, go tell other people that they can do it. Because I know some people just hang out in the Discord and they worry like, oh, I couldn't do this stuff. I guarantee you, any of you guys can do this. You just got to spend time with it. Spend time with it and learn the stuff. Look, we're going to start watching the system drop. Load averages is dropping, right? Or are dropping. So come back over here. That's done. But what about this one? Let's do this other one. So we'll say dd, and dd is a command to do what's called disk duplication. It's a disk duplicator. You can read the man on dd if you want, but it says convert and copy files. It's typically disk duplicator. So I'm going to say dd, and then I'm going to take from an in file. In file is going to equal dev urandom. So we're going to random. We're going to cause every time we want to get a bit, the next bit as we copy these over, we're just going to go grab it off of the processor, and the processor is going to have to think to give us a 0 or 1. That's what's going to happen here. The out file is, we're going to go to dev null. We're going to throw it in a trash can. But then the block size is going to be 1024K, which is a 1 meg block of ones and zeros, right? Just random ones and zeros. And the count will be, let's say 5,000. So that's going to be a 5 gig file being generated. And then we're going to take that and we're going to throw it through a bzip 2 -9. And then we're going to throw all of that into dev null. So I'm going to do one of those real quick. Hit enter. And now the system's going to sit there and think. But watch this. If I come back over here, see how the load average was dropping? Now the load average is going up again. So, but then it drops because it probably finished. Watch. Probably finished over here. And it said, okay, I could do that 5 gigs in this, I didn't put a time on it, but I could have it do a time. So I say, well, wait a minute. What if I just went like this? What if I said for I in, and then I did like a sequence of 100, do that, right? And then as I get done with that, I'll just go ahead and throw it in the background. Done. Now, normally you have to do this if you want them to be sequential. Like if I did this right now, it would do the first one, and then it would, wait, and then it would do the second one, and whatever. But if I do this right here, throw an ampersand on it, it'll background all of them. So I'm going to kick off, oh, this is going to be a lot. I'm going to kick off 100 of these at once on my system. So now we come back. This is going to break shit. Now watch this. Oh yeah. Oh yeah. Spins up through the roof. All right. So hold on. I went a little fast there. Let me show you guys the command I did. Oops. Did I just break that terminal? No. Okay. This is the command I did. If you want to do it in your lab environment, there you go. I don't think you'll get any input if you say dev null in the account. Please get any input if you say you just move it. Yeah. I could probably remove it out. I will tell you, this is still. You're probably right. It's probably not going all the way over there, but look, I still managed to spin up. Probably just because it's grabbing them off the thing. So here's a command that I could use to do that. But yeah, we could spin up the load. By the way, that's going to be for longer than 3 minutes. In fact, that's probably going to possibly crash the box. All right. So the next one, the next one's going to be memory topics. But the wife's coming back with breakfast right now, so I'm probably going to take like a quick little break. I'll put the let's let that spin there. Let's put Ranger Cam on. Where's Ranger at? Where's my Ranger dog at? Why is his camera not working? Ranger's not maintaining his camera very well. All right, I'll have to go reset his camera. But what we'll do is we'll take a little bit of a break. And whenever the wife gets home, let's see. Let's see. I haven't ever played with that one to bread. So let's see. Open SSL, speed, multi, and is there a space there? So that's going to be by 1, right? Ah. it's just gonna cause us a whole bunch of problems. Interesting. That's also going to push us even higher. Okay. Wrong. Devinal will not pass content. You're probably right. I probably didn't need the dev null in there. So yeah, I think when I normally write this, I don't bother to do the out file like that. I just grab it and then pipe it over. I like this one though. OpenSSL speed multi and proc by the number. So that's, guys, so you don't know, that'll do what's called an interpolation, and it'll drop the number 1 on the server right there. So OpenSSL speed multi and proc. It's kind of cool. And is that just doing MD5 hashes over and over again? Ah, that's nice. And then that generates, so you could do that. Okay. I've never messed with that one. That's pretty cool. I like that. And I'm keeping my own notes, guys, but I'll drop these notes up in the Discord later. But a lot of this stuff, the idea is, as you look at it and you see it, you're gonna probably forget about it if you just watch me. If there's this old saying, if I see, I forget. If I hear, I remember. Or if I hear, I forget. If I see, I remember. If I do, I understand. This is why I tell you guys to get your hands on it. Type the commands out. Like, figure it out. It'll work. I think the wife might be home. I think I'm hearing the garage door downstairs. Yep, definitely hearing the garage door. All right, here's what I'm going to do. I'm going to put us on a quick break. So how do I do breaks? I always just do my hourglass. And we'll let this spin. This lab is going to die here in a second. So what we'll do while we're waiting... Ranger Cam's not doing any good. Let's do that, and... I don't know, maybe that one. Ranger Cam's busted. The lab's gonna die anyways, so we'll just close that down. And I'll just, whoops. Oh, I'm on the wrong one. Hold on. $218. There we go. That's the one. Let's go here. Oops. Wait a minute. Do I have that one working? Oh, I need to work on that one a little bit. Some of my labs aren't. Some of these aren't very well put together yet, but. That looks colorful enough. All right, so I'm gonna leave these spinning for you guys. You guys can look at how the lab status is going and how the logs are doing. I need the security one. Where's the security one? Security and connectivity. Wait a minute. Where's security at? Oh, we got all the telegraph metrics. All right, I'll leave that spinning because maybe that's colorful and you guys like it. Sometimes people like colorful stuff. All right. Anyways, take a quick break and then quick break. And then more lab stuff. I'll do 10-minute break. All right, I'll be back. Alright, I've made the worst type of mistake. The wife was leaving. She was not getting back. So, oops. So, let's stop this for a second. We'll come back to this. Also, Ranger Cam should be working. Should be. Oh, there he is. There's Ranger. All right. Ranger's back. All right. All right, let's do a little more. Because the wife's not back yet. She was going to run and grab the stuff. We'll take a break here in a minute. So, here's his lab. For you guys, you should just be able to click on the lab. Let's see. Lab should take you right in. There we go. Move this out of the way. All right. So, we will continue on with this, and then we'll go on to a break. So, memory topics. First one, can you tell me how much RAM we have? How would we find out how much RAM we have? How much RAM do we have? Free-M will do it. Good. How about free-M with an H? What does that tell us? How's that different? Not an H, a T. What's a T do? How about, could you just run cat proc meminfo? Would that work? I mean, that's hard to read, but it is the information. And if you want to feed it into something, that would work. Hold on. What is going on here? One slot. I'm trying to do this because I do not get why proxy pass for endpoint is not working for Docker DNS name resolution, Docker exec-it, nginx bin sh. Htop might be on a box. You might have it htop. You can see how much memory is there. Okay, that's fine. I'd say htop's fine. It does show the overall usage. Also shows you breakdown a little bit. That's fine. The real Sega, it depends. So the question is about doing long-term Windows and Linux VMs. I have all my long-running VMs on XCP NG. So I run XCP NG in the home lab here. And that's where all of my servers sit, on a couple of physical boxes behind me. And then all of my different servers for my infrastructure are back there. So you can get away with that. Some people swear by Proxmox up and down. They swear by the Proxmox type stuff. I'm not going to tell you that any of those are better than the others. I mean, I would go make sure. Yeah, ICS, thanks for coming by. I would tell you guys, make sure that you're getting the what was I thinking? Make sure you're doing something that's supported moving forward. If you're using a free and open source tool, that's fine, right? But just know the implications. Like, I know with my XCP-ng that they're never going to do any kind of support for any of their Ansible stuff. In fact, some of their Ansible modules, myself and M-Pesa, who comes and hangs out sometimes, he and I have had to work on some of those modules to get them working the way we want, because nobody's ever going to support that, right? And some of the modules simply don't do what we wanted them to do, so we just had to pull some broken pieces out of them, because nobody's ever going to work on those modules again. Those XCP guest modules, they don't get any maintenance. But that's the thing, is if you're running something in the professional space, we always have somebody to call. We always have some support contract of some type. That's actually a requirement for all government projects. But in the personal home lab space, you just need to understand that, like, you're not going to have the same redundancy. You're not going to have the same person to call. So you just need to know what you have. So, okay. You need to know what the differences are. All right. So this one was how much RAM we have. Can you tell me how much RAM we have used? All right, how much RAM do we have used? Anybody know that? Same ones, right? HTOP was showing that. That's cool. Free-M also shows how much is used. It also shows us some is used and some is in buffer cache, and then some is available. So there's some stuff there. But yeah, it's all the same commands. Free-M, HTOP. Now the catproc CPU or catproc meminfo isn't going to tell us that, but there you go. All right, so there's that, and then how about this one? Can you tell me how much RAM we have free? Well, that's the same as the used, so I'm going to skip that one. Can you tell me how much swap we have? Are we running swap on this system? Should we be running swap on the system? This system has no swap, right? Right, there's no swap on the system. All right. So how much swap do we have? Done. That's fine. Free-M would do it for us. And then there's that. Yeah, free-M is pretty good for that. Absolutely. I think that's a good one. Okay. How about the next one? Let's go to, can you free all of the cache memory? So you got this cached memory, but could you free that memory? If you needed to, can you free all of the cached memory? And by the way, why might you want to do that? Does anybody know why you might free the cache? Supporting devs and database people. But why might we free all the cache memory? And how do we do it? Good question would be, what percentage will start to use swap? Okay. Some file systems, some vendors require you to have swap set up. Oracle, you'll never set up an Oracle database without swap. Now, do you ever want your system to swap? Absolutely not. But an Oracle database on Linux requires swap to be active. And it requires a certain amount of size depending on, like I've put Oracle databases on 1 terabyte RAM servers, and you have to have, in those cases, typically like over 64 gigs of gigs of swap ready. Do you ever want to swap 64 gigs? Oh God, no. That would be 64 gigs of memory being written to disk. No. But I mean, and you might say, well, how would I ever use 1 terabyte? Oracle databases will use 1 terabyte of RAM. Ibra Ta over on the YouTube side asked about what is swap. Swap is the idea of writing. So you run out of memory space. Memory space is like your desk, right? Your processor is doing all the thinking, but it's holding open these memory pages, right? And memory pages are quickly accessible memory for the processor, right? But when you run out of memory space, this right here, when you run out, what'll happen is your system will start to write down to disk. It'll have a swap disk, and it'll say, okay, well, I'll take this stuff that's on my desk right here, and I'll move this down into a slower storage that's about 1/100th the speed of the RAM, because disk is always way slower. And what you end up having is the memory space is being freed up, but then when it goes to read that, it has to go read it back out of swap. It's 1/100th the speed of if it were in RAM. So early on, that was a really awesome solution, like extended memory ranges and these things where we could have more than we really had so that the system could access more memory. But you're accessing it at such a cost nowadays that you don't ever want to do it. So, in fact, if I'm forced to use swap, I'll make a RAM disk and I'll mount the RAM disk as swap so that even when you're swapping, you're still using the RAM of the system. And you say, but don't you have to pay in some of the RAM of the system? Yes. But it's still, if you have to swap for a reason, you have to do it. Okay. Can you free all the cache memory? Yeah, you've got these echo commands, and I like to echo 3 into proc sys vm drop caches. There's 3 levels you can do. You can go look them up if you want. If you just look that up in Google, it'll tell you. One is like one is one of them, 2 is the other one, and 3 is all of them. So if I just did this, and then I did my free -m, I should see, oops, echo 3, oh, guys, you got to stop me. You got to put it into there. That would immediately rather drop our buffer cache, and then it starts to fill up again, right? So could you drop all the drop caches? Yep. Or can you free all the cache memory? Yep. And that's not something you want to do often, but you will typically, like if you're in a dev environment and your devs spin up virtual machines and then kill them, but the virtual machines are still holding, this happens a lot in Java, something's still holding the memory and the caches don't clear even though you've wiped all the processes, that's a nice thing. And also databases do this. Sometimes when you bring a whole database down and bring it back up or try to bring it back up and the buffer cache hasn't cleared, you can use this to drop caches. Now, notice in both of those cases, I just said in dev, and I just said they've already turned their process off, but it hasn't released whatever it was doing. That's when you do this. You do not do this against a live system. Like, you could drop caches against a live system, but you can cause problems. So, yeah, it's also, yeah, very useful for just making sure everything's clean in the system, right? And I do that to get everything all the same. All right, the wife is back now. So I am going to go take that break that I was talking about. So let's take this. Let's go back here. Check on Ranger Dog. How's Ranger doing? Ranger is moving because the wife's up. The wife's home. I'm going to take my break real quick. I will be right back, guys. I'm going to go eat. And we will come back to doing more Linux stuff. But also, you can start working on that next one, which is generate high load for the time being. What's my time look like? All right, got 2 minutes. All right. Let's get started here. We are back. Or I am back. I haven't missed anything, it doesn't look like. All right. I'm back. I have 36 seconds to spare. Also, Ranger got a treat because when I get breakfast jacks, I don't always eat all the egg on them. So I give him some extra egg. He really likes that. So, all right. What are we doing? For people that got here later while I was on break, we are doing more of this Socratic stuff. It looks the same every time. But we're talking through how you can mess with a system, how you can check things on the system and verify things. And we are down in one of these nodes and we're doing stuff. So can we generate high memory load for 3 minutes, and can we verify that we're doing that? So yeah, let's see if we can do that. We have a tool called stress. That's one way to do it. There's some other ways to mess with memory, but stress is a pretty easy one. And when this comes up, how's it going, Monkey Man? We're going to open up a second tab, and what we'll do, we'll just, in our second tab here, we'll make a simple little loop that just says something like while true, do date, and then maybe free dash m, and then sleep 2, and done. Right? Super simple little loop. It's going to loop forever over here. And all it's going to do is show us how much memory is used, free, how much is cached, and what we can do over here to try to use that up. So let's say stress, and stress will tell us, okay, well, you have this memory dash m or dash VM, and you can spin up a certain number of workers, and the workers are going to use a certain number of bytes per worker, and the default is 256 megabytes, by the way, right? So when I spin this up, when I say stress dash m, if I say like 8 workers, then that means that I need to have at least 1.5 gigs free on this box for this to work. So I'm just going to do this. Timeout, maybe 180, right? 3 minutes. It's going to break because it can't allocate all that memory. There's not enough memory to do this. Yep, broke. So you might have to step down a little bit the amount of memory that you're trying to use on this box. Still can't do it even with 4. So what if I do, let's try 3. So that would be 700 something megs of RAM, right? So that's going to run. That didn't break. If we come pop over here, we should see that we have less free memory, more memory used in our system, right? And we should be able to generate a high load on the system as far as memory goes, right? And then we can do that, and we can see how the system behaves, and we can keep track of if we have any of our other monitoring up there where we keep track of free and memory pages and all that stuff. We could see what's going on in the system, see what kind of resources we have left over, right? So that's kind of the goal of all this. Also, I missed some follows. Hopefully this stuff's useful to you guys over on the Twitch side. So, got the memory stuff. That's going to go. And then I say here, file system stuff. So we'll do a little bit of file system stuff. That's fine. We can leave that. We can hit Control-C over here, and that'll stop it. So what are some file system topics? Can you show all of the used space of the root partition? Can you show all of that? What is that? Is that df-h/root? Yep. And it shows me a bunch of other stuff, but for the most part, I can see that I'm using about 45% of roots, of the root partition. That's the root partition right there. That is the root of the entire file system. Everything hangs off of that, unless it is a separate mounted partition in the file system, right? Okay, so we use df-h on /. What about any other ones? We have any other ways to show all of the use space of that partition? Could I do an ls block or block ID? Now, ls block is going to show us the full size of that partition. Block ID is going to show some other stuff, but I think ls block, if we do like a -help, I'm pretty sure there's some options. And one of them is maybe a -O, but let's see if we have, maybe -F. ls block -F will show us that. So ls block will show us that the file system is here. It's an ext4. It's mounted from cloud img root fs. That's its label. Here's its UUID. That can also be used inside of the system to mount it. And then there's all of our information. How much file systems available? 10.6 gigs. And then 45% is used on the root partition. So that's a pretty useful one. ls block -F can show us that. All right. How about, what's this next one? Whoops. Can you show us all the inodes? What the heck's an inode, right? What's an inode? Can we see the inodes of that? And then what are inodes? What the heck's an inode, right? So we've got these inodes. Can you show me all the inodes? Data, what's data? I never use that command. Never use that command. If that's a real command, well, this thing doesn't even see it as a command. I've never used it. But df-I will definitely show you that. So that's definitely what we want over on the YouTube side. So let's come back over here. So can you show all the inodes? Yes. And but what are inodes, right? If I take this and I say, here's my number of inodes free, and I happen to be still in the root file system, because I checked in the file system that I'm in, df-I dot shows that we're the same. And what if I were to just like touch? So I'm gonna show you guys something here. I can just touch a bunch of files, file, and I can say 1 to 10,000, right? And this should touch 1,000 files. And then if I do a df-I, you'll see that I have 10,000 less, right here where that 7 is, I have 10,000 less inodes free, because every one of those files is, even though it's empty, it's got a file descriptor that points to it. So inodes are file descriptors that point to locations in storage, and storage, and you can run out of them. You could fill them up on this system right here. Now that being said, I've never run out of inodes on a Linux box in all my career. But I have run out of inodes in storage area networking. So like big back-end storage area networks like GPFS, which is your general parallel file system, which is by IBM, and then it's in a bunch of high-performance compute. That's where I've run out of inodes before. Now, most file systems have a way for you to trade off some of your space to get more inodes, basically just more pointer locations, and GPFS is no exception. The problem is you just want to keep track of them, so if you're ever approaching most of your usage, in fact, in this case, we're only using about 8%, but you need to make sure that you're not running out of those in the file system. Not typically a thing on a Linux box, could be, but it's not typically. It is a big thing in storage area networking because you will have a lot of times with researchers and stuff, if you're doing big high performance compute, they will have many super tiny files. In fact, there'll be files that are so small that they're wasting space based on block size of the file system. But you can't, there's no helping that. They're researchers. They need to research whatever they're researching, and they need to pull it down in whatever formats they do. That being said, you do need to keep track of your inodes because that's the health of your cluster. It's something you can control, not something that other people did. Yeah, Malicious, I've seen questions. I've had people ask questions before in technical interviews where they're like, well, what if your space is good, but you still can't write any files? Inodes. But again, I've never in all my career seen it run out. I've seen people do it to be funny, like on a lab system just to mess around. We could fill this box up. We could write all, what is that, some number of millions? So is that 2.3 million? We could write all those and fill this up and see the behavior. It's just going to say no space left. The same thing as it says if you run out of actual space. So you'll just have a broken system at that point because it won't be able to do any more work against that file system. All right, so we did that. Good. Can you show all the used space currently in the directory you're in? What's that? One reason I like using ZFS dynamic node allocation. Yeah, ZFS is good. So I don't know if ZFS is the same thing that we used. Okay, let me back up. ZFS was a Solaris file system. I don't know if the ZFS that you're talking about and like the modern one is the same ZFS that came from Solaris or not. I'm not sure of that. But I do know that ZFS is not part. I know that there's some conflict between them and the Linux kernel where their support is not direct and native still. And I haven't looked that up in a while, but last I heard, the last thing I saw on that a few years back was Linus Torvalds was like very against ZFS support. du-sh is probably the best one. So I'm in this directory, du-sh, and the directory I'm in is dot. So I'm using some amount of size in here. And what if I just dd in file equals dev 0, out file is equal to, big file. And then block size is equal to 1024K and count is equal to 5,000. So we'll do a 5 gig file in here, right? We'll just make it right here. And if we then do our du-sh again, when that's done, we should see that. Use OpenZFS, which is derived. Okay, but the CDL license issue remains. Yeah, and I don't know much about it, the bread, but I just know that there's some stuff there. And then look, now we can see in the file system I'm in, we've created that big old file. Now, if we compare that to like if we did a df-h on dot, you would see that we're here. And then if you cd to like temp, you do a df-h, you'll see that, but if you do a du-sh in temp, you don't have all that stuff. So it's important to note because like sometimes people think, well, df will show you all the use space in the directory you're in, and it's like, well, no, it'll show you the mounted directory's overall space, but when you want to get to one little part of that big mounted directory, that's where you use your du. All right, so that's kind of an important distinction there because you might think, well, df-h shows the same thing, but du shows a different thing. When I'm in that directory, it only shows the space used in that directory. And then when I move to a temp directory or whatever, I've got a different space being used, which is accurate. So you need to know both of them for different reasons. Overall health of a system. right? Gotta do all this just to clean up the output of this. There we go. That's much more of what you're going to see on a normal file system right here, right? And then from here, you would be able to say, okay, the overall system seems healthy because I'm not at 100% on any of my, or I'm not approaching whatever my threshold is. That's a bit high. 71's a bit high, but that's nothing to warn on. Typically, we'll warn at like 85, 90, or some people do 85, 95. Just depends, right? So there's that. Okay, so we did that. Can you show us all the space du-sh dot, right? Can you show all the processes? This one's fun. So I'm in temp right now. Can you show me all the processes that are using the directory that I'm in? If I wanted to unmount an NFS share, let's say, but there were processes that are using the directory I'm in, I wouldn't be able to unmount that directory until all the processes were gone. So I'm in a directory, right? I'm in temp. Can I show all the processes that are being run in this directory right now? All the processes that are using this according to the Linux system. All right. This one is LSOF on temp. And if I look at temp has, well, LSOF is running in there, sure. And then there's bash. Wasn't bash the shell I'm in? Like if I echo $shell, I'm using bash. How would I know if that bash was me standing in the shell? It is, by the way. But how would I know that? Does anybody know that? Remember LSOF, but I don't know if it's installed by default. LSOF isn't always installed. It is on most Red Hat systems. What is this LSHW? That's a lot of information. I don't know if that's what we want here. Oh, that's a lot of information. All right. Let's not do that one. But if I do an LSOF on temp, it'll show me that. So let's go down here. I'm just taking my own notes, right? Can you show all processes in the file or in the directory you're in? LSOF, and then you could use dot, which would show this directory. So LSOF dot. And then I'm just asking a few questions. How would you know if that was your process? Hedge, you said, am I running a distro on your own? This distro is, this is pinned for the lab, and any of you guys can be in the same shell as me right here. This is a Ubuntu distro, right? Ubuntu 2004 LTS. So, no, I'm not running this on my own. I have my own stuff in my home lab, right? But that's not what we're working on, a lab where everybody can be in the same distro at the same time. So hopefully that makes that clear. So what about this? This bash shell, I know that I'm in that directory, but how do I prove that this is the shell that I'm in? Anybody know that one? When you echo $$ on any running process, you get the process ID of the process that's running. This is super useful in scripting. If you're running a script and you want to write a unique file or a unique directory, I think remember the PID and then see which bash would close on kill. Yeah. If I killed that PID, I would definitely kill this shell right here. That's true. So, but that's how I could see. And this is a thing, by the way, guys, like this happens in real file. You might say like, well, when would you ever use this? This happens pretty often, not really often, but somewhat often when you're working with a lot of dev teams and you've got like maybe a centralized node where they do something and you're like, okay, we have maintenance. Maintenance starts at 5. We've talked to everybody, you know, we've got our downtime. This is our normal window. We went through our CM, our configuration management, and maybe an ECB, which is an engineering change board, or our CAB, which is our configuration, configuration acceptance board. And we've got the business process side of things done. But now I go to do the work, and the work requires me to unmount an NFS share and remount it. But I do an LSOF on that share, and there's just a bunch of people that went home for the day, but they've still got bash shells into there. Happens all the time, guys. This is one of the most common things I can think of to tell you. So what we can do is we could kill all those process IDs. Now, I'm not going to actually do the kill, but I'll show you how I would normally kill them. Actually, this environment's almost dead, so I'll kill them. I think it'll just redo my shell. So this is what I would do to clear this up. I would do an LSOF on dot like this, and I would get the second line, the second column here, not line, the second column is the one that I want to be able to grab all of these processes. So I would go like this. I would say grep-v for PID. We don't want the PID along the top, right? We don't need that. And then what I need to do is I'll pipe out an awk for just the second value or the second column. Now we got them all. Now there's other things. These other things are showing up, so some of these are going to fail. But let's kill it. So then we'll say xargs kill -9 or whatever. So this will put, if I just do xargs, watch, it'll put them all on a line. So if you do an xargs kill, maybe even kill -9, it'll put all of those in the line right after your kill. So I'll kill all these processes. I'll kill this shell right now, just so you guys can see it. But what I did was I just constructed a command through doing these individual little pieces. Nothing super complex. You just saw me do each of the different pieces in each of the searches. So when I run this, just killed my shell. But I can reconnect, and then I'll have a new one. And if I want to see my new shell, there. If I want to do an ls-of dot, I can see, look at all these things that are in, where are we at here? We're in root's home. Look at all these other things. There's a KC terminal connected. There's all these other things. And I could do that same command again. I don't have it anymore, but I could do that same command again to kill all of those process IDs. Now, I sometimes do this with, so you do like a ps-ef, right? And you get all the users on the left. And I sometimes use this, like if I want to kill all these GDMs, whatever they are, I will sometimes use this. And you might say, but you can use pkill -u for the user, and pkill will kill everything from a user. And I say, yeah, but maybe I want to just make sure it's cleaned up. Maybe I want to make sure nothing from that user is there. And for that case, like let's say I wanted to kill root. If I killed root on this, I would kill this box. But I might do ps-ef, grep-i root, and then I would pipe it through my awk. And this time I want the first column, right? The first column right there, boom. And this will give me all of them. And then, sorry, I want the second column. What am I thinking? There's all my process IDs for the root user though, right? And then I would put them all on one line with xargs. And then I would kill them all if I wanted to. And if you killed this with a -9, this box would go down. We don't want to do that necessarily right now, but that's how you can like take a box down. I mean, you're already root at that point, so you're just being destructive for the purposes of being funny, but that's still how you would do it. All right, so you could show all the processes that are in a directory that you're in with LSOF-dot with dot, and that'll show you all of the open files that are touching a directory you're in. All right. Check the long listing of a bunch of these different directories. So you can do an ls-l to see the long listing. And these are, let's see, they're not all directories, but some of them are. So if they're directories, I want to do the D. So I'll do root temp. Because if you don't do the D, it won't be just for the directory. It'll be everything in the directory. So I want to see everything that's in here. And it won't hurt the other ones. There's shadow, passwd. And then what's this last one? Etsy ssh /config. And then what is x4 is xargs for appending the output to the end of a line. Malicious, what xargs does is it takes a list of arguments and it puts them on one line. So it's very useful for feeding things into a command that takes multiple arguments on one line. Whereas when each of those were like this, they were new line separated and only one of them could have been fed in. So we would have had to feed it over a loop individually, and that just would have been a hassle and a mess. So instead of doing that, You put them on one line and then you feed them as arguments after the command. That's all it is. Yep. So all xargs literally did when we checked it was this. It took a bunch of things that were going to be in a line like this, like in these are all they have new line characters on them. But then when we do the same thing with xargs, it strips the new line characters and puts them like that. So if I were to do xargs kill-9, kill-9 will take as many arguments as it can fit after it. There's probably a limit, 256 or 1024 or something, I don't know. But there's some limit to the number of arguments you can give it. But this would take all of those arguments and put it after the kill-9, and it would kill the whole system. This would murk the whole system right here. But this would show me, so I use this to show me everything. There's a one that I use very often like this. Some of you guys have seen me do this. I'll get all of the users, and then I'll go sort, so they're all sorted, and then I'll do a unique-c to count them. And these are all the things that are running on this box right now. Root has 153 processes, GDM has 1, and Avi has 1. That's all the stuff that's kind of going on right now. And Jacqueline, hopefully this stuff's useful to you. Thanks for the follow. We are just working through Linux and doing some basics, right? And we're almost done in this environment because we're gonna have to reset it. But we were just looking at, you do the root, you do the temp, you do the shadow, passwd, and then what was that last one I had there? And my question is if you look at those, do you know what all of these mean over here? And this is a question for you. This isn't a question for me. This is a question for you to think about. Do you know what all of these permissions mean? Do you know what it implies on the system? All right. So this one is check long listing of files. Do you know the permissions? And this one was D. Directory or file will work with the ls-ld. All right. So how about, let's just look at this top one, /root. So this is a directory. Now I know it's a directory because of the color here, but you don't always get the color inside of the systems. In fact, ls is being aliased. Let me show you this. If we do an alias, ls is actually being aliased to ls color auto like that. So what if I did unalias ls, and then I did that same command for root, just we're looking at root real quick. Now I don't get the color anymore. So now how do I know if this is a file or a directory? How would I know that? I don't get the color anymore. Not all operating systems you're going to find yourself on as a systems engineer are going to have colors. The D, yep. This D over here, this first little bit location tells you whether it's a file or a directory. If it's a dash, it's a regular file. If it's a D here, it's a directory. If it's an L, it's a symbolic link, right? There's a bunch of things it can be, but those are probably the most common ones. You'll probably see those ones 99% of the time. Yeah, the D over here at the beginning tells you that it's a directory. Good. Now, how about these? We call these octal permissions. Does anybody know what these octal permissions mean for the system? Most of you probably have seen them or heard of them, but if you haven't, it bears repeating and understanding. So you've got read, write, execute, and then you've got read, write, execute, and then you've got read, write, execute on these different systems. But what? And you've heard this said by people as 700. This is a 4, a 2, and a 1 in octal. So if you have a 4, a 2, and a 1, that's 7. So that's a 7. Then you don't have a 4, a 2, or a 1, so that's a 0. And then you don't have a 4, a 2, or 1, so that's a 0. So we could read all these permissions real quick knowing that. We would know that this is 700. This is 777. But it's also something special. It's got a T over here. This is 640. This is 644. And this is 644. All right. Okay, so, but how do we know what they map to? This is where some people fall off. We know the 644-700, we do all that. But did you know that this right here is the user owner permissions? So this is the user owner permissions. So the user has 7. The user is defined right here. That's the root owner of the file. This maps to this. This is the group permissions. 000 for read, write, and execute matches to the group owner. So it's UG, and then a lot of people will call this E or O. The E is everybody and O is others, and they're not defined. So everybody else or others have no permissions in this system to this directory here. To traverse a directory, you need at least X permissions. So to traverse a directory, you need like a 5. You need to be able to read the directory, and you need to traverse through the directory, and that will get you like you'll see all the permissions, and you'll be like, oh god, I know I've given them permissions all the way through, but some file in the path won't have traverse, and they won't be able to read all the way down. The users won't be able to traverse down into that directory. Yep. So you've got the owner here, the group, and everybody else. So you'll see them named different ways. And if you do like a chmod -- help, that should help you out. Or if you want to, and I am not a fan of this. This is the user, the group, and the others and all. I'm not a big fan of that. I just like doing my I'm an old curmudgeon. I like my 755s and my 70, whatever. But this is how you can use UGO with plus, minus, or equals. You can do all that stuff if you like. Yeah, user group rest is some way people think about it. Yep. Perfect. So there's all these ways to do this, but this is something that when you're first learning systems and getting into this, you have to get to visualizing these. And it's octal, so it's 421, 421, 421, and then you say, well, how is that working? Well, if 4 and 2 are on, but the 1 is off, that's 6. And if 4 is on, right here, 4 is on, but 2 and 1 are off, that's a 4. So this is a 644, 640 permissions, 640, right? And that's how you do it. So it takes a little while, but as you get into doing systems and you're playing with it hands-on, you're gonna get these things, okay? So for people that came a little later, or I just got back from break, we're doing the Socratic Method. I've added a bunch of questions to this that are coming up here, and we're just taking notes. I said get a notepad out and let's do it. Like let's figure some of this stuff out, because I'm really convinced that if you've never like sat down and worked through some of these with somebody, some of this can be daunting. But then as you start to do it, you're like, oh, well, I could know all this about my system. That once I know these things about my system, I can go ask Google about it, because I know the version I'm on, I know the hardware I'm on. All these different things start to give you a lot of confidence of what manuals, because we're always talking about reading the field manual, right? Well, I don't even know what to read. I've never even touched this system before. But now we can start to ask the right questions and get the places that we need to kind of get to. All right. So let's keep going. Can you remount the temp as read-only? On this system, I don't think we can. But let's do a mount grep-i for temp. And, well, that's not great. Temp, so I do a df-h on temp. And I see that it's just mounted off the root file system. So if I had a disk, if I had extra space, let's see, PVS, VGS, LVS. Yeah, so we don't have any of that stuff going on. We don't have any space to make another directory and then mount temp to it. So we can't remount temp as read-only in this case. But if we were in a different box, like one of my home lab boxes, and I did a df-h on temp, temp is in the root of the file system, but I should be able to make a new directory if I had space. Okay, so I do have space. I could carve a new file system for temp, and then I could mount temp on that file system, right? If we wanted to do that. But yeah, we could, and then we could remount temp as read only, right? You don't tend to mount temp as read only, but one thing you do a lot is you will mount temp as no exec, and meaning that anything that lands in temp can't, because temp is a world writable file system in most Linux. You don't want things to be able to be executed out of there. Let me show you. Let me pull something up here real quick. I think I have. Yeah, hold on. Let me get my CIS. Wait, are we on 2004 over here? Yeah. Yeah, we're on 2004. So here, it's perfect. Here's my Linux benchmarks. So if you've never seen the CIS benchmarks, they're free. You can go download them off the internet. You do have to give them your email, so that's kind of annoying. But they will send you the benchmarks. You can download all of them. There's a whole bunch of CIS benchmarks. And what the CIS benchmarks are they're from cissecurity.org. They're maintained by, I think NIST is involved with them, but you can go read about it. And what they do is they give you these set of guidelines to how your system should be set up. So we can look down here, and we have to have no dev and no exec set on the temp partition. So I go right here, and what does that mean? If you just take everything away for a second and think about it, if I have to set no exec on the temp partition, that assumes temp is on its own partition, doesn't it? Yes, it does. Because you can't have it just set against, you can't have no exec set on the root of the system. Linux wouldn't work anymore because it can't exec anymore from its, that wouldn't even make any sense to have no exec on root. So that assumes that this is off on its own partition. And that's one of the places that's kind of the rub for a lot of us. Like in modern operating systems, I don't care about the local file system. That thing can go today. I don't care. I'm going to build a new system. I'm going to deploy it in a virtual machine in under 5 minutes, right? So if that's the case, a lot of us push back on our security teams, and a lot of us push back in general and go, look, let's not do this stuff anymore. Because, and by the way, some of these things break different applications. So having no exec set on temp, you always have to turn it back on so that you can install Oracle. And you say, really? Yeah, Oracle must run its installer out of temp on a system. And you say, really? No, that's not true. Yep, it needs a user grid in Oracle, and they need to be able to write into temp. Your script will not work otherwise. And you say, well, can't you go in and modify the script? Going in and modifying a vendor script will immediately void any warranty you have, 1. 2, they're going to tell you not to do it and probably call you a dummy because that's Oracle for you, right? And 3, it's just easier than you shouldn't. In my mind, I'm not going to go muck around with somebody else's couple, maybe even 10,000 line bash script. It's not the way I want to spend my month, right? That sounds terrible. So anyway, so my point in showing you guys all that is sometimes you have to set these things for security reasons. Sometimes you have to get exceptions. But one of the most important things when you deal with your security teams is you can explain why something should or shouldn't be there, right? So you might say, well, Scott, why do you have the CIS controls? Well, because I build servers all the time. So I have the CIS controls here. I have them professionally at work. And then if I have to build a certain type of server, I can come in here and do this. Also, I've written audits for these. They're up in my GitHub. But I've written audits for these in Ubuntu with Ansible. So Ansible will go audit all this stuff for me. All right. Anyways, that's neither here nor there. So can you remount it? Not in the lab, we can't. But can you list the number of free inodes in root? We already did that earlier, so that's fine. I don't think we need to do that one again. Can you touch temp test file and hard link to that file 3 times? So I'm going to touch cd to temp. We don't need to be in temp, but touch temp test file. And then it says to hard link as opposed to soft link to that file 3 times. So maybe I link other, just do it full. Temp test file to temp other file 1, and then other file 2, and other file 3. And then if we do an ls-l on temp test file, we'll see that it's got these 4 hard links to it. Those are 4 different inodes pointing to the same memory location. So if I echo this is a test into temp other file 3, but then I cat temp test file, which you just saw me make with nothing in it, it'll go in there. Is it a soft link or a hard link that you can? So hard links cannot link across to a different file system. Soft links can link to any mounted directories or any of those kind of things. But hard links are always limited because it's an actual inode pointer. So watch this. I'm going to remove rm. Actually, I'll unlink it. Unlink temp test file. So now it's gone. But if I do an ls-l on temp, whoops. I don't know what I just did there. ls-l on temp other file, I'll see 3 hard links into it because now test file's gone. And also that ls-l on temp test file no longer exists. Unlinking and removing are very similar steps. In fact, to make a file with the actual memory location no longer accessible by a Linux operating system, all you have to do is unlink everything to it. Once you've unlinked everything to it, there's no way to get it back without some type of, if you know where it's at and you can remake a pointer to it, but you need specialized tools for that. There's forensics tools that'll do that, and that file is still sitting out there on the memory in the disk until you rewrite over it with the new file over that location, which is one of the reasons why scrubbers are so important. If you're gonna do something with a disk other than putting a screwdriver blade through it, like we used to do, we used to actually break and chip up our disks back in the day. You want to do that. So yeah, could you make that, and could you link a bunch of files to it? Yes. So over here, so we ran out of our lab time there. So can you create 3 hard link to a file? Yes. ln something to some other file, and then ls-l will show it. All right. So look, we've been through the lab. We've burned 2 hours worth of labs already because we've had to restart this twice now. The labs are linked for you guys on both sides, so I'll let that come back up. And then we're going to keep asking questions. Oh, here's the question then. Can you hard link to a file across a file system boundary? To a file across file system boundary. And the answer to that is no. You cannot do that. There you go. Yeah, that's fair, Inspector. It doesn't clean up until you kill. That actually becomes important, and that's why we no-hup and log rotate. Because if you don't kill the process and it's still trying to write to a file, then it will keep the memory or the disk space allocated. That's fair. Okay, so I'm going to open this up and make this a little bigger. We're not actually doing that lab. We're just sitting in the lab. But can you hard link? And this was no. So what's our next question? Can you cat out the contents of a file that defines all the mount points in the system? This one's kind of tricky. There's 2 answers here that I think you can accept as an engineer. But cat out the file that defines mount points in the system. What are the files that I would be looking for here? Does anybody know? There's a way to, so this is, we're asking ourselves questions as engineers. Can we cat out the contents of the file that defines mount points in the system? And there's 2 ways to read this. There's the way that I think most people probably read it, and then there's the literalist way. The literalist way is not the same answer as the other one. So what defines all the things that should be mounted as the system comes up? etcfs step, right? And that is all of the mounts that should be mounted by the file system as it comes up, right? But there's a different answer to this. Does anybody know? So if you type in mount, word count -l, there's 74 things that are shown as being mounted on this system right here, right? ls block will show me the devices that are there, the block devices that are there, so that's useful. But how do I know where the things are mounted on the system? Now, mount is reading, I'll give you a hint. Mount is reading this file. So if you go read the man pages on mount real quick, somebody could tell me where that is. Proc mounts. That's got some stuff in there. That's pretty good. How about your Etsy M tab? Did you guys know that Etsy M tab, and look, Etsy M tab is actually pointed to proc self mounts. So there you go. But Etsy M tab is where the mount command reads from. Did you guys know that? Yeah, ls Etsy M tab, and M tab is M tab is what the mount command actually goes and reads. And then look, you can see this is where it's so important to understand linking. There's a soft link over to proc self mounts. So now that's where the kernel's actually looking. But then this is Etsy M tab that you're using to look at that, right? But then when we're looking at it here and we see Etsy M tab, that's as best we ever will probably need as systems administrators and engineers. That's going to give us what's mounted on the system. Now, if you ever VI that file, so man mount and then M tab, it says it typically. It says it in here. Do not go edit this file directly. It'll say it in here somewhere typically. All right, so anyways, there's good info there, right? There's good. This is one of these things where you ask a question, then you go spin up and go in as deep as you need. But you can see that you can either do Etsy FS tab, and that shows what should be mounted. But then once the system comes up, and in this case, Containerd started and Kubernetes started and all these other things started happening, there were all these other things that were mounted. Hey, Colkiss, how's it going? We are just going through labs on Sunday mornings. We always do labs on Sunday mornings. And we're doing notes. So showing you guys that, we keep notes of all this stuff. And then we're just asking ourselves a bunch of questions, doing kind of the Socratic method again. Because I'm just, I do a lot of different stuff on here. You guys see me like kind of go technical sometimes, kind of go in the home lab sometimes. But I'm really convinced that people want the basics. I think that especially getting the confidence to go do this stuff professionally, I think that the basics are maybe the thing that people need the most. So I'm like that Family Guy episode. It's what the people give the people what they want, right? Like trying to do that. All right, so yeah, we don't change Etsy M tab directly. You use mount commands to do that. The basics are definitely, well, I think everything I do stems from the basics. So I don't. I tell people all the time, like what I do. Like the managers and other engineers tend to think I'm just casting spells, but I'm doing very simple things. I'm just very used to doing them. All right. This one's fun. Can you tell me? Can you do a test of your write speed to the file system and a read speed from your file system? Some of us have been here like recently, even when I was doing some of these tests. But can you test the write speed and the read speed? Let's do a few tests. Let's say for I is a common counting variable in computer science. And let's just do, we've got 11 gigs available. So let's say for I in, and then we'll do it this way. Sequence 5. So this is going to do 1, 2, 3, 4, 5. It's just going to put those on the line there. And then I in the first iteration of this loop will be 1, and then it'll be 2, then it'll be 3, then it'll be 4, then it'll be 5. Right? We're going to say do. And then we could say echo, I am checking, I am writing $i file, right? And you can do that and boom. But we haven't done any work yet. We're going to add the work right here. This is one of the things about loops is that you can do any work between the do and the done that you want as long as you just keep setting them correctly, right? Set it up. So in here I'm going to say dd in file is equal to dev0. We don't want the processor doing any work. Just give me zeros. Out file is equal to, we could just do big file $i, so it'll be 1, 2, 3, 4, 5. and then we'll say block size is equal to, let's give it, I always do, when I do file system tests across storage area networks, I always have a small read, a medium size read, or exactly what the block size is of the file system, and then a large read. Let's do what I think, so this will be a 4 meg file, 4096K. And I think I'm not sure the block size of what we're in, but we'll figure it out. And then the count for this, we'll do, so it'll be 4 meg, so we'll do, let's do 250. All right, so the count will be 250 4 meg files, and that'll make files of some size. And then we can see how long it takes for this file system. It's going to write them out sequentially. One of the things I also like to do, DD will give you a pretty good time, but you can wrap it in your time command. So here's the command. I'm gonna hit it. If any of you are doing it with me, you can do the command right there if you're doing it in the lab. And it says that, okay, so here's our output. We wrote a 1 gig file, approximately 1 gig file, actually exactly 1 gig file. And it was at about 540, 589, 602, 598. I'd say that averaged about 570. And you could, you can throw that in a calculator and do the actual average if you wanted to, right? That's up to you. But the point is, we have now some data about how fast PowerPoint's in Discord. This PowerPoint's in Discord, but I've been updating it, so I might have to. It's called the Socratic Method. Socratic Method for Linux. There's an older version of this one up there. I keep adding questions to it every time I do it again. So there's actually a whole bunch more questions that are new coming up. Like there's some Docker ones. There's some other stuff. Just it's all file system. It's all things that we run into as systems engineers. So all right, so we wrote it out. So that's probably about what our file system. By the way, that's what we found out the other day. That's about what our file system writes at. But what does it read at? So I come over here. And I'm going to do the same thing. I'm going to read that file now. By the way, this is just text, so you don't have to change this. I am reading the file, but that's fine. And you could change it around file 1 or whatever, but it doesn't matter. Now the in file, in file is going to be big file. And we don't need the block size or the count anymore because it's going to know those. And then where are we putting it? Out file, we're just going to throw it in the trash. But we still have to read the whole thing. We still have to read it out of the disk and into memory for this to work. We're not going to do anything else crazy to it. We're just going to time it and see how long it takes to read that data out of the file system. So that's a 1 gig file for each of these, and we're reading it out and then just throwing it away. And we found this out the other day. We don't read from our file system here in this virtual space nearly as fast as we write to it. Look at that. Say we're averaging about 190 right now. Yeah, mid 190s megabytes per second. All right. So could we test the read and the write speed to the file system? That was the question, and the answer is yes. And you will see faster speeds on like an SSD than you will on a virtualized disk that's back-ended to whatever, and then let's say you've got a file system requirement to be able to write up the the batched up reports within a certain amount of time, and you know that the batch reports take 40 minutes to run, and then you know that you're going to have X amount of gigs of data, and then the question is, do I have enough time to push the data within my maybe 1 hour or 2 hour SLA? And these are the kind of things that we can't answer when all we're doing is sitting here looking. You guys think I'm making this up, but if you're just sitting here looking at a black background with white or green letters, I don't know if I can do it in time. I don't know if the batch jobs will get done in time. I don't even know. I don't even know where to start. Well, to start, test your individual components and start doing some math, right? And the math it's simple. Let's pull up a calculator and start doing some basic things. How long is it going to take me to push 100 gigs across that, right? Now, granted, we're not going over a line right now. We're just writing to a local disk. But maybe that local disk is then pulled via NFS or Samba Share or whatever. There's all kinds of stuff. Oh, did you find it, Doc? Yeah, it's a little bit older version of it, but it's the same basic concepts. And I'm writing notes on this as we go now, too. So speed tests, tests of writes and writes, not writs and reads. History. There we go. We're writing and we're reading. We don't need that. There we go. All right. So there's our speed tests. What's our next question? Networking topics. All right. So we're over to networking. We've been doing this for 2.5 hours, but we're asking ourselves questions. We're figuring out, like, what do we know about the system? We're doing, again, like a Socratic method where we ask ourselves things and we're figuring out if we know. The community's helping, and in general, we're just, working through this stuff. So the first question, can you show all the interfaces on your system? What are all the interfaces that your system has to some type of network? What do you guys got? How about IP adder? Those are all the network interfaces on the system. IPA, there you go. Yeah, so can you show all the interfaces? IPA, IP adder, right? They're basically the same command. How about if config works if you have it? If config is on this box, it's funny, it's not always there, but it is on the box right now. If config will do it. Yeah, I think we can show all the interfaces that are there. There's also, I want to say, you might be able to get away with, is there another one? I like that. That's a fair one. IPBRA. There you go. I actually like that. That one shows just the type of networking, and you see some of those addresses are in IPv4 and some of those are in IPv6 space, so that's useful. Now, so those are all good. We did that by configuring NFS share speed and disk speed. Doc, we did that the other day in this one where we were doing the writes. We were just simply writing to our local disk here. The ones that I was doing there, I was just writing to my local disk, but I could go and do that write against anywhere. All I would do is change the out file, and if I had a Samba share or an NFS share or any type of share in all the world, I could definitely have that pop up right there. So yeah, so hopefully that answers that. Can we show all the interfaces? Yes. All right, let's get in here and let's muck around a little bit. Can you show the interfaces that are physically connected? So this one is, how do I know that any of these are up or down? And when I say physically connected, IP adder, and when I say physically connected, I mean if this were a physical box and this were the main device, which it happens to be, what we used to have to do is go in the data center and look and see if the cable was physically plugged in and if it was green or yellow coming out of the back, right? If it was a steady light or if it was processing data, you could tell that by going and looking at that. But this is a virtual machine, so I can't go and see if the physical interface is connected anymore. So how do I check that on like a virtual machine like this? How do I know that some new interface is actually physically connected? How would I know that? So we have nmcli con show. If nmcli is there, that would work. What about this one? IW config. Yeah, I guess if it's a wireless connection, IW config might work. But we don't have wireless on this. How about this one? ETH tool ENP1S0. How about that? And right at the end, look at that last little line. Link detected, yes. That command right there, ETH tool with whatever the interface, and then looking for link detected, yes. That's been one of my like most critically useful commands. Not having to go and get into data centers and go like walk across the campus to go get in an actual skiff and that kind of stuff of all my career. This right here. Being able to find that the link is detected on some secondary or SAN interface that I have connected up. That's it right there. That one's huge. Yeah, I want to know that it's connected. Well, so here's the thing. Can we know? I need to put I need a space. There's this really annoying thing. I don't know why. Whoever made the UI for super annoying. But the UI over on the YouTube side, there's a question, and I literally can't read it because there's a fucking heart in the way. I can't see the command. It's super annoying. All right, anyways, we want to know the internet speed from the Linux machine. Thanks. Yeah, we can, Sandeep, I have a bunch of methods for testing the speed, but typically to test the speed, you have to control both sides to get the full speed because you need something to bounce off of. And I show that in one of the other labs. I show iPerf, the tool iPerf 3. But anyway, so we have this connected physically. We can see with ETH tool, ENP1S0, right? Boom, there you go. All right, so we see that's connected physically. Can you determine your default route? So you're on this IP adder. How do you know the routes that your system is going to send traffic? How are you going to know? So the kernel has TCP/IP embedded, right? And that TCP/IP is going to send things a bunch of different ways. And how is it going to do that? So I agree. It's IPR. Yeah, that heart is super annoying because it's squished down on my screen. I have 3 monitors here, and on that one, it's just right in the way of whatever people have said. So it's super annoying. I don't know who was like, hey, this is an excellent place. No words are ever gonna go across there. It would be like if I did this right here, guys. This is what it looks like when I look up there. It looks like this right here. Hold on. It looks like this right here. Wouldn't that be annoying if I was doing like closed captioning, but then I had this thing in front of it? That's what it feels like. This stupid heart's like right in the way. Stupid little heart thing. All right. But see, I moved that out of the way so now you guys can see. Okay. Yeah, IPR. The IP route is going to give us route. Let's see if route does it. Oh, whoops, not route. Route. Route also gives you some good information. So IPR and route are really just different ways to look at the same type of information. And I like that. I might lean, as a person who's been doing Cisco for 22 years, I might lean towards the route command as looking a little cleaner. But I use IPR all the time. And the only reason I use IPR is because I just want that default. When I see default, I know that I have what's called a gateway of last resort, a default gateway, a gateway, whatever you want to call it. IPR gives us the command. Yeah, actually that's useful because IPR is very close to the command that you actually put in to change those, which is nice. Yeah, so you're adding or removing the IP command. That's exactly right. Yep. So let's see. Can you determine the default route? IPR or route. Both of those are excellent options, and both of those show us a bunch of information. So if I didn't know. I think I've known about the default, just the route command over the years, but I always forget it. But that's really awesome. You see the actual kernel IP routing table, which is so similar to show IP route inside of Linux or Cisco. We do our show IP route, and or SHIP route, right? Oh my gosh, closed captioning. Closed captioning does fantastically bad against engineering topics. Just fantastically bad. It does pretty good around normal stuff. We were just sitting here talking, but like if I start doing 172.30.1.1, it'll just be like, I don't know what he's doing. It's close. It's close, but it's not good. So I probably should turn that stuff off when I talk networking. All right. So looking at those, if I did something like this, if I did a host for www.google.com, or I did an NS lookup of www.google.com, or I did a dig of www.google.com, which are, by the way, all ways to go find out information about where Google is. And then we looked at those values and we compared them to route. So look, we've got the authoritative answer of it's 172.217. If we came down here and looked at the destination, where do you guys think that we're gonna route to from this box to get to Google? I haven't pinged Google. I haven't seen if I can talk to Google right now. I've just looked at where my system is resolving via DNS to find Google, which is this 172.217, and then it coming down here. And how is it going to figure out where it can map? Traceroute would work for that. Yeah, SOAR. Traceroute's useful for seeing how things hop, sure. There's also a lot of things that'll be blocked out in the world. I have two default routes I select between them by source address with IP rule. It's really ugly. As long as it works. So if nobody's ever shown you guys this is the we can go real deep in IP subnetting. Some of you guys have been around and you know that I can take I'll take a subnet all the way apart if you guys want. But we don't want to do that right now. None of you guys are like, I'm going to go from Linux to networking. This guy, he bamboozled me, right? He swindled me and switched me over to networking. Suffice it to say that whatever the mask is over here is just a mapping of bits that are almost like a platform. And you can think of this as, these are all ones. So this is all 8 bits and this is all 8 bits. So you can think of it as, hold on, you can think of it like this. If this were going to match this, it would have to do so perfectly in the first 2 octets. So, real quick looking at this. Does 172.217 match perfectly in the first 2 octets 172.17? That's a big fat no, guys. It doesn't. Now, how about 172.30? Does it at 172.30.1? So this has to match 172.30.1. Does that match? It matches the first one, 172, but then it diverges greatly. So these two are out. They are not the route it's going to go. And then look at this. It has to map perfectly for these two. It's got to be all the bit places have to be the same. Nope, not going to match. So these guys are all out for how this is going to route. And then flannel is the same thing. It's going to be 192.168.1. That doesn't match, so it's no good. So if this doesn't match any, and you don't have a default route, this gets dropped on the floor, and you're an idiot. No, I'm just kidding. But your router, the internal route table doesn't know what to do with it, and all routers, all IP layer 3 devices for networking just drop things if they don't know what to do with them, unless they've got a default gateway. So anything else that didn't match any of those other rules is going to go there. So it's going to go out our default gateway. Our default gateway is going to be our interface ENP1S0. It's going to go hit 172.30.1.1, which is our router internal to this network. That thing is going to have to deal with it, getting it out to Google, and then getting it back to us. So we can test that real quick. This is one of the reasons why every network engineer any of you have ever met, when you say you can't get to something, you can almost just hear them in the background typing, ping whatever you just said. Ping www.google.com. We can ping it. But on my side of it, on the on the Linux part that I control, I know that I sent it out this interface right here, and I sent it to right there. Everything else, I don't know. Yeah, flannel is a an interface for K8s. Yeah. Yep. And these are newer. They were added later. Where'd that go? IPA. Yeah. So it's actually funny, in these newer ones, they're using flannel and calico. So they're using two CNI container network interfaces inside of Kubernetes, right? Yeah. Browser send me an ICMP no route message if it can't find me a route. Yeah. So we got that. So can you determine the default route? We could. And then let's keep going. Can you ping the default gateway 3 times? So let me clear that up again and we'll do our route. What's our default gateway here? Ping-C3 172.30.1.1. That's our next hop, right? Can we ping it 3 times? Yes. So can you ping the default gateway 3 times? And that is ping-C3 172.30.1.1. We did it, right? But here's the thing. If you're ever troubleshooting like a system and you're like, okay, well, I can see the default gateway. I can ping the default gateway, so I'm getting that next hop. One of the things that's super useful, and I've already done this, but I want to show you guys, is I love to like dig Google. Or you can even try to ping Google if you want. And what will happen if you ping -C1 Google? What'll happen here is, even if this didn't come back, even if this failed, what do you know if you go to ping something by name and you get this? What does that mean to you? I mean, just think about this for a second from like a system standpoint. You told the system to go to a place called Google. Google didn't, or your system didn't know what Google was. Your system went through the whole process of DNS resolution and brought back a response. So if I was on a network and my device had been working and doing all this talking to the internet, and then I came in one morning and everybody was like, oh, shit's hit the fan, everything's busted, I can't talk anymore. But I can still resolve. So I can still resolve. This is all the way up to application layer, DNS, and coming back down. I'm getting all this talking through DNS. Yeah, you guys are right. We're resolving, right? That means something else is probably stopping me from just pinging or just doing that other thing. So at that case, I'm going to start looking for network changes that have happened. I'm always going to check, see if my box is rebooted. I'm going to see if things on my side could be blocking me. Are we running IP tables still? Are we running NF tables? Something could be happening on a box. But I'm going to start digging into networking related concepts, because I'm still doing full stack all the way up to application layer and back down resolution of a name. That is not going to happen without something else probably affecting us. And then I'm going to start to walk the system. Like we just said, I will ping the default gateway. Can I still get to my default gateway? My traffic is flowing internally the way I expect. I don't control anything past my Linux servers, right? So what I start to do is, what if DNS is cached fair? Then that is something that you probably want to make sure that you wipe your DNS cache. There's DNS cache commands we could look up inside. I think there's all kinds of things, but yeah, that could be it too. It could be that DNS is cached, but something else is busted, and that's why I'm going to start doing my pings and see where my connectivity gets to. So I'm not being prescriptive about how we do any of this stuff, guys. I'm just telling you there's all kinds of things we can know about a system when we're on the system doing basic commands. Okay. Air disabled stuff at work the other day. Interesting. Yeah, I've seen problems. I mean, with interfaces, sometimes when things just work, people ignore any little errors or whatever. Ghost, your network engineer, you do this every day. Ghost, I bet people have called you and said they can't reach a box, and you ping it and then hang up on them, because that's what most network engineers do. All right, so we can default gateway. Can you determine the MTU, the maximum transmission unit of a network? So let's clear the screen. Let's do our IP adder. We know that this is our default network right here. And it says, can you, the MTU of the network with ping. And we can say IP adder to see MTU. Does everybody see the MTU there? Maximum transmission unit? And what does the maximum transmission unit mean? Does anybody know? It means including the header and the footer, the maximum number of bytes that you can have in a layer 2 data frame. Ethernet 2 by default has a frame that can not be bigger than 1500 bytes. That includes the header and the footer on it, which is about, I think, like 28 bytes. So that leaves you with a payload of like 1470 or something, 14 something of traffic. But can we determine the MTU with ping? Can we find out how big are jumbo frames? They can be 9,000 or 18,000 typically. Jumbo, or sometimes people call them, jumbo frames, or it's another name for them. But they can be bigger. But how can we test this from our box? Does anybody know? Anybody here ever played with this? Some of you may have seen me do this before, but can we test? And there's a tool within Ping. Or a part of Ping. Watch this. We're going to ping, and we can't use Google anymore because Google, once you start sending funky stuff to Google, it doesn't respond anymore. So we're going to ping. We'll do a -C1, so we'll just do 1. And we're going to do a size of 1500 bytes. And we're going to send that to www.yahoo.com. And that's going to go. So this is interesting, Inspector. The link MTU is obviously this hop, but the whole path is what I want to test. And I can test the whole path with my method. But I won't know where it's broken, but I will know that it's broken. And this is how I found this out, is I used to do this for my storage area networks to make sure I was getting my jumbo frames the whole way. So check this out. That just worked. And you might look at that and go, well, Scott, hold on. You just said that if it was coming down the stack and ICMP happens at the network layer, so that's layer 3, and you said it was 1500 bytes, but that's not going to fit down in that frame. You can't fit it down in that frame. And I say, you're correct. So what has to happen for IP to talk to the data link layer with a maximum transmission unit of 1500 bytes, but with a header and a footer, that 1500 byte ICMP packet just got cut in half and put in 2 different Ethernet frames. That's what had to happen right there for this to work. Now you can't see that right here, but there was a fragment. We had to fragment that packet down into 2 pieces for 2 Ethernet destination frames to get across there. But watch what happens now. We're going to set the -M to do. This is super weird. You can go read about it if you want. But we are setting do set the don't fragment bit. So M stands for the permutation bit. And we are saying do set the don't fragment bit of 1500 bytes. So now as this thing comes down through the layers and it's at ICMP, which is the network layer, right? We're going to go down to go to the frame, and the frame is going to try to cut it, and it's going to say fragile. It's going to say fragile on it, and you can't cut it. And watch this. It's going to break. So I just verified that my link is not set. Well, we already knew because it says MTU right there. But I just verified that I can't do that. But what I used to do is I used to get I would have like multiple hops to get back to my storage area network across my fiber channel Ethernet. And my storage guys, or not my storage guys, my network guys would be telling me, hey, and when I say network guys, I did everything, but I tended to focus on the Linux side when I worked at Lockheed Martin years ago. And my storage, or the network guys that set the network up for me, they would tell me you've got jumbo frames the whole way. And I'd say, okay, cool. And then I would do this, and I would walk from, I would walk from like 1450 up to like 9,000, and I would lose all my traffic because I'm saying don't fragment it down. And it would always work on my side. My connection looked like I had my jumbo frame set. This said 9,000 on mine, right? It was set, and that's what the storage required. But somewhere along the path, it was busted. And I proved it, and I sent it to them, and I'm like, guys. And they're like, oh, hold on. Oh, no, sorry, it's going this other way. That link's not set right. And then it immediately worked. But this is the thing that we have to do. We, as engineers, we run into things where you just have to know how to use your tools, right? and you have to test assumptions, and you have to prove things to yourself, and then you have to write out the things that you prove, and verify they work, so that, you know, I mean, you're not trying to point the finger at anybody. You're just trying to say, like, hey, this is not, I'm not getting the expected behavior. I'm not getting the promised service level agreement or whatever thing I'm expecting to get from the service that you're providing for me, right? And in IT, we're all providing a service to somebody else. Most of the time, I'm providing my Linux engineering, like my platform engineering and my build services, to my dev teams. That tends to be where I go. I don't ever deal with outside customers. I am 99.5% of the time all internal. I'm always dealing with my internal group of sys engineers and devs. I have like hundreds of dev teams. Nowadays, I work on the high performance compute, so I work with a lot of researchers. But even then, the researchers come into our RCDS team, and those guys handle a lot of the dealing with them and retraining them. And I just keep the system all platform stable, you know, keeping everything running. It's like the routers that silently drop my packet. Yeah, Inspector, that's a thing out on the web. We mostly don't respond to anything external anymore. All right, so can you determine the maximum transmission unit of the network with ping? Sure can. You can see where it won't chop anymore. All right, thanks for the follow, by the way, Suraj W. And you can see Ranger there not being impressed with us. It's an old GIF of Ranger that I made. Can you properly identify all your IPv4 and IPv6 networks? Ooh, so can you? And this is a similar command to all of our other ones. IP adder will do this. But when you look at those, are some of those running? Here's a critical thinking thing. Are some of those running both IPv4 and IPv6, and how are they doing that? Let's go check on Ranger. We got a Ranger check. There's Ranger. Also, I think it's supposed to get to 100 and... How hot is it now? It's 94 in Phoenix right now. It's supposed to get to 104, I think, today. What did we get there? Hold on. So there's our Ranger check. There you go. Look at him. All squished with his head. He's an old dog. Squished. IPA grep up. I think that's good, but that strips out our IPv4 or IPv6 information. That information's down here, right? So on this one, so this would be a question. Which interfaces of the... So we've got interfaces up there that are using... Actually, we have... Let me ask you this. So can you identify all of them? And one... So IPv4, IPv6, or both? Can you guys see that some of them are both, and some of them are only one? And let's say which one of those up there is only... So we did IP adder, and then what was only IPv4? Which one up there only has an IPv4 address only? Which one has only an IPv6? Yeah, I think that one was actually probably one of the best ones. That BR one, that one probably had some of the best output for this. Yeah, look at that. That's clean. That's super clean. And that answers the question immediately. Because look over here. The Docker, and so the ones that only have IPv4, whoops, they are that and Docker. Those are only IPv4 addresses right there. IPv6 only is my Calico, right? And then both are my loopback. So my loopback's doing both, and my flannel. So if somebody were to ask you in this, and they said, hey, I see that you're running both flannel and Calico for your CNI for your Kubernetes. One of the things I noticed is your cluster is running only IPv4. Which of those CNI interfaces is running all of your IPv4 stuff? And if you look at that, knowing that only flannel and calico, there's 3 interfaces there. Which one of those has to be running the IPv4 interfaces? Which one of those has to be maintaining that part of it? The only one that can possibly do it is flannel, because it's the other two are only dealing in IPv6. Does that make sense? So, hold on. Hold on. All right, it's back. Sometimes my closed captioning dies after so many hours, so let's get the system back up. Hold on. But do you guys see what we just did there? Here we go. Whoops, wrong one. Where's this? All right, but do you guys see what I'm talking about there? We can see which ones, and then we would know which ones are doing what. So sometimes that's important to know, like what's actually happening in our system. So there we go. Can you list your open ports? We should have a lot of these. We should have can you list your open ports? What open ports do we got on this box? This little server, this little thing's doing all kinds of stuff. What's it doing? Who knows what it's doing? Netstat, if we got netstat. I don't know if we have netstat on here. We do have netstat. Boom. Netstat will show us what's listening. So netstat's fine. I always use NTULP, but that's fine. Any of them will work. How about SS? Yep. I also use SS-NTULP. Okay. Or T. Right? Boom. There's a lot of stuff listening on this box. Okay. Dash tuna. Boom. That kind of compresses it down. And all of your options are going to give you different things, right? Man, look at all these. So many things that will help you to figure stuff out. What about if you wanted to list a very specific open port? What if you wanted to check, like what if you wanted to list everything about like an open port? Like you knew 22 was open. I knew that 22 was open, but I wanted to know, yeah. LSOF-I 22. That's what I do. Dash P should be process, I think. So if I knew it was 735, that would be the process, and then that would give me the information. So the LSOF-I and then the colon port number is what I normally use. But once I know a process ID with a dash P, I can go look at what everything that process is using. Does that make sense? I don't know if the dash P will work with a port. Yeah, so that goes to compact D, which is some other thing, right? But this will give you the PIDs, and then you can get the PID for this. Clear as mud? Good, right? But this does show me that this is listening on a certain port, so that's good. All right, so there we go. There's a lot of things about our system that we can see. We can see how and what are these ports? You've got all the TCP ports and all the UDP ports. They are mapped between 0 and 65,535, so it's 2 to the power of 16. It's 0 to 65,535, right? So the TCP side and the UDP side can both be open or they can both be closed. But these are all the places you can think of your ship, or you can think of your your server as an island if you want. And these are every port that can be connected to by anybody good or bad that wants to come and land on your little island. That's every one of them. You ever hear somebody say, oh, I cracked in on a port that wasn't open? That's not true. Never once happened. Not in the history of TCP IP. So if you got compromised, it's probably on a service that was open. Maybe the service was supposed to be open and you were running an old version of it, or it was a 0-day vulnerability, or you didn't have layered security, or. There's a million different ors that can happen, right? But for us, what we can do as we're building servers and thinking blue team, because everybody plays blue. If you're not playing red, you know if you're playing red, guys. You know. You're attacking stuff. Everybody else is playing blue. We're defending. So those of us that are playing blue, what can we do to make this system more secure? Well, hell, I'm not using etcd right now. Why is any of that stuff open? Dopar, I'm writing these up now. I'm writing these up in a little notepad, and I'm going to drop them up in our Discord after. But no, like this, a lot of this stuff, Dopar, I want you to. The goal of this is to get you guys. Well, one, you can take your own notes, but I'm going to send these up to Discord so you have them. But two, like much more than that is just practicing these with me, because you can be in. This is linked right here. You guys can drop in the same environment as me right now, free online, on Killer Coda. I just reset it, but you could be in the same exact environment as me, and you could be doing the exact same commands that I'm typing out and chat's typing out and all that stuff. How old is Ranger? Ranger is almost 13. Ranger is getting quite old. It's very hot in Phoenix. He is, but he is, he's downstairs. It's 73 downstairs. He's nice and comfortable, but it is quite hot outside. It's getting 94, which I think is like 38-ish for you Celsius users. We're going to be about 44 today for Celsius users, which is about 110-ish. Yeah, Dopar. That's why I say do these commands with us. Get in here and do these different labs. We're not even doing the labs right now. I have a lab linked, but we're not doing the lab. We're just doing these questions and walking through and asking ourselves these things as a systems engineer. So yeah, this is just taking maybe stuff that some of you have done. I'm gonna squeeze this. Hold on. I know it makes some of the guys mad when I squeeze water bottles on stream. I apologize, but the goal is to get you guys getting your hands on this stuff and being able to figure this stuff out. I live in Phoenix, Arizona, one of the hottest parts of America, of the North America. 101 in Tucson, yeah. We're at right now. I think we're only at 90. We're at 96 right now, and it says my high today is supposed to be about 105. So we won't quite hit 44C, but. So Horizon said, do I have a course in Udemy similar to Linux Academy? You seem to love to explain content. No, I don't have anything like that, Horizon. I just have the Linux group. So the professional Linux users group is where people can go and hang and talk. I do have a book. That's the only thing that like anything charges around here. That's on LeanPub. On the Twitch side book. But you guys, nobody has. I tell everybody all the time, just hang out, work on stuff, find stuff that's interesting to you, and then if you want to go do something like that, that's up to you. But nobody has to buy anything around here. It's like the whole you don't have to buy anything to kick it. That's an old joke. You don't have to lie to kick it. But yeah, there's a huge Intel plant coming to Phoenix. There's also Intel has 2 other big plants already in Phoenix, by the way. So yeah, I have people that work over there, so that's good. Yeah, Heather, I appreciate that. I've been teaching for 15 years at the college level, so I try to break things down as simple as I can with a lot of this. I know this is also like a pretty long. We spend a lot of time on Sundays going through labs and stuff, so I know that this is kind of like one of these longer kind of engagements. So some of you might want to take it in pieces, but if you pop back on here, or if you go watch this later on YouTube or Twitch, just go to the next part and keep going. So. Can we list all our open ports? Yes. What can you prove that your DNS is working? Can you prove that your DNS is working? There's all my hosts that I know about. So, can I do that? Hey, how's it going, Shunya? Or I think that's right, Shunya. Hopefully this stuff's useful to you. We are just working through Linux, right? Just asking ourselves questions. This is very much what we call the Socratic Method. Most people equate the Socratic Method to like a confrontational thing. Like it's used in debate and used in argument. But we are not doing it like that. We're doing it like a teacher asking questions and all that kind of stuff. What are the differences between your LeanPub book and the labs on Killer Coda? Brian Ramirez, the labs on Killer Coda, you could do them and pick up all this stuff. The book is about the labs, and it's just got like some journaling questions to make you think a little more. That's it. You do not. I tell guys all the time, you don't, strictly speaking, need the book. However, if you're somebody who likes to like take notes and write things out and think about stuff later, that's what the book's for. And then Vienna asks, is the book free or paid for? The book's the only thing that costs anything. It's on LeanPub. It's like $20. Everything else around here, you can just hang out. You're getting as much right here as you would out of the book. The book is more of like an offline thing if you want to spend more time in the systems world later. Yeah. I'm not telling anybody to buy it. I'm telling you guys to work through this, and then if you go, oh, I've run out of things to work on, which I couldn't imagine you doing, then you go pick it up, right? That's the goal. In fact, the guys, there's a lot of people in the Discord over the years who have watched me build a lot of those pieces. So for them, there's no reason for them to buy the book. They were literally there when I was putting all the pieces together. It's just the book has like everything all wrapped up in a bow. Whereas like you could go find a lot of that stuff on the Discord. It's just it would take you a long time. Dopar, does Twitch TOS ban casting chat from Tube? No, Dopar, what Twitch terms of service does ban is you can stream to as many things as you want nowadays on Twitch, but what you can't do is you can't they call it diminishing the experience. So like I couldn't have the chat only, I couldn't only talk to like YouTube and not talk to you guys as well. They get mad about that. But no, as far as like streaming, you can stream to anybody you want nowadays. So if you guys ever go read that or look into that, if anybody wants to stream, Twitch, I'm never going to be popular on Twitch. Like Twitch is for entertainment, right? Like people love watching games and stuff. YouTube, I'm much more popular on YouTube because people want to learn stuff over there. So that's kind of my take on it. But anyways, so can we prove that DNS is working? Yeah, so let's do something like NSLookup on www.google.com. We would see that Google has, here's the server that we use to do our DNS request. That's a common Google DNS out there, right? Yeah, you can also just ping a URL. That's true. And then if it resolves the name, so if we just ping newegg.com, right? If it resolves the name to an IP address, then DNS is working. That is the simplest test. Can I hit something via name and have it translate over to the IP address, right? So can you prove your DNS is ping anything by name outside of network? There's that. Yeah. Oh, by the way, I got to break down NTULP for somebody real quick. So Sandeep, give me a second and I'll do that for you. Can you prove the DNS is working? Yes. NSLookup, host, and dig against those names. How do you flush your DNS on Linux? I got to look that up. I haven't done that in a long time. But you have your DNS cache is... You've got a DNS resolver. I forget how to do it right off. There's a way to do it. I haven't had to do that in a while, but I always just look stuff like that up. Go take it to the old Google machines. Flush DNS cache on Linux, right? Mac, Linux. I needed to add Linux in there. NSCD. Might be this. Elka Bro Guapo. I love that name. That's funny. Let's see these statistics real quick. I've never messed with this. I do a lot with systemd, but every time I do, I find something else cool. I'm like, oh, that's cool. Ah, look at that. There's some interesting stuff. And can I flush it right there? Can I flush all my systemd resolved caches? I'm not seeing any problems with them, which is important. And then I can flush the caches and then look. I never even... Yeah, we are running systemd resolve D internally as well. So can you prove that DNS is working? And in this case, yes, we already did that. We did the proving that it worked. we weren't necessarily getting in there and worrying about if it was, doing anything else, but were we able to resolve and get somewhere? Yes. So that's good. Let me go back real quick. Somebody asked about this. Listing our open ports. So let me show you guys something. If you do an SS by itself, it'll just dump a bunch of stuff to the screen, right? I'm gonna make that a little smaller so it fits better. But don't worry about what it's saying. It's just dumping a lot of stuff to the screen. Let's make it really small. Doesn't matter what it's saying, it's just dumping a bunch to the screen. And then when you SS-N, you're going to add some kind of what's called an option to it, and it's going to cause it to behave differently. NT U L P, right? And then when you look at that, you go, well, Scott, that stripped it down and that did all these other things. And I say, yes, it did. And you say, well, how does that work? So what you do then is you clear this up and you man SS. And then you come down here and you look at N. N is numeric. Do not try to resolve service names. Show exact bandwidth values instead of human readable. This is very important. When I say do not try to resolve service names, your file, there's a file out there that keeps, it's called Etsy Services. It keeps the names of all the popular port mappings for Linux, and you can go modify it all you want. But we don't want to do that because I want to see the exact port number that's open. Like I want to see that it's port 22 that's open. I don't want to see that it's SSH. I don't want to see that because I need to know maybe that numerically for some other reason. Plus things that scan are going to see headers and all that kind of stuff anyway. So that's your N. Then we come down. We said NTUL. So L is listening. Display only listening sockets. So only things that are actually open. So NTULP. So there's some other information. P, show the processes that are using the socket. That's really important for us to then go look up what that process is doing and how it started. So NTULP. Let's see. What other ones do we have? This is how we would look and find it. T is TCP, and U should be UDP. So when we put that all together, it's all of the... Where's the U at? Yeah, UDP. So TCP and UDP. We use the N to not give the translation between the S's and the the services and the numbers. We want the numbers. The L is the listening ones only, and the P is for the process ID so that we can go dig into it more. If I nmap, it will only show ports on the loopback interface. Cheeto, I'm not sure what you put there for the nmap. You might have to drop it down in the Discord and then I can look. But that's how we would break down what NTULP does. We would go and we would look at each individual piece inside of our man pages. But yeah, the N is stay numeric. N is stay with the numeric. P is the PID. L is only listening, and then T is TCP and U is UDP. So boom, it only shows us TCP or UDP, and then it shows us all this, and it keeps it port numbers. So we proved that DNS where we proved all that stuff. Clear the screen. What file do we edit to change the service to port mapping? So if I did NT, so I take the N off, and I do this, so now it's saying stuff like SSH right here, which is kind of annoying. Then I say VI Etsy services, and I come down here to where SSH is, and I change this to, Big Papa Pump or something. That was like an old wrestler name, if you guys remember that, right? And then I do that SSTULP again, and then look, there's that ridiculous name because it's resolving off of the 22 that would have been there if I put the N back in there. So see how it's 22 and 22 as opposed to the ridiculous name that I gave it. And I did that just to show you guys how silly it is, but then you can come back and you can fix it. Let me say that generally speaking, you do not want to mess with these. Generally speaking, That is not a place that systems engineers spend their times. We don't try to hide things in the network. We don't try to obfuscate things like that. That's not like a thing we do. It's there. We can muck around with it, but on a rebuild of the service or when we destroy the machine and build a new one, all those changes are going to be lost anyways. So I don't know. I mean, like, there's things that are very valuable to know. Like, you should know what the mappings are, but you don't have to memorize them all. You also don't need to memorize like all the well-known ports. So the well-known ports are the 0 to 123, which is the first 1024. Those are called the well-known ports. And then like 1024 to like, I want to say like 8000 something are like typically client ports. And then all the rest are just, you know, unreserved ports for whatever you want. Typically client reconnects. All of these big ones are typically like a client reconnect back to itself or something. Or, you know, a connection back from somewhere remote. You know, any of these high level ones. But you can go look up anything you want. And, by the way, does anybody know, I don't think it's going to be in here, but does anybody know what 666 is? Anybody know who got 666 very early on? It's a gaming thing. They don't have it. They have these other ones. But does anybody know who got 666? You can go look it up on Wikipedia if you want. Who is 666? Anybody know? It was a kind of a joke on an old game from the 90s. It's still, I mean, people still know it. Actually, there's a new version of the game out. Newer. Monkey Man, it is. No, it was before Diablo. There's an old shoot 'em up. Came from Wolfenstein 3D. Doom. Yep, it was Doom. The old Doom port. Yeah, if you ever go look up what was the old Doom port. Doom used to use, it was a 97, and the list of ports for all ports. Oh man, look at all that. Eternity Engine, all that stuff. Anyways, yeah, Doom used 666 originally. Okay. What file do we edit? Etsy services. So, what file do we edit to change service to port number mapping? That is Etsy services. Right? All right. Can you connect to another server and test for an open port? So we have SSH node 01. Okay. And can we check? Can we connect to that server and test that there's an open port? How would we do it? Telnet would work if we have Telnet. Look at that. That connected. We need E. Oh wait, it's like Control Shift dot. There we go. All right. So we connect. So that was one way. That would show us. And by the way, we got a header back. We can curl. Curl will allow us to do the command line URL, so we could see if it had like a WebSocket open. Sure, like not even a WebSocket. Sorry, if it had HTTP exposed. Sure. But what about NC? And with that, we tend to use like VZ. And it'll say we connected. Or one that I like to use is like this. And I'll do a timeout. Because otherwise it'll just sit open. Timeout. Oh, timeout 3. So it'll show me a header. Cat into dev UDP something. Is that like a port number? Horizon, is that like a cat dev UDP and then like a port number? That should be TCP, I guess. I don't know. I don't know if that'll work, but let's for sure know that netcat -vz will give you and by the way, that -vz will not work in some of the Red Hat netcats, they have been compiled differently and they work differently. IP and then port. Interesting. What about timeout 3 netcat node 01.2. That's another way that'll drop. Wait, hold on a second here. Yeah, it doesn't come through Horizon. Let's try node 01. Is there a colon in there? Yep. And UDP still wouldn't. Yep. Maybe on your local host. Anyways, it doesn't matter. We can test with those ones and we can get there. So that's pretty good. How about, what's another one? Can you connect to another server via SSH and show 3 levels of debug on the connection? Must be IP and not host, I see. So can you, check this out, can you connect to another server and show 3 levels of debug on that connection via SSH? So you've got SSH to node 01, and then maybe you do that and you just say uptime, right? And they'll just give you the uptime of the box and come back. But can you show multiple levels of verbosity of that? Yeah, dash VVV will do it. It's going to dump a lot of crap to the screen, so let's grab this real quick. This is going to dump so much stuff to the screen, and then it's just going to do our simple little command that we had, and then it's going to tell me that it came back. Right, so here's our uptime that we actually ran, and then here's our closing out of the connection. But when we look at the top of this, we've got different debug levels. Starts with debug 1, and you could do just debug level 1 if you wanted. And debug 1 starts with, they all start with, okay, I got the header from the SSH, right? And I read the configuration for my local config. And then I went to look at any configuration options for config around that. So these are like the deeper configs of the .d. That's any like one-off type things that you have in there. And then we have to resolve. Look, it does a DNS resolution of node 01. And it uses its IP address via the port number to do a connection. Then on my side, this is my system, I look for these different identity files. And I say, do we have the identity file root.ssh, root.ssh ID underscore RSA, which is a private key, and I did find that one. Now, we did not find any of these other ones. That's what the -1 means. None of those files exist. If I do an ls against this directory, right, the only thing in there will be the ID underscore RSA. Those other ones are not there. They don't exist. I knew that because of these tests. They looked for them and they didn't find them. Then I say I'm starting my local version and I'm connecting to the other side and I'm getting its OpenSSH version. That's the same thing that the header was showing us. And then it says there's a match. We're going to be able to talk, right? That's what it says. And then it starts breaking things down for us. That, look, there's some deeper debug. It's doing a file descriptor 3, so that's going to hold that open connection, setting O non-block. So there's non-blocking so data can move, right? And then we start to look through each of the different systems. And then there's host keys for each reading. So we found it in known hosts. And then we looked in known hosts versus its elliptical curve DSA file, and we found that there was nothing wrong with the server, right? Like there's nothing wrong with the server. It's if it was some other known host than we had, we would have to do something else here. Like we would either have to accept the key, or we would have to we'd either have to accept the key, or it would tell us there's probably somebody else there because it's a different ECDSA than I expect, right? So that would come up. And then there's a bunch of stuff here. It talks about the different algorithms that each side can use. There's some stuff going on in here, and you can dig in. Look, this is the same idea. I always tell you guys this. Like when Robodom's around, I like to use him as an example. But since he's not around, I'm going to use Cheeto. If I said, "Hey Cheeto, everybody here wants some soda," take my truck to the store and go get everybody here a soda. So I toss him the keys to my truck, and he's like, all right, 40 something sodas, right? Or depending on both sides, it's like 70 something. So he goes and runs to the store. If he starts my truck, I expect him to just drive to the store. But if he starts my truck and it doesn't start, then I would expect him to open the hood. And then I would expect him to go check, make sure all the tires were good and the battery was connected, and all these other things that could be wrong. But my point is, you don't go to debug level and troubleshoot unless something's wrong. Now, some of you are probably like, some of you guys are on the software engineering side and you're saying, well, duh, I don't look at the logging unless there's something wrong. I get it. This is exactly the same in the systems world. If everything works, just connect to the server. But if something breaks, go see where it broke, right? This is life. This is the life of an engineer, right? If you're choosing to be an engineer and a sysadmin and all these things and get the title and the money and the fame and the power and all the stuff that you don't get, that's how we do it, right? These are the things. All right. So can we SSH and show all these debug levels? Yes. And why do we do it? Is when we got to troubleshoot. Something broke. Something didn't connect the way that we expected it to. All right. Can you prove that you have nothing blocking port 80 to google.com? So I don't control anything outside of this server. But can I prove that I have nothing blocking me from getting to port 80? That's fair, Arth Vader. That's fair. Don't want to be a sysadmin, just a lazy dev. Perfect. But it's good to know these things. So, curl Google. Yeah, right? Just curl. If that responds back with a functioning web page, that probably worked just fine. So yeah, can we verify that nothing is blocking us to www.google.com? Yeah, curl Google. That works. You will do that kind of stuff often in your Kubernetes space. You will do a curl, but then maybe you'll put, in our case, it's by default already port 80. So you don't need the port 80, but maybe I wanted to see if my application on port 5000 would accept a connection to somebody not in its application namespace. Then we can do that. Well, that's not going to work because it's Google, right? But my point is, you can have all these different things and you can test the web functionality of a thing for APIs, especially with curl and wget. Wget works the same way, except just downloads it. Okay. So we have that. Can you prove that you have nothing blocking port 80 to Google? Yeah, we can do that. How about this? This one's fun. We have SSH node 01. We are on control plane node. Can we copy a file from here to there? And can we copy a file from there to here? Can we do that? Do you know how to use that? What tools would you use for that? I can think of a few tools that might work for that. But one that I use more than others. Can you copy a file from here to there? From one server to another and back. Can you do it? SCP. SCP is great for that. So, what if we had echo, this is a good session of Linux into temp some file, right? Now if we do an MD5 sum against temp some file, I should see its size. I can also do like a CK sum. I can do a bunch of different things to that to make sure it's the same. But then how do I get that from here to over there? Well, it's always a from here to there type model. So let's say SSH temp some file. Maybe SSH, good God. SCP temp some file. I don't know what's wrong with me today. Over to node 01 at temp, and we can rename it right here if we want, or we can just call it some file. And this will copy it from here to there. And then we can SSH to node 01 and we can send a command to md5 sum temp sum file right in that command, and it's the exact same file. And we can do a checksum as well, ck sum, and it's the same file. Nothing's changed in transmit in transport. And then one of the things we can do is we can pull a file from over there. Maybe we know that we messed up our so somebody did this. Somebody went like this and said, I am a dummy into etc cron tab. Now when I cap my etc cron tab, I messed up my etc cron tab, guys. It's busted. So I go to I love grabbing stuff from other servers. By the way, before you ever modify a server, a service config of any type, you should copy off the original, but I've broken it. So I know this other server was built at the exact same time. I'm the one who built it. So I'm just going to scp node 01 etc cron tab back over the top of my etc cron tab. And then now, if I cat my etc cron tab, everything's fixed. I don't have that dummy thing anymore going on. So you can push things with SCP. You can pull them with SCP. You can use, there's more powerful functionality within rsync to keep directories synced, and then also only to change things that have changed between them. So it'll do a basic little hashing function like we just did to verify that nothing's changed between two things. You can also make sure that there's flags as you SCP things around that will keep the permissions. That's very important. If I'm just pushing stuff for me as root around the environment like cron tab's owned by root, should be owned by root. I should pull it down, permissions are the same, whatever. But if I'm pulling and pushing files for my devs, I need to make sure that I'm using the flags that preserve their permission. So man SCP, and there's flags in here that will verify and ensure that the permissions do not change as we copy this around. Look, preserves modification times, access times, and modes of the original files. That may be very important. Recursively, we want to copy entire directories. Sure. Maybe we don't want diagnostic messages and those kind of things. And then that's going to be mostly what we do. Most people do at least P. It's going to keep all that stuff the same. And then also to recursively keep whole directories, right? That kind of stuff. Alternatively to this, so when you use SCP and rsync, I want you guys to think of something. I don't have anything here. I'm looking for something that would make a good example of this. I got a bunch of napkins over here. All right. When you move files individually, and you move them in open directories, they're kind of like this. They're just kind of like everything moving over to somewhere else. And what I mean by that is like this, is they're just a bunch of loose files and directories that are moving. But the concept of tarring, which is much, much, much more preferred in almost all senses, tarring is like I took these and I wrapped them all up and I made them into like I put them in like a briefcase, or I took this little plastic thing that I had for this little gift that somebody gave me. Somebody gave me a knife the other day. And I put them all in there. And now they're not just a bunch of loose files in a directory anymore. Now they're a bunch of things in one file, and they move over, and then we unpackage them over there. That is almost always the preferred way to do things. Oh yeah, you can, look, you can move stuff as a bunch of loose files like this. It's fine. The system can do it, but it tends to be when we're doing like software deploys and other stuff like that we really want to wrap things up, and tar does not do any compression by default. There's no compression built into tar. Tar simply takes everything and folds it up like a briefcase and carries it to another place so you can open it back as the same exact briefcase on the far side. That's all tar does. So SCP is perfectly fine for moving files around. I use it, everybody uses it. But we tend to, if we're going to package something and move it, use something like tar and unpackage it, and then everything's exactly the same on the far side. So anyway, something like that. So SCP from SCP local file to remote node, and then the file system, right? That's how that works to send That's our send. And then our bringing it back is exactly the opposite. So we go from remote node to here is to pull, right? To send or to pull or to push or whatever. Hey, how's it going, Nick? Over on the YouTube side. Yep, it is a good Sunday. We are just doing labs, right? We do labs on Sundays. That's what we do. And these are like as basic as we can go. We're doing very simple Linux stuff. We're asking ourselves questions. We're answering them. People in here are down here. Yeah, tar without any compression. Yeah. Yeah, you can actually tar. Yeah, there's some things you can do with tar that's pretty useful. I've seen mounted file systems where you just tar right into there and it'll just send it over. There's some pretty good stuff you can do. All right, so and it depends, guys. It all depends on a lot of this stuff. I'm showing you the basics, but then like depending on your architecture, there's even faster ways. I have way faster ways to move stuff than this in my clusters, because in my clusters everything has GPFS. So if I put something up in GPFS, which is most of my devices have at least a 100 gigabyte per second link into there. I mean, all I got to do is put it up there and I can pull it. I can execute things out of there. It's so fast. Like my file system, like I put all my libraries in the high performance compute space are up in our GPFS, and then all your nodes can execute from the same libraries. It's wonderful. You never have to wonder if things are out of date or whatever, because everything, when a node comes up, it's either connected to GPFS or it's not. It's either part of the cluster or it's not. Oh, GPFS is so much more than NFS. Yeah, it's a general parallel file system run by IBM. Yeah, IBM owns it, and it's very valuable. The open source one that a lot of people use that's also super fast is Lustre, Lustre, and that's Open SFS Foundation that runs that. And Atomic GI Hank, I missed your follow earlier, but hopefully this works. Hey, Ross is here. Ross, we are doing Linux this morning, so I've got the labs linked for anybody that wants to do the labs. Although we're not doing the labs, we're doing what's called the Socratic Method of learning, and we're asking ourselves questions over here. And the next question is, can you capture all the packets on an interface? Can you track things that move in and out of this server, right? We've got these two servers, SSH node 01, and we're in control plane, and we've got these two servers. Can I capture all the packets on the interface? So I know that my IP adder, I know my interfaces are ENP1S0, right? That's my main interface. And then we are going to see if we can capture all the packets on the interface. Now the tool, yeah, we can track anything at any time, Rosper, that's true. If we want to track what's coming in and out of this interface, there's a tool for that. It's called TCP dump, right? That should make Ross snicker. It's a dump, right? So TCP dump, and then I need to know some information about it, right? Like I need to know the interface that I want to look at, which is ENP1S0, and if I just do that, it's just going to dump forever to the screen. Hit Control C. That was 27,467 packets. It's a lot. Zombies Pale 6 said, hi there, is there a way to access my home server computer from outside network without port forwarding? I'd need a static IP for that. Yeah, well, Zombie, no, you don't need a static IP. What you might need is called DDNS. So the concept you want is DDNS. So Guacamole, if we look here, so my router, my external router, it logs to asuscom.com, and Prolog, which is the name of the Professional Linux Users Group, this always maps to my home address, even if my internet goes down and comes up and gives me a new resolution. But the solution you want for that, Zombies Pale, is called DDNS. It's dynamic DDNS. Your router probably does it, but you can also get it through Cloudflare. And what it is there's a service out there that exists in the world that's waiting, and your machine is running basically like a client that just checks what your IP address is out to the world, and then it just registers it to them. And then anybody that wants to hit you, anytime you want to hit your system from anywhere out in the world, boom. Just use Tailscale with exit node. Yeah, there's probably simpler ways to do it nowadays. The way I've always done it is I can hit, like I can go anywhere in the world. And in fact, when I go down to Mexico, I do this. Wait, that's my other one. Hold on. Let me just pull up. I'm just going to pull up a generic. Where's it at? I'm just going to pull up a generic new putty session. And I can connect to my remote home server, which is at prologueasuscom.com on port 22 from anywhere in the world. Tailscale. Let's go check out Tailscale. But I can almost guarantee you Tailscale is doing the same thing. But the technology you want to look up is DDNS. But let's go look up a Tailscale. What the heck's a Tailscale? DDNS is typically what you want. Okay. What are my hands doing? Come on. I feel like I'm wearing like oven mitts. Tailscale. DNS. Let's see. Is this just Tailscale is a unique IP that stays the same no matter what. Use match DNS and admin console. Okay. So where does this Tailscale run from, though? This has got to be. So they've got a free service on this, huh? Okay. Oh, I don't want to do that. Yeah, guys, I don't do much with this. I just use DDNS, so I'm just looking at this because it was mentioned. I don't know this. All right, but guys, there's a quick start for anybody that wants it. Boom. Look, I mean, it looks interesting. Guys, look, there's a lot of solutions out there to do a lot of things in this world. I don't know this one at all. I just know the one that works for me, and this is how, like, anybody can connect in. Anybody that has access, anybody that wants to be part of the Professional Linux Users Group can get access to get into our systems, right? And then you can get connected to any of our nodes out there. And once you connect into our nodes, then you can right over the internet. That was over the internet to me on my external port. And then this reports every day. It reports the usage out to our sandbox. So if you're in our Discord and you want to see, this actually makes me sad. Nobody's used any of my servers that I have available. They're just in my virtualized environment. The last person to use this was like 3 or 4 days ago. All right. Anyway, something for you guys to play with. It's all good. It's all fun. All right. So we're over here. We're still looking. So we can capture all the packets on an interface to a file. So we do that same thing, and then we do a dash maybe capital O to temp. Actually, I'm sorry. It's W, and then temp wireshark.pcap or something like that. And now this will get, oh, by the way, hold on. We want to capture a certain amount. So we'll capture like 10,000, let's say, right? So we'll capture that into that. Whoops. That's funny. Wireshark1.pcap. We'll do that. So now it's going to try to write. Looks like that was we couldn't write over it, which actually is hilarious to me. We should be able to go delete that if we want. But now it's going to take a long time because we're not doing any traffic. So I might come over here and then do like while true do uptime done, right? Oops, done. And now this is going to spin real fast and send us packets. And then if we jump back over here, that thing's going to finish way faster because now, yeah, there's all our packets coming to this interface. So we kind of cheated a little bit. But now we got 10,000 packets captured to a Wireshark1.pcap file. And that Wireshark file you can always open. So if you guys have never played with Wireshark, mine is immediately going to tell me to update it. I know because I don't go in Wireshark very often. Except I use it to show my college students stuff. But yeah, I don't want to update. Let's go to one of my test PCAPs. And this is a capture from my network I think many years ago now even. There's my epoch time. We could take that and figure out exactly when this was. We can go copy that. Whoops. Copy just the value. And we can go throw that in an epoch time calculator and figure out what that time was. Actually, we can go here and go date dash percent. Oops. Yeah, I don't know. We should be able to find it though, but we can. And I always forget how to read that back. But oh, okay, okay. So date dash dash date that at. So what? Oh, I need an equal sign. I knew something was missing there. Equals. So that was November 9th of 2021 that I captured this originally. Yeah, equals. Yeah, yeah. I was testing you guys, and you were the only one that passed, Haas. You were the only one that passed because you knew that I missed the equal sign. But I did that to test you guys. Excellent work. You will get 2 likes. No, I'm just kidding. But anyways, that was a good catch though. We can capture stuff. Can we capture all the packets on an interface? Sure. Can we then permute that and find only packets that are going certain directions? And this kind of thing becomes really important because what happens is you will just be sitting there building your servers, right? And you'll be happy building servers as an engineer. And then somebody will come to you from like the storage team and they'll be like, "Hey, we got a backup client out there, and the backup client, it's the damnedest thing. We set it all up. We talked to the vendor. The vendor's got our new location, and we got our old location. And we turned the new client on, and it's not sending the information over. Can you figure this out?" So you go to the server and you tell them, "All right, get ready to pass the data." You do your TCP dump, and you're looking for that new network, and then you don't see anything. You don't see any traffic going from the server, and you go, "Guys, I can definitively say that," and they're like, "The data's flowing," and you're like, "I can definitively say it's not going out this interface." And the storage guys over there are going, "Yeah, it's not coming to us," but the people looking at the client are like, "The data's leaving." But then you go and find out, this actually happened to me at one of my companies years ago. They go, "Oh shoot, we put the wrong client data in because you sent us at the beginning of the engagement the old client data, and we never updated to the new data point." So then they fix the client, and I'm sitting there watching it, and I just watch all the data flood out the right direction. Everybody's happy, and everybody's like, "Yeah, we're so glad the Linux guy got on." And I'm like, I literally didn't even do anything. I just sat here and did a TCP dump and verified that nothing was leaving, which we knew, and they knew nothing was getting there. But then we could verify it was going out the other direction, and it wasn't being routed to the proper place inside of the client. And that was super easy. But it's just because I knew how to sit there. And I want to show you guys something. There's something important about TCP dump here when you go to do your filters. So you go and you think, okay, I'm going to do a TCP dump, and I'm going to look at these. I do a pound sign just so it stays there. But I man TCP dump, and there's nothing useful in here, as I read, about the filters. So then I go, well, shoot. Where's the filter information, right? Like how do I find where the filter stuff is? And the filter stuff is all under this right here called PCAP filter. So because when you look here and you're trying to do TCP dump and you're trying to do these filters, there's not a lot of info here. So then what you do is you get out of here and you man that filter, the PCAP filter. And in here, it's like, in here, there's a type and a dir and a destination host and a source host and a type and by port and gateways. And, oh, man, there's all this stuff in here. By the whole network, if I want a whole network, by a certain subnet mask length. This is like a networking guy's dream, right? But all of these things feed back into that TCP dump. Yeah, so that's the thing is you're looking at, we're still going to use TCP dump as the overarching command, but the dump of the actual individual PCAP filters is down in here. So I'm like, okay, I want the destination. So actually, this is what I was doing. The destination net was going to a certain place. So this is where my point is, you'd come here and you would find there's actually really good examples here for all of this stuff, for how you can carve it down. And then these, like, to select all IP packets between ACE and any host. So IPA host, but not the Helios, would be this. And then I would go in my TCP dump, I'd man my TCP dump, and I'd go, all right, how do I do the filter part of it, right? And the filter part is, come down here. Yeah, so TCP dump and then just drop it. So it'd be like this. So TCP dump, and then I would just say those values from earlier, right? And then everything else. And then I don't have an ace or a host, but I would say maybe in this case control plane. And everything between here and node 01 maybe. And then now, oh, well, that's hilarious that it won't let me overwrite them. But now I'm listening to everything between this host and node 01. I don't care if people are going from this server and proxying out and playing Doom online. I care about this connection to that server. And I want to capture all the traffic because, again, I have been told that we would have this data flowing on this port and this and this. And I can validate that, no, there's no data flowing over that. You know, I would expect 95% of the traffic flowing between these two to be that backup data. I don't see any of it. So that. I like Die or DiceNet. They're all man pages as well at the bottom. Oh, yeah. There's some really good ones on there. That's true. Yeah, and Bash man pages. I'm also a big fan of going and reading stuff online. I do the same thing with Ansible. I don't do a lot of reading directly in Bash like this. I mean, if I'm down locked in a skiff, like in a data center, and I can't get out, I'll spend some time down there. But for the most part, I've got my notebook. I tend to have, if I've got a device with me, I tend to have all my notes somewhere here. Let's see. Can we capture all the packets? Yes. So can we capture everything and put it in a file? Yes. So it's TCP dump. We got a whole bunch of them. Something like this. Boom, right? And then, but this IP host control, this kind of stuff, you won't find in the TCP man pages. It's in the PCAP filter. Where did it go? Yeah, you're going to man the PCAP filter, and that's when you're going to go find that information. You're not going to find it in TCP dump man pages. It's not there. There's some very basic examples, but if you want to get like nitty gritty, watching data flow between certain things, this is where you'll do it, PCAP filter. All right, we're going to stop that. RM-RF, temp, Wireshark. Get rid of everything. Oh, well, it would help if I type things right. Boom. So those are all gone now. But it's funny that Wireshark or TCP dump won't write over a PCAP that's already there. I like that. All right. Can you show all the hops between your server and google.com? What do I mean by hops? I mean all of the packet hops that are made, because frames don't hop. I've explained this often before. Frames get stripped off and don't ever go past the next network interface. They never do. Frames, like you'll see on like a crime show, they'll be like, oh, I've got the source MAC address. And you're like, no, you don't. The MAC address never left the local network. Anyways, I digress. I don't take the shows that seriously, but when they say stuff that egregious, I just want to be angry. All right, anyways, so Tailscale is peer-to-peer VPN. I don't know, Brian Ramirez. I don't know much about the Tailscale piece. I do everything with DDNS for my system, and that works pretty okay. That's been, man, I've been seeing that and using that for 20 years. So I don't know. There's probably better ways to do it nowadays, I guess. But okay. So can you show all the hops between your server and Google? This one is traceroute. Traceroute, www.google.com. And I fully expect, what? apt-y install traceroute. So we'll get traceroute on here. I fully expect this to not traceroute all the way to Google, because a lot of times network devices are configured to not show. These are configured not to show all the hops, and that's fine. However, this one did show, well, it showed all but one. But let's go to Yahoo. Let's try some other ones. Yahoo.com. Yahoo got there, okay. But a lot of times you won't be able to get to the places that you might want. You might let's go data.gov. Data.gov is a government website that you can pull API data from. And as we were hopping along and getting there, there were 3 devices that did not. Oh, look at this. There were 3 devices, 4, 5, 6, 7, 8. There, look at all these. These are all the ones that aren't responding to us. Those are all hops that are valid. We're about to hit 30, which I think is the max. But we could curl data.gov. Curl it. Oh, move. What? I thought data.gov existed. Maybe that didn't. Oh, and there, look, they finally hit 300,000 data sets available. If you've never hit like a fun little API and pulled data from the government, there's U.S. government. There's a bunch of ways to do it there. All right, so we can show all the hops. Can we show all the hops? Can we show all the hops between us and Google? Yes, we use traceroute. Right? I compare trace routing on Windows and Linux. Sometimes traceroute on Windows only gives more hops than proper reverse DNS entries. Yeah, there are different ways to do a lot of this stuff. Hey, how's it going, Morrison? We are just doing Linux stuff today, right? Just hitting the basics and asking ourselves questions and walking through stuff. We're in networking right now. We've done system level stuff, processors, memory, disks, file systems. Now we're in networking. We're about to get to security and software packages and all these other things that I've added. So a lot of this stuff is probably review. I mean, it's been like, it's funny. It's been 4 hours of review, but this is good, right? If you haven't done some of this stuff, it's going to be valuable for you guys. All right. Can you capture all the traffic on your primary interface? We did that with TCP dump. Can you capture all the traffic on your primary information and save it to a file? We did that. So that was TCP dump. All right. Disk topics. Oh, we didn't do disk stuff yet. We did file systems yet. We didn't do disks yet. Can you check how many disks you have in this environment? There are disks that are part of this server. Even though it's a virtual machine, there are disks that are in there. And what disks do we have? LS block. How about LS block -F? That was a fun one. Okay. So disk topics. How do you know? How do you check how many disks you have? LS block. And LS BLK-F. I'll take any of those. What about yeah, fdisk-L is one of my favorites. fdisk-L will give you a lot of information, and then maybe you just grep grep for disk, and it'll give you just the disks. That would be pretty good. So fdisk-L, that's a pretty good one. I like that one. Gives us all kinds of disks that are in the system. Now df-H shows us mounted things, but the problem with df-H is it doesn't show us. It'll show us disks that are mounted, but what if I had a dev VDA or a dev VDB, but it wasn't mounted? Would it show it here? df-H would not show in that case. Yep. Okay. So if there are a bunch of block devices down in dev disk by. So ls dev disk by. And then the by can be label, part UUID, path ID, and UUID. So if I did everything in here, you would see that by label, here's some labels. By disk, part UUID, there's some. By path, and by UUID. And it's funny, if we did an ls-L on them, those are all links. And those links all link to the parent directory of the parent directory at the actual location that they go. Watch this, I'll prove it real quick. ls-L. And then watch, I'm going to only find, actually, well, we'll link them all. But see how they go to the parent to the parent. So from dev disk by, they move up to 1, 2, so they're in dev. VDA 15, VDA 1, VDA 1, so they're all pointing to the same place. But that is a correct thing that will show you those block devices. ls-l dev disk by everything. That would show you all of them. Dev disk by ID. I haven't seen that in Ubuntu, but there are different ones in different file systems. By ID might be one. In Ubuntu, I've only ever seen the label, the part UUID, the path, and the UUID. Those are the only ones I've seen in there. Yeah. Let's and we can go check that. Look, this is one of the nice things about having different environments. We can go check that in my home lab, right? Oh, this is an Ubuntu box as well. But my home lab, this is a CentOS 7 box. So this is path UUID ID. There's my ID right there. So you're right. They do exist by ID in my environment. In depending on where they are. Yeah. But my CentOS box does do a dev disk by ID. So there you go. And just, I mean, it depends. Like, you guys are going to see different things. And it's important that your virtualization, a lot of times your actual, if you're using logical volume management, they will sometimes be assigned DM-0, DM-1, even though they're logically mountable. All right, block ID. Block ID will give you some interesting stuff. Oh, did my environment die? Oh, my environment's dead. Oh, yeah, there we go. All right, all you gotta do is restart the environment if you get stuck or if it breaks. Just restart the environment. Gosh, can't get my little mouse to. Block ID will show you. I'd say block ID will work. So there's a lot of ways. Let's leave it at that. That there's a lot of ways to see all the disks in your system. By IDs is given as proper examples when doing disk stuff. Yeah, and Ubuntu went a different route. Ubuntu does everything. When you go look at their cat Etsy FS tab, they have chosen to use labels. I don't know if it's just because they know labels are going to be immutable in the environment. I'm not sure. But that's how they do it, all their mounting by default. So, yeah, you will find different proclivities in different operating systems you guys go to. But some of these things, some of these base commands will always be valuable to you to kind of know. So how about this? How do you check how many disk partitions you have? ls-block -f. That shows partitions right there specifically. How do you check how many disk partitions you have? Well, you can use ls-blk, ls-blk-f. I'd say those are pretty good. But could you also do fdisk-l again? grep-i for if I knew it was VD. Yeah, that would work. I actually I use that in my home lab a lot. fdisk-l grep-i vd in this environment, or whatever your starting of your nomenclature for your disks are. Okay, so there you go. Boom. Those are all good ways to find the disks that are in the system. And remember, this is a good point from earlier. df-h is awesome for seeing what's mounted. But what if you were coming to a disk and somebody told you, hey, there's a bunch of there's a bunch of extra disks in there that aren't being used, and you're on a physical box? df-h will only show you what's mounted. But there's so many things that might be under the hood, not attached to the actual OS. And this is what we're digging in on, right? This is another way to look at the system. All right? So, it's not that certain things are wrong, it's just that we have to think about exactly precisely what we're doing, right? And then how do you check what file systems are on which partitions? You know, you come to a disk and you've never been to the server before. and you're trying to figure out like, well, hell, is this mounted the same way as this other one? Are the and a lot of this stuff I compare between servers. Like, were these built the exact same way at the same time with the same kickstart file or with the same netboot image? Like all these kind of things. By ID gives partitions. Nice. Okay. So which file systems are on which partitions? We have lsblk will show us the file systems. lsblk-f will show that, and it'll even more information, right? What do we got over here? How about the mount command? That's actually pretty valid. So what if we did a mount grep-i for like root, and well, there's a bunch of crap there. And well, we just mounted and then did more because it's just going to be too much crap to the screen anyways. And yeah, we can see this is mounted here and the type. Yeah, so I'd say that's fair. Mount is the command. Yep. And in this case, we got too many other things. So mount grep-v e, and we will get rid of C group, and we will get rid of container. Right. And then what's another one that we need to get rid of here? Snap. Get rid of that crap. I still got rid of most of them, but most of these other ones that aren't real or don't, well, they don't matter to us anyways. Find mount. I've never used find mount. Ah. I like that. Never even seen that command before. That's pretty cool. By the way, that kind of looks at the point that like you can do this for a long time and not see everything. Let's go look at this one. What's this one? We say grep v ie ext4 and xfs. Yeah, that's fair, because then we can just find the things that we cared about. Yep, that's another way to do it. Yep, and that'll clear out the clutter and the noise of the other things. If we know that we're on ext4 and xfs, that's what we typically are in the world nowadays of enterprise engineering. You will probably in the Linux space mostly run into ext4 and xfs. You might see some 3s out there kicking still, ext3s, but I don't think you're gonna see that much. Yeah, that find mount was pretty nice. Yeah, I like that because it shows you where things are mounted from, so that's nice. Okay, so we're getting on. Can you check partitions that aren't even mounted for file system type? So this is interesting. What if there's a partition out there, but it's not mounted, right? So it's not like a mount, or it's not one of these other things, but it's got something on it. Remember, I told you that there's disks that are out there, there's block devices, and you want to see what's in there, even if they're not mounted. And I think LS block is probably the best one for this, because LS block will show you block devices even if they're not mounted. Let me show you this over here. If I go to my box and I clear this up and I do an lsblk-f, there's all these things, and these ones all happen to be XFS and then a logical volume management member, so they're part of a bigger thing, but they are part of whatever storage or whatever pieces they are. But if there were other disks that I had already partitioned in here that weren't mounted anywhere, they would still show up in this LS block. So can you check for partitions that aren't even mounted for FS types? Yeah, lsblk-f. And some of you might be saying, Scott, it seems like a lot of the things you do are the same command for different things. Yes, you're using these commands and you're figuring out different pieces of the system. Some of these things might be questions you ask for different reasons, because management comes to you and says, hey, how much extra storage can we get into that box like today? I don't even have time to go order something or to have Like, we can't even wait till tomorrow to throw in, and this is rare, but let's say it happened. We can't even wait till tomorrow for the SOC, our operations group to go and throw data, throw more disks in there. We can't take it down. We just need to squeeze any other disk space that's out of it. Can you find it? LS block would help you find it. So would, if you were using this, PVS, VGS, and LVS would let you know if any of your disks were not being used within your logical volume management system. Now, strictly speaking, in these questions, I don't ask you anything about logical volume management because we don't have that ability in Killer Coda. I have actually asked in their Slack channel before. I said, hey guys, I build a bunch of labs over there. Is there any possibility that I could get like a little environment that has like just 3, even 1 or 2 gig disks that I could just have people do, we would do like software raid, we would do LVM with them and stuff. And they said, no, we don't really have any plans for that. And I said, all right, fair enough. It's your environment. You guys do what you want. But I just thought that would be useful because I get that people could be worried about abuse, but I think for people that just want to sit here and learn this stuff, until you've added disks to a mount, until you've done some of this stuff, you're going to think like, oh, I can't do that. But then as soon as you do it, you're like, oh, stuff's easy. I could take all these disks and put them in whatever, right? Like I think most of you are like that. You get your hands on something and you figure it out, right? So can you check the partitions? Yeah, we did that. Even if they're not mounted, sure. All right. Can you check disk I/O over time? Can you check disk I/O over time? I'm going to add sysstat because I don't have sysstat on the system. But let's get sysstat on here. And can I check the disk I/O over time for any of my disks? For all of my disks? Who knows? So sysstat is a set of packages that have I/O stat. All right, let's see what this is. BWM-NG. I can't imagine this is going to work. Probably not. Oh, maybe if I have that tool. Let's go check it. I'm going to see what this tool is. I've never seen this tool. Hey, Apollo Python, how's it going? We are working on all this stuff. Let's look at IO top here in a second. But let's try this one. I've never seen this command before. Oh, yeah, look at that little guy. That one's pretty cute. All right, that's cool. It shows us what's going on with the disk. I've literally never seen that command, so I love it. All right, but let's look at some of the other commands that I am a little more familiar with. That's awesome. I think that one's good. What about this one, IO top? This one probably came. Oh, it's separate tool. ETH. What is Ethernet? Is it Ethernet? Help me out. Which one's? How do I do the Ethernet? Without the I. Oh yeah, look at that. That's pretty alright too. Alright. That's an Ethernet thing. Good. So let's do an IO stat. So IO stat will give you 2 things by default. It will give you disk, and it will give you, well, it's not even disk, it's block devices and CPU. So CPU's here, and block devices are here. But those are 2 weird things in my mind to put together. So we can use iostat-c to see just the CPU, and iostat-d to see just the disk. So, but we want to see it over time. And what if we did this? What if we said iostat-d 1, 1? Well, let's do it like this. Let's do 1 by itself. If there's 1 argument given to the command line with iostat, it'll give you every 1 second forever. If you give it 1 and then you give it like a 10 here, it'll go every 1 second for 10 steps. So every 1 second there will be a slice of how much that CPU is being read or used. Sorry, in this case it's disk. Being read or used. So this is 10 1 second iterations. We can have iostat-d1, and this is 1 second iterations forever, right? And that's kind of useful. How about SAR? Yeah, if we have SAR. SAR does not, it says SAR is not enabled, but I should be able to do a SAR-R. Nope. So SAR is trying to look at today's data and look back, but it doesn't look like SAR is on. I don't remember how to turn it on, but we just installed IOstat, so it's not going to have any historical data anyways. IOtop we tried. You'd need a separate tool. But check this out. This is one I wanted to show you guys. So we can do iostat-xe, and let's look at that every one. Let's do that every 5 seconds. What? It's XV? Damn, XZ. I'll get it eventually. So check this one out. This is going to do every 5 seconds forever. But watch this one. The first output was really long. And then now all the output is very short because the output for any one 5 second slice, because again, it's immediately just taking a snapshot, but every 5 seconds, it's only showing the things that are having activity. I didn't install IOtop. I can install IOtop though. But look at this. This is iostat-xz, and it'll only show you the things that have activity. This is only things that have activity. Let's get that. Let's go check the IOtop. Hold on. Check this IOtop out. Let's see what this looks like. I don't really mess with a lot of this stuff, but these are tools that you can put on your systems to verify that things work the way you expect them to. You ask questions as an engineer, you prove things to yourself, you take things away. This has whatever the commands are over there and what's actually reading and writing back to the disk. So IO is always input and output, right? It's input and output. Which, by the way, there's really only 3 things in computer science, right? Input, output, and processing in between, right? Those are the things we do. This is looking at I/O to the disk for any command. Super useful. etcd is doing a lot. etcd is our key value store database for Kubernetes, right? All etcd is a super fast data store. That's all it does. Oh, by the way, I missed some follows. Thanks for the follows, guys. Hopefully, Def Not Freddy and Martha P. Hopefully, this stuff's useful to you. We're just going through Linux stuff, right? Like asking ourselves questions and figuring stuff out. So can we check the disk I/O over time? Yeah. And I like this IOtop, which is by process I/O to disk. All right. Super useful because you would very quickly see what's using your I/O. Does Prometheus have its own UI? Yeah, Prometheus has right here. This is my Prometheus in my home lab right here. Yeah. It's a web UI. Yeah. Yeah, Prometheus has its own UI. The problem with Prometheus though is this. Even if you were to graph things or even if you were query data, it's not good to show it to other people like this. So that's why you take this stuff and feed it over to a tool called like Grafana. So Malvi asked a question about Prometheus, guys. Okay, so where were we at? We were checking disk over time. Can you verify disk read and write speed? Yeah, can we verify the disk read and write speed? And actually, we answered this earlier. We did DD commands into and out of our file system. So we kind of already did the speed stuff, right? So we already did the speed stuff into and out of our, oops. Damn it. So I'm so used to just mousing over things to copy them that I hardly ever hit Control C anymore. That was my bad. Control C. Boom. Yeah. Yeah. So that's actually. Whoops. Yeah. There we go. All right. We did that. So we did that. We did that earlier, right? Also, thanks for the follow, Ben Hesner. Hopefully this stuff's useful to you. What are we doing here? Oh, we're still watching this. Let's hit Q to get out of there. There's also other commands it looks like you can do. All right, so now we're going to get down to security stuff. Can Grafana work alone or get metrics without Prometheus, or is it just UI mainly? Malvi, Grafana is almost always used to scrape as, like, the Grafana is like the one ring at the end of everything. Hold on. Damn it. Hold on. Hold on. In my home lab, this is my monitoring, right? Grafana is just the one ring to rule them all and in the darkness bind them. It is, the Grafana is just the end piece that scrapes from Influx or Loki or Prometheus. But Grafana itself doesn't keep its own, Grafana doesn't keep its own data store really locally like that. That's not what it does. It relies on something else. That can be Graphite, Loki, Prometheus, Influx DB, all these other things. So hopefully that answers that question for you. And then if you want to see those all, we can go to my Grafana instance, like in the home lab. And then I could go to like make a new data source, right? I want to create a new data source. So here's the ones that I've got in my home lab. And if I wanted to add data sources, here's all the ones: Prometheus, Graphite, InfluxDB, OpenTSDB, Loki, Elasticsearch, Jaeger, Tempo, Zipkin, distributed tracing. Maybe I need to play with some Jaeger, but SQL, if you want to pull data directly out of SQL, cloud stuff. In my home lab, we've pulled CloudWatch down and that kind of stuff. And then enterprise plugins. Look at all these different plugins that are out there. And then others, like you can have Alert Manager and Test Data DB coming over here. So there's a lot of things, but no, Grafana itself very rarely keeps data about the system. That's stored somewhere else. Yeah, Ben Hesner, hopefully this stuff's very useful to you. FIO gives detailed disk IO stuff like IOPS as well. Good. Yeah, any tool you guys can do to get these things and figure them out. So let's do security topics. What do we know about security in a Linux box, right? There's a lot of security stuff that can happen. But before I do that, real quick, let's I gotta grab a drink here real quick. Let's put this over here. There's Ranger. You guys can check on Ranger. I'm gonna put a quick break. Hourglass. Put my little hourglass up. You guys are welcome to keep hanging out and talking shop, or if you got to bounce, let's say quick break and grab a drink. All right, I'm gonna give you guys. This will be Ranger is almost 13. He is a pretty big dog. I'll go down and give him a treat here. I'll leave it on Ranger. Just normally I'll switch through things. By the way, look at these, all the people trying to log in the last 6 hours trying to break into my system. Probably some people because I showed how to get into my system earlier today, but that's fine. You get logged out forever if you mess around too much, so that's fine. Let's go here to Ranger. We'll leave this on. I'll go give him a treat here. Yeah, quick break. So smoke him if you got him. That's what we used to say in the Army. Do whatever you need, and I will be right back in a few minutes. All right? All right, I'm back, but we still got some break time, so feel free to. Yeah, you see Ranger down there munching on his food. That's Ranger for you. It's a good dog though. He'll be 13 in November. Well, Ranger's munched on his treat. Check out the stuff in the home lab. Oh, there was a question about, is Loki similar to Prometheus? Loki's different. Loki cares about logging. Prometheus is not good at logging. Prometheus, in fact, should not be used for logging. That's not, it's useful for metrics. This kind of data being shown right here. This is, although this is Telegraph. But yeah, Prometheus itself is very good for metric data. This is Loki here. Loki is feeding this data, which is log aggregation, and sending data to an API endpoint for logging. That's what Loki's really good at. I have a good, over on the YouTube side, I have a pretty good primer on monitoring. And we have a project actually. So for people that are interested in doing that stuff, you go in the Discord and you pop down in the Prolog projects here. And in the projects, there are these lab files that you can go and you can watch the video on YouTube. Then there's the monitoring deep dive project guide that you fill out, and then there's the monitoring deep dive with labs. So you can actually fill this out, and you strip off all the stuff at the beginning, and just you'd have something in a portfolio. You don't have to show that it came from us. You can just show that you did it, and then you can post it on your as a part of a portfolio that you know how to monitor Linux stuff. It doesn't matter how you get the knowledge, guys, as long as you're the one that does the work and sets it all up, right? So anyways, that's in our Discord. You guys can go play with that stuff if you want. We're still on break, so I think Kubernetes is valuable. It's not a must. Kubernetes exists in most environments, but I can tell you that I can tell you that I've worked in the last two places where we weren't even using Kubernetes. High performance compute doesn't use Kubernetes at all right now, although it's moving into that space. It is moving in, and most of it's still bare metal workloads, because the bare metal workloads still do most of the big data. So, well, alternative to K8s, if you are determined to go. So K8, so in general, Kubernetes K8s is not, it's not necessary to do K8s if you're not interested in those type of workloads, right? Like alternatives to that would always have been bare metal systems, normal virtualized systems. Invite for the Discord. Hold on a second here. Sometimes I forget that I don't have the people, like sometimes if Robodom's not around, he's one of my main mods, he drops it in there, but there it is on the YouTube side. There's the Discord link. I apologize, that hasn't been getting posted. Normally he posts stuff like that like pretty much like every hour, but I didn't have him on. He's taking a break today, so he's not around. Yeah, the monitoring project I think is an excellent thing because it builds stuff out like what's in my home lab. Not exactly like my home lab, but this part is exactly the same, and this part is exactly the same. So you can get some really good pictures in there of stuff that you've done, and then when people ask you, they're like, well, what was this? And you're like, well, I was actually monitoring all of the messages in my system, and I wanted to verify, there's three things we monitor. We monitor metrics, logs, and tracing. And I've done a really deep dive on logs and metrics, And depending on your organization, if you want me to be a systems, You know, if you want me to be a monitoring engineer, then you probably have some good tracing set up. And if you don't, I'm ready to start working on that, right? That kind of stuff in an interview, people would probably be like, this person's ready to go. This person's ready to get in there and do some work on this stuff, right? So that's kind of I mean, I'm colorblind, but that's still a pretty cool looking graph right there, I think. And that shows, that's a visual representation of that disk IO stuff that we were just looking at in our stuff earlier, right? Oh, look at that ranger dog. Oh, ranger dog. Laying around. He's really good at looking like he's a sad, overworked dog, but I assure you that dog is lazy and pampered. And he's a good guard dog. He knows he only has to give me one good bark. He doesn't have to do anything else. He doesn't have to charge anybody or anything. He just has to give me warning that somebody's here. So he's pretty good for that. Yeah, look at all those failed logins to my systems. All right, let's get back to work here. Oh, my colors are all washed out. Maybe my screen's too dark. All right, get that out of the way. So, what are we doing next? We are down in the system, and we are finally into security stuff. I think everybody hangs out just to do the security stuff. Let's do some questions around security. Like how well do we know how to do some of this stuff? And these are the same types of questions. I'm telling you, like, stuff like this comes up in my high performance compute stuff. Stuff like this comes up in government contracts that I work on. It's all super simple stuff. You just need to know where to go look and how to figure it out. So, all right, let's do some security. What users have logged into the system in the last 24 hours? How do we know that? How do we know what users have logged into a system for the last 24 hours? Who knows that one? Could I do pipe? Can I maybe do a last and pipe it through more, and it'll tell me, okay, those are all the people that have logged in. And also another way, because last reads from top, so it reads backwards. So you might run last through TAC, which will flip the data backwards. So look at my home lab here, right? So clear this up. Last, pipe it through more, will give me all the stuff here of me connecting in. But if I wanted to see that backwards, I would just TAC it, and then it would be in the proper order for me. So 2 times I logged in, but it wasn't even today. It was 3-4 days ago now into this system, probably because that's when this box rebooted. But I keep a screen session up. So even if, like, some of you probably, hold on real quick. Some of you probably, if you're in an environment like this, you're very probably, you got all this stuff going on. Some of you are probably somewhat terrified of killing your putty shell, right? But I'm not, because I have a screen session up. So I can go and I can jump back into that box at any time. There's just a jump box in my home lab, right? P01. Oh, nope. Damn it. You just click on them here. P01 jump 01. So here's my jump box. My user. Get in. And then once I get in, I do a screen-ls to see the screen over here, the screen sessions that I'm in. And I have the one screen and it's detached. And then I do a screen-r and I'm in the exact same environment that I was just in, with all of my different environmental things down here across the bottom. So there we go. Yeah, last log. That's a good one. Hold on. There we go. Who's logged in and when? I like that. And maybe I do a last log in grep-v for never, because I don't care about people that never logged in. So last, pipe it through more to get it so we can read the top. last pipe it through TAC, so it's backwards and it's the correct way that a human would want to read something. Last log, and then maybe grep-v for never, because we don't care about people that have never logged in. I think those are all pretty good ways to see what users have logged into the system ever, but also in the last few minutes, right? Or the last 24 hours. So in this case, we don't even need the more because it's so small. But there's my system, and who's been able to connect to it and all that kind of stuff. All right, so that's very useful. I think I've told you guys, when I first get to a system late at night and I've been called out and they say, "Hey Scott, you know, maybe," because I take on-call rotation even though I'm the lead. Pretty much, I've been the lead since 2016, so almost 10 years. I've been the lead on every team I've been on. I still take an on-call because you take on-call. And if you're the lead and you don't document your stuff well, you get called out by the juniors all the time anyways. So I try to tell you, like, get your stuff right so you don't get called out a lot. That's a big part of being like a senior and a staff and a principal engineer, is like making sure that your life isn't ruined by all the juniors that call you all the time. By the way, it's fine. People call me whatever. But my point is, the first things I do on a system always are this. I do an uptime to see when it first... This has only been up an hour and 11 minutes. That's sus. On a production system, that's real sus. If we weren't working on it, there's a reason that box probably went down. You know, we got redundant power. We've got all kinds of things. Boxes shouldn't be going down. And then, you know, I do a last pipe it through more to see who was on the server. And if I see a bunch of the devs on there, I'm like, how were the devs all doing congregating on the server at 11 at night? That's real sus as well. They were doing something, and they'll get on. Man, I'll tell you, this happens all the time. They'll be on the call and they'll be like, "We weren't on the server. We didn't do anything." I'm like, "You guys did something. Just get to confessing before I have to go figure it out." You know. And you find out that they were like changing whatever, and you know, all kinds of stuff. Find out one of them had root, and you're like, motherfuckers. Anyways. There's a reason we hold root so tightly as administrators and engineers, guys. It's not because we're assholes. We are assholes, but that's not why we hold that. It's because other people aren't ready to be... They're not ready to be in charge of it because they have too many other things to do. All right. Can you tell me what PID is listening to port 22 on your system? This is a part of security because what if I don't want port 22 being listened to? Out in the AWS space, there's actually a big effort to only use SSM to manage your system. So why would you have port 22 on? You say, well, but I want SSH in. Whoa, no. There's a whole bunch of thought process around no SSH, port 22, no RDP 3389. Turn those efforts off. Always come in through the cloud and always use SSM to manage your servers. There's a whole bunch of people that do that. So maybe you want to turn it off. How do you find what's listening to port 22 on your system? Who knows this one? This isn't a test. This is just me asking you guys how you would do it. How could you verify for yourself that port 22 is or isn't on the system? I like that. So SS-NTULP, grep-I for 22. You don't need the I. The I is just my ignore case. All right, so now I've got the process ID over here of 760, and then, so that's my PID, that's my process ID. So I can do a PS dash, well, there's a few things we could do. Hold on, so there's a few things we could do. We've got the process ID, so we could do PS dash EF grep dash I for SSHD, and there's our 760 right there, and there's some information about it. We also know that it was 760, so we could also just grep for maybe the 760, but remember, if there's other numbers, it could be, look, it could be covered inside of that. But okay, so we found that. But what if we also knew that it was this SSHD, and so then we could go something like system CTL status SSHD, and then we found that there was also the main PID of 760 right there. Oh, so WC Dozer asked a question, what's the product SSM that you should run from the cloud? So that's an AWS specific cloud. SSM stands for system, I think system script. It's something system manager. It's SSM is something system manager, but it's a AWS service that basically connects on the back end and can run scripts, and so it can run PowerShell scripts in Windows. It might be Secure System Manager. I'm not sure. We can look it up real quick. Hold on. SSM AWS. And SSM stands for, it's Systems Manager, but I think there's some other part to it. I don't know. Yeah, Systems Manager, basically. But it's another way to connect in. System Storage Manager? Yeah, but it connects to everything, Mad P, so I don't know. Secure, because buzzword. Yeah, secure is always buzzwords. So we can tell the system is listening on, oh, can you tell? You tell what PID is listening on port 22. So, by the way, we had all those cool commands, right? And all of those were pretty good. We did an ss-ntulp grep for 22. We did a we did a ps-ef grep for SSHD. That would probably find it. We did a systemctl status SSHD only because we knew, but we had to know for those to work. We had to know things about it. But what if I told, oh, did I hit insert sometime? So what if I told you that there's another way that we used earlier, LSOF-I port 22, that will also show you what's listening on port 22 on your system. So that's another way to see what process ID is listening on your system. For any port that you know is open from your ss-ntulp or ss or netstat or whatever, any port that's open, you can go and hit with an LSOF-I and see directly what's listening on there. And then look, here's your file descriptor. There's 3 for IPv4 and 4 for IPv6. So there's 2 different. Oh, LSOF can take you pretty deep. Yeah, I use LSOF like when I'm watching, man, like if I'm doing virus scans and I'm like, man, how long is that virus scan going to take? And I'll go watch the virus scanner opening files and stuff. So you can do a lot with LSOF because you can watch a specific process. Watch this, LSOF-P 760 now. So now we'll dig into the process. This is all the stuff, all the libraries and everything open by the SSHD daemon. So you're like, oh man, they're using an insecure libcrypt. I needed to go update that. I definitely need to restart that service. There's all kinds of things once you really start digging in that can be useful, but they all start with the question, can you tell me that port 22 is actually running on your system? Does that make sense to you guys? Like, we're doing very simple things, but we're finding out all these things about our servers. We're digging in all these different ways and all these different paths that we can kind of go once we know that something is or isn't running. Hey, Crazio or Crazio, hopefully this stuff's useful to you. I appreciate that Prime. Anytime you guys do Prime, you can use those anywhere. You can use those on your, buddies playing Dead by Daylight or something like that. So I always appreciate that. If you use AWS, there's SSM, but if Azure, there's some other stuff with Azure. Yeah, I don't know what Azure does. They use a Azure Automated Hybrid Connector. That's oh yeah. Look, have you guys ever, so speaking of Azure, so let's step back a second. In the cloud space, I have 7 certs. One is the Certified Cloud Security Practitioner from ISC Squared. That's probably the big one. Then I have 5 AWS certs, which are all the way up through the security one. So the security one's probably the most coveted of those. And then I have an AZ900. So I have an Azure one. The reason I bring up the Azure one is this. It was just mentioned over on the Twitch side about the Azure part. If you've ever listened to somebody, especially on like a 1.75 speed, because I watch videos faster, somebody try to explain Azure Blob Storage, just the amount of times they use the word blob, it just becomes like a funny word to you. You're just like, and then the this blob, simple blob, all these block blobs and and you're like, oh my god. And then it's like a tongue twister. It starts to sound like if any of you guys ever watched the show Arrested Development with Bob Law Blogs Law Blog. If you guys have never seen that, that's Bob Law. Yeah, anyways. I'm not gonna do it because then the CC will be making fun of me. But yeah, this is what we do. We do system stuff. So and Kit, hopefully this stuff's useful to you. So let's keep going. Can you tell me how the SSHD system was started on the system? So we know that it's running LSOF-I22. We know that this daemon is running. If we do a systemctl status SSHD, we can see that it's running, and we see that it's enabled, meaning that when the system starts, it's going to come up. But can you tell me about how the daemon was started? Can you tell me about like the command line part of it and how it was started and all that stuff? Here's some information about when it was started. But what if you wanted to dig in a little more? Do you guys know anything about how it was started, where it was started, all that kind of stuff? Mad P, this is an excellent start. But what if I showed you guys this one? I love showing you guys these ones that I've picked up over the years because I think that they're really good. Journal.ctl might give us some information, but watch this. What if I wanted to know like where it was actually started from? Like where's that config file? You can do a systemctl cat sshd, and this will show you that systemd, when it started, it went and looked in libsystemd system ssh service to start that. Yep, and then Haynes over there got the other one I'm going to show you is, this is one of my favorite ones. It's systemd analyze critical chain for SSH. And this will show you, oh, you got to give the whole name. You got to give the whole name. When you do this, this will show you the way that the system started it, all the way from the first slice all the way up to the SSH service. So if anything broke along the path, this is the critical path to get SSHD running on your system. So between systemctl cat, so this one is, can you show how systemd started SSHD? Yeah, we can do systemctl status SSH. Oops. We can do systemctl cat SSH. We can do systemd analyze critical chain. You gotta give the full name for that one to work. All right, that's a bunch of stuff. Systemctl edit full gives you nano. Systemd is a really big rabbit hole. There's a lot to do with systemd. Because, and one of the many reasons I like systemctl cat so much is there are like, I think last I checked, there's like 20 places that systemd can look to start files and start things on a system. There's etc systemd, there's libsystemd, there's just so many of them. But when you do this, you know exactly how this one was started. So you know that it's not somewhere else in the system, right? Please, your notes available for us on Discord. Aphoris TV, I will put these notes on Discord, yes. In fact, this is already up there, the PowerPoint slide for the Socratic method that we're using and just asking these questions, absolutely. But I'm just adding these notes now to walk through because there's some value in thinking through and just getting in a system and typing the commands in. There's if any of you have followed along, I can't imagine anybody's followed along with me for 5 hours, but if you have, and you've been typing these commands, even if you haven't been taking all the notes, you've still been seeing all these different things that are happening in systems, all these things that work a certain way, all this kind of stuff. So, okay. So we did that. I think we hammered that pretty good. There's other things that we can do. We can go, well, we can dig down into the pit if we wanted to, but I think that's pretty good. Also, we can see, this was one that I mentioned earlier, we can do LSOF-P. Once we know the process ID, which I think was 760 on this box, we can then go look at all the things that are running. But that's a little different, but the point is, I can see all the libraries and I can see what's listening and all that kind of stuff with an LSOF-P against the process ID. That's valuable. Okay. Can you list the kernel modules? This might not seem like a security thing, but it kind of is. It's also you trade off in systems world. You trade off between stability and security, and also productivity and security. Security always slows down productivity. What I mean by that is like having to log into servers and then having to re-authenticate with multi-factor authentication. But we accept that because for the security purposes, it's valuable to us to not have a system go down, be compromised, all those things, right? So can you list the kernel modules that are in place in this system and being used right now? So we can use uname-r for the kernel version, absolutely. That's very valuable. That's one of the most important things. LSmod is our buddy, yeah, and we got it on both sides, Haynes and Dertohaas. So it's funny actually. Both of those names seem German to me. So it looks like the Germans are taking over. So that's good. Good for the channel, right? Germans always end up being good engineers too, right? As far as a positive stereotype. But look at all this stuff here. We've got all this stuff that's going on, and if we wanted to, look, we could grep. Well, I was gonna say we can get rid of any used by 0, and I was gonna say we could get rid of anything that's not being used by something else. But really, right here, we have a lot of stuff. We've got the module name on the left, and what it's being used by on the right. So this inet diag is being used by TCP diag and UDP diag. And generally speaking, if you ever want to RM mod something and remove it, it can have nothing over here on the right. What does that mean? If I wanted to remove WireGuard right now, I should be able to do it because there's nothing over here. If I did an RM mod on WireGuard, I should be able to pull that module out of the kernel. But if I tried to do an RM mod on IP6 tables, this thing will say, no, buddy, you got all these tables over here. You got 1, 2, 3 things that are using it, so therefore you can't remove IP tables. That's almost universally how it works. I should be able to come in here and say, let's see, let's find one that I don't think is doing anything. Last time I did this, I ruined the server. But let's find one. ButterFS. I don't think ButterFS is doing anything. So RM mod, so remove mod, ButterFS. And if I do that, and then I go do my ls mod again and grep-i for ButterFS, I don't see it anymore. And maybe I just do my ls mod and eyeball it again real quick. I don't see it in there. Also, that's a lot to try to read through. So what I might do is this. Sort. And if you don't give sort any arguments, it'll sort alphabetically by the first one typically. So then I can just come in here and look at the B's. Is there ButterFS anymore? Nah, looks like we ripped it out. Because there was nothing that needed it, so it could just get yoinked out of the kernel. By the way, you might say, well, Scott, hold on. In this control plane server, you're using ext4 everywhere. Or do we have XFS? You're using ext4 everywhere. So do you need that ButterFS? And if you don't need that ButterFS, couldn't we just blacklist it so it doesn't come up? That's what we would do. Yeah, and part of hardening a system is closing down ports, removing unused software, and getting stuff out of the kernel that doesn't need to be there. Why does this stuff need to be in the effing kernel? I never want to use ButterFS. Not in this system. You can use it for fun in labs and stuff, but I'm not going to use it in this Ubuntu system. We've got ext4. We can go to XFS if we want. ButterFS is like 10 down the list before I would even get there, right? And that's not me talking trash about it. I'm just saying there's no reason for me to go to that file system. Should we see kernel module for virtualization? Yeah, there's virtualization ones in here. There's quite a few of them. They're the VirtIO ones. So these are VirtIO ones right here. And I think the one that I did was I pulled the VirtIO net one. And the funny thing was when I pulled virtio.net, that took my network too. So don't pull your virtio net because it's being used. Yeah. So there's all those things. Can you list kernel modules, lsmod? Right? And then how do we read it? Other stuff like that. Discovered ButterFS on Fedora with time shift, one snapshot a day, and update, break something, reboot, select snapshot. Yeah, that's fair. There are reasons to use it. Professionally though, I don't use it. Okay. By the way, we got a follow on the Twitch side, so thanks for that, guys. Let's keep going. Can you list kernel modules, lsmod? Can you verify that a file has not changed in the last 3 days? How would you do that? I don't think that Etsy cron tab has changed. And I see that June 8th is there. Yeah, how about this one? Stat. I can see it's access, it's modify, it's change. I would buy that for $1. Good. But hold on a second. Let's do something real quick. When I just looked at Etsy cron tab, so let's add both of these, right? Because ls-l on Etsy cron tab, and then stat Etsy cron tab. Okay, I like both of those, but hold on. ls-ltr should show the last time it's been used. Okay. Now hold on a second here. I just want to check something real quick. Let's check some. Let's MD5 sum. Etsy cron tab. That's going to be our hash for Etsy cron tab, right? It's a BF556. That's all you got to remember. BF556. Let's do something here real quick. Let's touch Etsy cron tab. I'm touching the file now. And then I'm going to do my ls. And I'm going to do my ls-l. Those are mine. And then we're going to do the stat. And then we're going to do the MD5 sum again. Do we agree that this file has not changed? BF556F1, B5, it hasn't changed, right? And 334B3, yeah, it hasn't changed. But this timestamp of when I touched it updated. So I got to pull off this. This doesn't help me any. Because if somebody just touches the file, it gets that date updated. But down here, we see that it was accessed. We also see that it was modified, and then it stamps it that it was changed. So that's super annoying, isn't it? Hey, B Ramirez, hopefully this stuff's useful to you. Thanks for the Prime. I was telling you guys earlier you can use those anywhere, so I appreciate when you use them here. But if you come down here, really the only thing that tells us it hasn't changed is some kind of hashing function. And I need to set a lab up for this because I don't think people use this, and this has been bought. This has been bought, I'm sure. Yeah, I think it's probably even open. It's probably even been bought. If Red Hat's using it, it was probably bought by Red Hat. But we used to use Tripwire back in the day. And what Tripwire does is it just hashes everything, and then if you move or change anything, it just alerts like a little Tripwire. You went and changed something in the file. You can go change and you can check things and you can generate reports, and there's all kinds of stuff that it's actually pretty good for. Let's go find if anybody's actually who's actually maintaining it. See if anybody's actually maintaining it anymore. It was released under GNU public license. Good. What's the actual license over here? GPL version 2, so that's been contested. You should move it to 3. Series of stealthy intrusions. This is useful. You can set your policies and all these things, but I wasn't sure if anybody was actually using these anymore, but this is a good way. There's also file systems that can do this kind of stuff as well. Typically, most of that stuff will be paid for, and it'll just keep everything on the up and up. But okay, hashing function, some kind of tripwire. All right, so can you verify that the file hasn't changed? Not with normal file system stuff, we really can't. I just wanted to show you guys that that's an important function. If you touch things, but also this is the way around things. In file systems, like your file system /temp has a log rotate in most modern Red Hat and Fedora and CentOS and stuff. It removes things after 30 days out of temp, right? But if you're touching them, you're refreshing that. So you can actually touch certain things to keep them from being removed. And sometimes we do that. We'll have like automatic cleanup inside of a storage area network, but then maybe because of a maintenance weekend or something, we'll take all the users off and they won't have time to get the warnings. So we'll touch all their stuff like the week before and give them an extra free week to get those warnings and stuff. But then we don't have to change our process. All we do is touch all the stuff. So that's a case for that, how you might use that kind of as an engineer. Yeah, hashes are a good way, Mad P, absolutely, to verify that things haven't changed in transmit and that kind of stuff. Yeah. All right. So okay. So can you verify the hash of a file before and after you copy it to a different server? Oh, my lab environment's gonna die again. I can't believe I'm hitting 5 hours. I don't normally stream for this long, but I'm gonna refresh that environment. That environment is pinned on both sides, so you guys can go in and be in the same lab environment that I'm in. And I'm going to move that over, and I'm just going to make this a bigger thing. And we're just using the same lab over and over again, even though we're not doing the actual lab. We're just using the lab to set these things up. But can you verify the hash of a server before and after you copy it to another server or a file? So I'm going to cat my etc cron tab. That's one I like to use. There's a file. And if I can do a MD5, MD5 sum against etc cron tab. I can do a SHA-1 sum against etc cron tab. Now we don't use SHA-1 sums anymore because they have been deprecated, but you also have other SHA up to even I think 512 in our system, so that's a longer hash. Hash takes no matter what size input you give it, it will always give a fixed length output of a certain number of bits. And in this case, this one is however many it is. I want to say this one, I thought this one was 32 and this one was 128, but I could be wrong. But anyway, so they're fixed length, they're there. And then it says I want to push this to another server. So I'm going to SCP my etc cron tab over to node 01, and maybe I'm going to send it to temp cron tab dot, I don't know, dot control plane. Maybe, I don't know, something like that for fun. Then can I SSH to node 01 and send a command over there to MD5 sum my etc my temp cron tab dot control plane. Can't tab because it's on a different machine. There's that. I can change this to SHA-1 sum, and there is my SHA-512 sum if I wanted to, right? So now I got all of those, and I can verify, yeah, nothing changed in transmit. So can you verify the hash of a server before and after you copy it to another system? Yeah. Yeah, so you do an MD5 sum or whatever against etc cron tab, then you SCP etc cron tab over to node 01 temp cron tab, something like that, and then your last command would be SSH node 01, and then you would do a MD5 sum on temp cron tab, right? Just like that. That would do it. That's it. Super simple, right? Check it on one side, push it to the other, check it again. And you know, maybe you never in the course of your career have to ever do something like what I just did. But maybe you want to hash something to check. A very common way that we do this is, or a place that we do this, is when we download stuff from mirrors. This used to be very common back in the day. You'd go to download some piece of software. You'd go to download like a Yellow Dog version of Linux back in the day. There was Yellow Dog Linux, right? And you would go and you would go to download it, but then there would be these mirror sites all over, typically at college campuses. And what they would have is from the primary site where Yellow Dog was kept, actually linuxdistros.org was huge for this, you would go and you would download the MD5 sum. So you would get this right here for the file. So you would get that out of band. Then you would go and you would download your ISO from wherever you wanted, and then you would compare them. And you would compare, and they would be exactly the same or they wouldn't. And if they weren't the same, there's some shenanigans going on, and you would throw it out, and you would go download another one. And that's how we used to keep software secure. It's an out-of-band management process of passing the hashes. And you might say they don't really do that anymore. Yeah, they do. Watch. Let's go to Kali. Kali.org. Let's go to download Kali. And I'm going to download, in my case, I download the installer images and I put the ISO directly on my system. There's the SHA-1 sum. Or this is the SHA-256 sum for, let's see, here's the weekly, the net installer, the everything. It's for air-gapped folks that need everything. That's going to be a huge file. 11 gigs, that's all of the different stuff in there. This one is a minimal, not a minimal install, but it's got less stuff on it. And what is this version for? What version are we on? 24.2. Do I have 24.2 in my lab environment? Let's see. I don't think I have anything that high. Hostbox holds ISOs for me. And I've got Kali 23.3. That's the most recent one. I got 22.4. So, but I could run this if I had the most recent one. I could go drop it in there, and then I could take that SHA-1 sum, or they've got a SHA-256 sum, and I could then compare it against there. So that's a thing that you can do. It's still valid. Still a very valid way to find that nothing changed between the shenanigans, you know, any kind of shenanigans. We use those in the Ansible lab when we push our files over. We make sure that our files are exactly the same. And the reason we do that too is because other admins might have gotten in and mucked around in your files, and they may have been doing it for the right reasons. They may have gotten a security alert and a warning, and they may have updated all the places that they knew that there was some version of code or something, and then they just repackaged it up and said, Scott will never notice. Scott will notice because Scott hashes everything. I'm kind of a jerk like that. But the reason is because if my name's on it, I want it to work, right? This is the same thing for you as engineers. You want, like, if you put your name on something, you want that something to work. You don't want it to be like questioned later, like, hey, why did I push all this last month and it worked, and then I pushed it this month and I thought it was deploying, but it didn't work. And I'm like, oh, no. My stuff breaks early and tells you you're using the wrong, this is not the hashed version. You have a different version of the tarball, you know, the thing that Scott packaged and made sure worked. And then it's not a big deal, by the way. Just let me know. I'll go verify the thing in my test environments, and then we'll move my hash forward to the right piece of software. I have to do this all the time anyways, but I just need to know. Because you can't just go changing stuff in environments and not testing it first. That's a very important thing in systems engineering in general, especially if you want a good name, you need to have things work. So, okay, can you encrypt a file using VI? Can I encrypt a file via? Can't read it. So VI with a -X option will write your file with a blowfish encryption. So if we man VI, we go to encryption. -X will tell us we can have an encryption key, and that's the only thing. And then I think it doesn't give you any other information here, but you can go read about it and go find out the types of encryption that they put into this. Last I checked, it was blowfish. But yeah, so now nobody else can read that file unless they know our basic, my little basic, which I've probably already forgotten. There we go. This is a test. That's actually the password too. Except it looks like that. But that's our password. So our password is in the password file. That's like when the server goes down and the backup's on the server. Backup to the server's on the server. Oh man, that's a failure. That's a failure. All right, anyways, can you encrypt a file with VI? Yes. Boom. Too easy, right? Do I have one of these sessions on Ansible? Yeah, so I have, Heather, the question is, somebody asked on the YouTube side, do I have a session on Ansible? So there's a few things on Ansible around here. I have, if you come to the Killer Coda and the Het Tanis labs, or you just go, our lab is pinned up there, and then you can just go back from there. I have a bunch of Ansible labs. I do have quite a few talks on, like our live talks that just go through Ansible. And I do have this is in the Discord. I have one of these same things called Socratic Method, where is it at? Right there. Socratic Method Ansible. So let me pull that up. And Socratic Method Ansible looks like this. I'll make this a little bigger so you guys can see it. This is in the Discord for anybody that wants it. But it looks like this. Learning Ansible through the Socratic Method, so you ask questions. And here's the first lab. What's the version of Ansible you're using? Why is this important to know? So you do the first lab, and then you answer these questions. By the way, this is very similar to the book, but this is not the book. The book has other things and digging deeper and stuff. But these are supplements to the lab. Then can you show the version of Ansible? Can you show the documentation? And then lab 2. Then you go, and these labs are very short. But can you do all these things? Add a -vvv to the ping command and see how it changes. So yeah, I do have this for Ansible, and I have talked through it before. I know it's up on YouTube somewhere, but it's probably not organized anywhere. But these are questions about a whole bunch of them. Can you inherit 2 roles inside of a playbook? And then best way to reach me is on Discord. So there you go, boom. All right, so we're still doing Linux. That was just a question about Ansible, and we do have something like this on Ansible. You guys are welcome to. These labs are free. I can't even believe the value you can get out of Killer Coda for free. I mean, they have a thing you can pay. I've never paid them anything. I just build labs, and it works great for me. Anyways, where are we at? We were here in the lab. What's the next thing? For any user, can you determine their sudo permissions? So I'm just going to say user add -m Scott. Scott user. How do I figure out what permissions Scott has for sudo? How do I determine their sudo permissions? I mean, I can ID Scott, and I can see my groups, my primary group and my secondary groups if there are any. But what's my command for sudo? Who knows this? This has probably been like one of the biggest game changers for me. Did all of this, your teaching and material, come from you doing it for yourself out of curiosity? Yeah, Nits Night Strike BG said, did all your teachings and materials come from you learning this yourself and not learn eventually turn it into first? Yeah, so I learned all my Linux in the wild. I took one class in college probably in about 2004 on Linux, and all the rest of the stuff I learned in the wild. I wish I had groups to join. I had really good mentors, though. I had really good engineers. You could check the sudoers file. Yeah. But I've been in environments where the sudoers file is 2,000 lines. So you can check sudoers, yeah. For any user, can you determine their sudo permissions? Ah, somebody had it. Sudo -L-U Scott. Scott's not allowed to do nothing. I love this one. Sudo -L-U some user. Then let's muck around with his permissions. Let's give him some more permissions here. So we'll grab that. Can we determine their permissions? Yes. And then let's give him some permissions just to mess around with him. Let's cat etc sudoers, and there's a admin group and a sudo group. So we got an admin group and a sudo group. What if I just say vi etc group, right? And I go to /sudo, and then I go down here and Ubuntu's in sudo, and I just add Scott right here. And then I just look at Scott's ID, and I see that he's in the group sudo, and then I look at his permissions, and now he can do whatever he wants. Yeah, sudo -L-U is one of my favorite commands I ever picked up, because it shows me exactly what a full run through of those permission sets are going to be for any one user, and it's excellent. It always works. I have a lab that goes specifically over this in the security section. It's called the attempted sudo access. So users are trying to do stuff with sudo that they're not supposed to, and then you find out one of the users is allowed to do something, so you give them permissions, and then you're like, well, I gave them too much permission, so you pull some of the permissions back, and that's kind of all this stuff. That's what we're doing here with sudo permissions. But sudo-l-U Scott will show you exactly how this system is evaluating its sudoers and all the pieces around sudoers for that user's permissions. It's very useful. The other way I could have done it was I could have tried to become the Scott user and then tried to do things, but again, that might take too long. This is my favorite way because it tells me what the system sees, and I can just snap through it and go. And I could run this. Look, if I had 50 servers and I ran this command across all of them, I could very quickly see on like 3 or 4 servers if my sudoers is messed up because my user isn't given permission or whatever, right? So there we go. Oh, the book command. Hold on, somebody did book. There's no book command on the YouTube side, but on the Twitch side, there's the book command. Hold on, I'll give you guys for people that want the book. Again, I don't think you guys need the book unless you're already pretty invested in learning Linux. But the book is there. I would tell you well before you ever do that, come hang out and do Discord, shop with some of the engineers. Hell, we got a big event coming up. We got a huge event coming up in August, right at the end. So let's go back up here. We go all the way up here. We've got a big event. We're turning 5 years old on Discord, and the group itself, our Professional Linux Users group, is actually 10 years old in August. We've been running it. I ran out of my house well before the other stuff. Dopar, you said, can you check where the permission's coming from? Yeah, I think there's actually a way to do that. Let me see. But there's all these different talks, and they're all free. You can come to any or all of them. And actually, I'm going to have a challenge, kind of like an Easter egg hunt. Whoever comes to the most is going to get some kind of prize. Not only are you going to get the prize of listening and talking to a bunch of engineers in different areas that maybe interest you, but you're also going to get like a tangible prize. Like, I'm either going to do a Humble Bundle, or I'm going to do like a $50 Amazon gift card or something. It'll be something. But the point is, it's the person who finds the most of the little Easter eggs that I'm going to hide in the different presentations. So I'm not even going to hide them. They're going to be out in the open, but the point is it'll be there. Okay. Okay, so let me get that out of the way. Let's keep going. Yeah, so the question was, can we see where those permissions came from? So the Scott user has all of the following commands. We'd probably have to look at the user. I'm trying to think if with the sudo-l, let's go look at the -l. You know, I don't think so. The question was, can you see where the permission's coming from? And I would say, I don't think you can. I think this is just super useful for finding where the permissions are. And then I guess it would be on you to know your files, I guess, because there's two places it can come from. It can come from your etc sudoers file. It can be here. Or this include right here, it looks like it's commented out, but that's not a comment. This is one of the few places where a £sign is not a comment. All these other things, it is a comment. But this is actually being used. So your sudoers, ls-l etc sudoers.d is an inheritable directory because of that. And there are two things in here. So if we cat etc sudoers 90 etc sudoers.d 90, and then you would see that that's where they've added in the Ubuntu to be able to do everything with no password, right? So those are the two places you have to look. But for me, because what I try to do, so everywhere I've ever been, people have exploded their Etsy sudoers out to this big monster file. And what I always do when I get there is I take that big monster file and I strip out some of these things, like the this right here, the include dir, because it'll make it recursive, and I move it down into sudoers.old inside of the Etsy sudoers directory. Then I put a clean sudoers in there, and the clean sudoers doesn't get any permissions that are any special besides just the base ones that come with like Red Hat. I normally do this on Red Hat systems. And then what I do is, if you're like, well, hold on, all of our our computer science guys that work directly with our team to feed out and teach the researchers how to do stuff, all of those guys need to have wheel access. And I go, awesome. The name of their group dot whatever. So I'll just do the name of their group. That goes in Etsy sudoers.d everywhere in my environment. And then they have those permissions everywhere. And when it comes time to audit who has permissions where, I can just run through with an Ansible playbook, check my Etsy sudoers.d for all the permissions that people should or shouldn't have. Then, if over here there's like a little pocket of engineers on these dev nodes, and these dev node engineers are supposed to have, I don't know, certain permissions, but only on their nodes, I can push them via Ansible just over there. And when I do my audits, I see, oh yeah, that little patch of servers over there has those guys with their dev node. They have root over there, but only on those boxes, and only because, right? So it becomes, this is why I'm such a big fan of a .d directory. It's an extensible directory off of your Etsy sudoers. So Etsy sudoers is sitting there doing all its sudoers stuff. And everything in .d gets appended to the end. It gets appended to the end of the file. That's how the order of execution goes. If you ever put something in earlier and then you do it in the .d, you'll see that it overrides. You can go play with that. Also, .d is read in order, so you can override in .d, which I think is, don't go overriding stuff. That it's like layering. It's just going to make you mad, like at the end of the day. But my point in saying all that is understanding order of precedence is still super important as an engineer. When you do this, or when I do this, I keep everything super clean. Like my Etsy sudoers is just a small, tight little file that's not doing anything else. And Etsy sudoers.d is all my individual permissions. So it's very easy for my little audit Ansible playbook to come through every day and just see all the permissions for any servers. And if anything's aberrant from what I expect, it immediately tells me. It's super simple. It's super simple, but knowing that exists, those are the only two places that permissions can come from. My tiny little file that has nothing in it, that's just a nice little OS level file, and then all of my other individual command sets. So hopefully that answers like how I do it professionally, because that is what I do. All right, we spent enough time on sudoers. For all the users, can you count a list of what default? Oh, that's fun. This one, I'm getting more bashy here. So for all users, can you list a count of what default shells they have? All right, this stuff isn't super simple. Some of this stuff's getting more complex. Let's answer that in parts. Where is the default shell for every user located? Does anybody know that? Who knows where it is? Etsy Pass WD. Does anybody know what field it is? There's 7 fields across Etsy Pass WD. You need to memorize them before you join a Discord. I'm just kidding. No, you don't need to memorize anything. You can just join the Discord. It's the last one. It is always the last one. It's the 7th one. So actually, that's funny. I'm going to show you 2 ways to call it. If it was ever anything other than the last one, if it was ever anything other than the 7th one, but it was always the last one, I'll show you how to call that too. But it's always going to be the 7th one. So let's do this real quick. Let's cat Etsy Pass WD, and then we'll catch that to the output of awk -capital F colon, because colon is our field delimiter there. And I'm going to print out the 7th field. There's the 7th field all the way across. But I said, can you list a count of what all default shells there are? So then we got to do this little guy, sort them all, put them in order, and then unique-c, and it'll count them all. Isn't default shell an environment variable too? It is. Super nerd, that's where it comes from though. It's in your Etsy Pass WD. That's where it comes from default. Then you might say, well, could I change my environmental variable later? you can change your if you have other shells in your environment, you can change them inside of your bash shells. Count dash L, the new line. Watch this. I'll show you guys a sneaky little sneaky trick. So this is one. Did you know that if you ever have like a weird, you always have, like, have you guys ever like gotten data from somebody and there's like it's just a mess, right? But the last field is always correct. This is a case where this comes up. IP adder. Let's say on this one, I always wanted. So let's do IP adder, and then we'll look for. Let's look for grep-i mtu, right? And if you look at that, and you see that, you'll notice that there's a different number of fields. Like on the first one, let's see, especially with the spaces, there are different number of fields across here. Q length, yeah. There's definitely more space on this one. In fact, I'll prove it to you. No. We actually don't even need regex yet. Watch this. I want to show you guys this cool. You know, they hate them for this one trick. Watch this. I'm gonna do an NF here, capital NF, and it'll give me the same output. So let's do it on this other one real quick, and I'll show you guys. Watch. NF is the number of fields, so it's a really useful one. But watch. I'm stepping a far field for a second. Yeah. Let's do this MTU one. And let's say I wanted, I'm just gonna, let's pretend for a second. Let's go awk, and let's pretend that we wanted 10. We're just testing here. And 10 would be group. So that's always there. And then let's say 11 is always default. But see how sometimes default, and then hold on. And then but 12 is sometimes Q length, and then 13 is sometimes that. But I say, no, Scott, what I needed was the last one of all the lines, no matter how many lines there were. I know my data is garbage, right? Whatever data I'm pulling in. But what I do know that I need 100% for sure is the last thing on the line. This will do it for you. So some lines ended at 11. Some lines ended at 12. Some lines ended at 13. But every line ended at number of fields for that line. Right? So I think that's super useful. This is one of the most useful things, because sometimes you get, I don't want to say you get garbage data, but to know how to strip the front of the data off. And then you might say, well, Scott, what if I needed the field before it? I think you can do NF -1 like that. Yeah. So you can get 1 back, 2 back, 3 back, right? So you can start stepping back through them like that if you needed to. It's a super useful trick. Mr. Muddy Pants, it is a cool trick, right? But it's also a useful trick. Like it's what is the start? I don't know the start of the line. I think it's like there's a way to start at the front. This is the only one I use, so this is the only one I remember. You guys got to remember, I'm like I have a lot of cool tricks, but they're the only tricks I know. I don't know if you were like, Scott, you're an encyclopedia, because people tell me that about stuff. I'm like, no, I'm not. I know the shit that I know how to get working. Should it be $1 one is the first one always. You're right. But what I'm saying is yeah, I don't know any other. Yeah, that would always be the first part of the line. Yeah, I didn't even think about that. But NF is the number of fields, so it always gives you the last part of the line. Even if there's, it's just like there's an example that I can think of where, watch this. This. So this right here, if we were to grab this with a bunch of other data, and then maybe we were not doing, we were using CSV or something. CSV, comma separated values, which is a common, comes out, and then we give it to managers. We use CSV because then they can put it in Excel and they can do pivot tables and stuff with it. This will break it because of this. So this will break your CSV. Yeah. This is an older one. This is in the lab environment, right? So, all right. Anyway, so what default shells they have? Yeah, that was easy to find, right? We're just figuring the stuff out. That's the goal. And I tell you guys, one of the things that I didn't realize, I was later on in my career, this was a few years ago, I was sitting with some of the like older Unix admins inside of the NOAA project, the National Oceanographic Atmospheric Agency, and we were just sitting around working on stuff, and one of the guys was like, whoa, what was that thing that you just did, to one of the other guys? And he's like, oh, this, I don't know, this is some trick that I always did and it always worked. And then he's like, oh, that's cool. And then it's like I picked up all these different things from watching those guys, and then those guys picked stuff up for me. And it was like, it's almost like when you sit with the engineers, if you guys have ever heard this, sit with the old warriors, the conversation's different. I feel like it's the same thing with the engineers. Is it's like sit with the engineers and you'll pick up the little engineering tricks. Dayton said didn't recognize me with the fresh haircut. Yeah, and I shaved too. So shave and a haircut, 2 bits. All right. So can you verify the individual user's list of limits of open files, and do you know where to change this? So this one's got 2 questions to it. Where do you change their limits? And can you see a user's set of limits? Yep, I think Haynes got it. ulimit -a-u Scott. This is what Scott can do in my environment. ulimit -a-u Scott, or whatever your user is, right? And that may not be different than the root user, but it could be. Ulimit -a, and then this would be my user. So I can specify users other than me if I'm root, which is very common. Very rarely as the root user do I give a crap about any of this stuff. But very often do I care about like a service account. Like there's a service account Scott that runs a Scott application in an environment, and they're having a problem doing something. That's very common. And then, yeah, Haynes got the other part too, which is vi your etc security limits.conf file, right? That's where you'd change it. Where do you change user limits? In there. Boom. And then down here, you can come down and see if there's any. These tend to be defaults here, but there's nothing in here that's set right now. Why did I never use ulimit? Write that down. Yeah. Why would you ever want to limit how many open files the user... Oh my god, Mr. Muddy Pants. Mr. Muddy Pants, hold on. Hold on. Oh god. Oh god. To protect the users from themselves. Users are going to use... Users are like little baby toddlers walking around on the top of a roof with no protection. They will, and I know that sounds really morbid, but a user will absolutely crush whatever system they're on with no regard for their safety, the system safety. You could be like, hey, if this server goes down, it's going to kill 100 people. And they would be like, open file, fork bomb, crash the server. You have to protect users from themselves. Users are... Man... Users are going to use. And you might say, Scott, you just went real cynical. I've been doing this for 20-something years, so I am super cynical on what users will do if you don't lock them down. I have seen... Let me tell you. We've got this tool. We use Slurm, right? Slurm is this awesome SkedgeMD, right? SkedgeMD. I even got a lab that shows you how to install Slurm. Slurm is this awesome tool in an environment that controls how everything happens, right? It's you build this big cluster, you give everything the same backend storage, the same libraries. Users can come in and submit batch jobs and run jobs against the Slurm control daemon. It'll go out to its compute nodes, process across thousands of nodes, and then come back. We had a user in there. Look, we had users accidentally doing watch commands too often and crashing this stuff. That's one. Users were like, well, I'm just running a watch command. And you're like, your watch command is getting sent to a daemon and going to like thousands of servers. You guys are crushing the system. So we had to limit their use of watch commands. We had a user that figured out, because we have all these accounting, like you can only kick off so many jobs and stuff. So they were starting stuff and then fork bombing out on the systems in Python to like get more processing than they were supposed to have. And they were using 90% of our cluster. Our cluster generates, and this is some generic numbers for people that care. Our cluster generates more than $1 billion in revenue for the college, one of the colleges I work for. And this person was using 90% of it by fork bombing Python for whatever bullshit stuff they were doing. I mean, they weren't the medical team, they weren't the business team, they were just some researcher out there. So, anyways, my point is, users without limits, users are basically like you ever play one of those games where things just bounce off the walls, but then they eventually find a little hole and they go like this and they bounce out and they escape or whatever. That's what users are like. Mr. Muddy Pants, there are defaults. A lot of the enterprise. So this system probably doesn't have high defaults because most Linux operating systems come out of the box empty. But most environments that are enterprise Linux, we lock these down. Yeah. So we will like hard set a user at like 64,000 or 65,000 open files or something, and only so many process threads for sure. We typically lock users down at like 1,024 process threads unless they need more for some reason. And there are valid reasons to get more, but you need to explain them, because I'm telling you right now, I'm not just going to let you wander around like this until you bounce out and walk into the minefield and kill us all, you know. And I'm telling you, I've watched users just crush systems. Users are going to use, man. Users are going to use. And then we used to joke around about if you make something idiot-proof, they'll make a better idiot. They're always working on making better idiots. Not that users are all idiots. I'm just saying, like you'll get cynical over time. Then there's another one. There's I got a whole bunch of them, but there's the picnic. Problem in chair, not in computer. Or PEBCAC, problems exist between keyboard and chair, or chair and keyboard in that case. I'm not as big a fan of the ID10T errors, but I love the picnic error. The picnic is the problem in chair, not in computer. Yeah, and if you ever see that written on one of your tickets, that means that you're kind of a dum-dum. All right. Or you're causing problems where you shouldn't. All right. All right, so now we're out of security, but some of these things will still look like security, so don't worry about that. General system. Can you show me how the system was booted by Grub? And where would you do that? So this is general. Can you show me how it was booted by Grub? He calls you a user. That's funny. Layer 8 issue. I like that, super nerd. That's pretty good. How it was booted. Like what's the command line call? How did this server come up from cold metal? Cold, dead, in this case, virtual machine metal. But when this server came up and handed off to the kernel, how did it happen? Dmessage is the king of that. I'm going to do a dmessage head 20. That's pretty good. Yep. So dmessage with like a head on it or something. What about, so in here, what does it show us? It shows us exactly as the system got called in. It shows us the command line boot image. This is the exact call of the command line as the server was started. Did you know you could get this from somewhere else? Did you know that you can cat proc cmd line and it'll show you exactly how the system was booted? And I love that when I do like an xdish command. Xdish command is xdish is a way to hit a bunch of servers, and then you can pipe it through an xdish back-c and it'll count everything back up. And I have actually an example of that, I think. Do I have that somewhere? Hold on. Let me see. See if I have this. Hold on. I'm looking at my presentations real quick. Linux Systems Administration. Come on. This is my Linux Systems Administration talk. And I might not have it in here, guys. If I did have it, it would have been right here. Nope, I don't have it. Okay. But anyways, Xdish back will pull back all that stuff. Journal CTL. I don't know if Journal CTL will give us from the start. Logs begin at the time it started. Okay. Yeah, it does give us the command line boot. I do like that. Okay. Yeah, Journal CTL is actually, that's pretty good. That will give us the system all the way back. Okay. That's actually pretty good. I like that. Gives us the kernel starting up. But one limitation of Journal CTL with that is I know Journal CTL will roll. If you've got a server that's up like over 30 days, you might not be able to see that far back. So that's possible. Something to think about. dmessage does too, actually. So that's not that big of a deal. But I love to go to servers and see cat-proc command line and then aggregate them all up and see if any, like 100 servers or even 1,000 servers, are any of them different. And the 1 or 2 or 3 that are different got built a different way, and I know that I need to go fix them back to my baseline. Because again, you guys probably think I'm crazy, but that like level of control I need over my servers, I just need to have control of them. I need to know how they're doing, because how am I gonna maintain them if I'm not in control of them, right? So I need to make sure that all the things are being started properly and booted properly and all that kind of stuff. So all right, that's good for that. Can you tell me the running kernel version? What's my running kernel version? Surprised nobody typed it yet. Maybe everybody's asleep. I haven't been talking a long time. uname-r. That's it. That's the best way to find the kernel version. Ah, dmessage-k. Will that give me the kernel version? I mean, I guess that'll show me the kernel version like anything would show me the kernel version. I mean, any dmessage, I guess, will show. No, that's fine. Any of these things at the top would show me the kernel version. That's true. There's our version right there. Useful information for junior type engineers is this is called semantic versioning of numbers. This is the major version here of the kernel. This is the minor version, and this is the patch version right here. If you need to know more about semantic versioning, semver.org will tell you all kinds of stuff about it. This is, look, this is platform engineering, Linux engineering, systems engineering, software engineering. I don't care where you're at. You're using semantic versioning. And this is a very structured and very correct way to do things, and it's the way that you will want to like look at things. Even if you're not the guy pushing the software out, you need to know the major, the minor, and the patch release versions of things, because that actually will help you to figure out if things are compatible. You'll look at compatibility matrices and stuff. So like you'll pull down like a GPFS like compatibility matrix for the different versions and stuff, and then they'll be like, and if you're in a 5.4 with any patch version, it'll work with up to this version of whatever. And you're like sitting there, and look, it's rough. You got to like figure out. You got to like kind of hold your finger in one place and figure out where you're at all the way across the board. But we have to do these things to ensure stability across our clusters, especially in big, high performance compute type stuff. Yeah, it'll also warn you. Yeah, Nike Strike just pointed out something that's really good. It'll tell you if something is bleeding edge or not. There's Ranger. Dent Dam. Hopefully this stuff's useful to you. cat-proc version. Let's see if that goes. Ah, there you go. I didn't even know about that one. Another place to go find what's going on in your system. And hey SM, how's it going? I tell you guys all the time, you don't need to know 100 different ways to do this stuff. You need to know one good one. I tell you guys all the time, like people get on me all the time for using Screen, and they don't do it as much as they used to, but they'd be like, hey, why aren't you using Tmux? It's more modern, this and this. And I'm like, I don't know, man. I got screen to work one day, and I just kept using it, and here I am, like senior staff principal. I mean, they have all kinds of different titles depending on where you're at. But I'm like, I'm the engineer in charge of things, and I still just use screen because it's the one that worked for me. I don't spend a lot of time like setting up my environments. I do very vanilla engineering, but my stuff works. And that's why people like me. That's why managers like me, right? Managers like me because of this one trick. I make shit work. All right. Anyway, so can you tell the running version of the kernel? SM, whose emote is that? I think that's I don't even know whose that is. SM might know though. SM's around pretty regularly. Can you tell me how many versions of the kernel you have available if we need to go back to an old version of the kernel? So we know the version of the kernel we're on, but do I have any old versions of the kernel that I can go back to? And again, I'm not trying to trick anybody, guys. I'm just giving you, again, Socratic method, asking questions, thinking through, can we do these things? This is my my shell setup, right? Or my screen. All right, that's my home lab. So, those emotes were very long ago. I don't think you can earn anymore. Nice. Well, that's unfortunate because we want people to have all the emotes they want. Depackaged SL grep kernel. Okay. Look for kernel. Okay. There's some versions. So we've got the one we're on, and then maybe there's this 54812. Okay, I don't. That might not be as good as what I was thinking. But we're 131 and there's 147. That's interesting that we're back behind whatever kernel version we patched to. So we're patched to a newer version. But, okay. I like the ls boot. That's what I normally use. So let's say, can you tell me how many older versions of the kernel do we have available? ls boot. And ls-l on boot with typically VM will show us all the things we might want to know about the kernels that we do have. So on this box, the question might be, I do really like this one, ls-l on boot, and then it's VM. So those are the kernels that we have. We've got one kernel, and then we've got two links to that same kernel. We don't have a backup kernel, guys. This box is not enterprise ready. And guys, I will tell you right now, I've gotten in more dragged out, just going to the mat fights with my engineering teams over this concept right here, in front of all the way up to sea levels, all the way up to the sea levels, like at AAA. And you guys, these things, I mean, I would go to town with these engineers, the security, governance, risk, and compliance teams about this. They would say that the older kernels that we had, now granted, we had an old kernel always. They would say the old version of the kernel is vulnerable in all the ways that a kernel is vulnerable, and I would say it is not. And they would say, well, then why is it still here if you're not using it? And I would say, because you can't just run on one kernel. A kernel, a car can have one engine in it, and if the car breaks down, they'll fix the engine, whatever, the car will be down. A server is not like that. A server has to have the old version of the engine in the trunk so that you can put it back if something breaks on patch day, or something breaks down the line and we need to step all of our servers back. So they would argue, well, you're introducing all these vulnerabilities that are supposed to be patched out. And I'm like, but I'm not. They're down. The service is down. If the question was having some vulnerability or having all of our servers down because of a production, problem, I'm pretty sure management would say, go back to the old working kernel. We'll accept that risk of the vulnerability because literally everything is better than being down from a money-making standpoint, right? So anyways, the point is I used to get in these drag down fights with these guys, and they'd be like, it's still a vulnerability. And I'm like, but it's not. It's just sitting there. It's sitting there off. Somebody said, can I ask a question out of topic? Do I have to know Linux that much for cloud security engineering? I think that for cloud security engineering, you will do yourself a favor by knowing more Linux, but I don't think it's necessary. But then again, I come from a background of I already knew a bunch of Linux, and then I did all my cloud security stuff. So like I have a CCSP, I have an AWS security certification. And do I have any other ones that are directly related to cloud? I mean, I have a bunch of AWS certs, but like those are my 2 security ones. Yeah, I don't think you need Linux for that. Like there were no specifically Linux questions on any of those certs. I just think that almost everything you're going to do is going to tie back to Linux. Almost anything you're going to do in the security space is going to tie back to Linux anyways, I think. Let's try this one. Apollo had a pretty good one. Let's see this one. apt list installed grep Linux image. Look at that. I like that. Look, guys, you might think that I sit up here and like know everything, and I hope you don't think that. In fact, I hope that you definitely don't think that, because you should very quickly say, if this guy can do it, I can do it. And you're right, you can. But I can tell you right now, I learn stuff every time I do that. There's probably like 10 commands that I've written in here that I had never seen before today. And they work. We're testing them. This is this old engineering adage I always tell you guys: one test is worth 1,000 opinions. Guess what? Apollo Python could have came in here and typed that, and I could have been like, no, that won't work. But we just did it, and it did work. Why would I have to argue with him? I mean, it worked. That's actually really good. So yeah, that's just the ones installed by app. True. This is true of all package managers. It's the same thing with when you do like RPM in Red Hat. If somebody has installed a package by build, if they've built a package somewhere, RPM doesn't know about it, which is, by the way, in production, I will never have a compiler. People are like, oh, you must be a real hard ass. Nope, you will not have a compiler in my production environment. That's insanity, guys. The ability to build and change things in a production environment is exactly what shouldn't be in a production environment. That shit should be built and spun and tested through and all that stuff in our dev environments and our CI/CD pipelines, right? Everybody wants to talk about CI/CD, but then when it comes time to do it, nobody wants to actually lock down prod. I lock down prod. I just remove compilers. I never have compilers in my prod environment. And then people are like, well, I can't change it. I know you can't change things. You got to change things back there and bring them through. But yeah, Yenis, hopefully that's a good answer. But yeah, I don't think you need Linux. I just think Linux is such a good, like everything kind of goes back to Linux in engineering. But that's probably me because I've been doing it so long and I'm kind of insane. But I enjoy it, right? This is the fun stuff that we do, and this is we're asking questions here and walking through things, and I'm learning stuff as we go. Had Git in their web app and just put deny Git in there. All right, so let me finish this up. Let's go with another question. Can you show, this is a question that kind of looks like something from earlier, but it's still a valuable system thing. Can you show that the SSHD service is running? How would you see that SSHD, yeah, that's a good one. System CTL status SSH or SSHD. They'll work either way, so that's good. What about what other things? PS, AUX, grep. Whoops. I can see it running there. Good, good. By the way, from here I see the PID. And I see that PID maps to right there. So that's boom. I can see that. That's pretty good. I like it. SS and yeah. Port 22. Boom. Or just SSH. Right? There we go. So any of those. There's our history. System CTL status SSH. PS-AUX. Grep SSH, ss-ntulp, grep-i for SSH, that would work. And what about this one? This is, again, I went over this before, but this is one of my favorites. lsof-i22. If I know the port number already, I love just looking at the port number that I expect something to be on. What about 53? What's 53? Anybody know what 53 is? DNS, right? By default, 53 is always DNS. LSOF, the socket. Yeah. Yeah, so like there's, I mean, look at all the, I mean, there's just, I tell you guys, in the Linux engineering space, everything points to something else. It's like a game of chutes and ladders. And really, you just need to know. I mean, look at all these commands we're coming up with. People are giving me commands that I didn't know. But it's all these things that we just ask questions and then sit and hang out with the others. We are root. So yeah, that's how we're seeing it. I am the root user, in case you guys didn't know. But we talked about this right at the beginning. There's a PS1 variable in these lab environments that don't have, that don't look right. So if you wanted to, you can set your PS1 to, you know, if you're just like, hey, I need that pound sign, I need to know that I have the power, you could set that, right? So you can, it's up to you how you want to set your environment up, but strictly speaking, it doesn't matter that much, right? But those are ways that I can see that SSHD is running on my box. Yep. I think that's pretty good. Okay. What about, let's keep going. Can you show, this one's good. Can you show how the SSHD process was started? What's the parent process? We might have nmap. I don't know if we have nmap on this box. No, we don't. Oh, PS tree might work. I don't even play with PS tree very much. But how about this? Can you show how the SSHD process was started and what its parent processes are? How about PS tree? So, by the way, what if you grep something like this? Have you guys ever played with grep and you want to know, like, I want to know something a little higher, or I want to know something a little lower? How would I see something a little earlier? What if I said dash before 5? And that would give me a little bit more. And then I say, I need to see a little more, and I go 10. So 10 before the most recent one, and maybe I could find some stuff out. But what about this? What if I knew this? What if I said PS, EF, grep-i for SSH, and I saw that this was the process, and then I saw that my parent process was 1. How would I... Shauna Alvarado said, PS, FAUXX, grep-ish. I love it. Yeah, that's actually... Oh, that's really nice. Because look, it shows anything underneath like an SS agent. I like that. I wonder if you could do that with just the 1X. Would that still work, or do you need the 2? I still like that. That's pretty good. Now, how about, could we still do that thing from earlier, that systemctl status SSH? Couldn't that still work? I mean, that still shows us. Yeah, I thought I always had to do capital 2 Oreo. That's why I tested it with the lowercase earlier. I always thought I needed to do a cap. I thought it was cap A and cap B, but apparently lowercase b works because we just tested it. But see, that's another one of those examples where I tell you guys, like, I don't always know. Like, when I was looking at that -B5, I was like, I thought it was capital B, but apparently you can do both. So, okay. Let's look at this real quick. The SSHD process was started by process ID 1. So if I did a PS tree, right, and then I just did like a more on it, systemd started up here, and systemd started everything, right? Systemd started pretty much everything in my environment. PS-EF grep-I systemd System D was, okay, so let's see, System D journal. They're all started by this process one. Well, anyways, the first process of the system should always be System D. The process one should be System D. Yeah. So you can banner grab and see that's open. Sure. Like NC to 127.0.0.1 on port 22. Sure. Yep. That would work, right? But that won't show how it's started. That'll show that it's running. But how did it start? This is another one. You've got your system CTL status, and don't you also have, where'd it go? System CTL status. Don't you also have that tool I was showing you guys earlier with cat? I love this tool. I love cat out of system CTL because it shows us. Okay. So now I have from my process ID earlier, which I think was 730 on this one. Let's see. 733. So PS tree. My environment's dead. So I'm gonna have to grab a new one of those. We gotta restart the environment, guys. We've been going over 6 hours now. This is like one of my longest streams ever. But we're going over 6 hours now. What if we went, make this a little bigger so you guys can read it. We're not even doing the lab. The labs are pinned, but we're not even doing the lab. We're literally just clicking buttons. System, CTL status, SSH, right? Now it's 756 for this one. So we do a PS tree dash P on that PID. But was there a way to see more of that? Oreo Byte, I want to see more around this one. I don't use PS tree. Is there a parent? Dash S maybe? Can we see a parent? There we go. Okay, that actually is perfect because it shows system D as process 1, so we can see that it was processed that way. Let's go do the system CTL cat real quick because somebody asked about that. System CTL cat SSH. We know that system D started SSH. We see it right there with that PS tree. We got that cool little, that's actually, I really like that a lot. So once I've got a thing, I know how it started. But this right here tells us that system D started the service. But the system CTL cat shows us what file it used and what was in that file. So if you're ever tasked at work with like writing an alternate SSH service file, hey, we want to use port 22, but if the users ever use up all of their slices, but they haven't used up all the memory of the server, they've just logged in and done too many slices, we want a secondary alternate SSH. We're not doing it for hiding purposes. We're not doing it for security by obscurity. We just want a second one up in like the 17,000s, and we'll have a secondary port. You could do that with this right here. You could grab this file, you can make a lib systemd system, or you can make it over in Etsy systemd system. That's where I would do it. And SSH-alternate port, and then you would come in here and you would set an alternate port for SSHD in here. You can make it call, the easiest way to do it would be instead of calling where is it at? Yeah, instead of it calling the options here and getting the main file, you can have it call the Etsy SSHD underscore alternate config file, and then make that file from your other file and just change the port number from 22 to like 17,000 something. I use that. That's something I use. Not because I want to, again, not security through obscurity, just an alternate port to get in case one of the SSH daemons goes down. You also want to have a console port if you can. Console ports are pulling up, I can pull up, I'm in the Bitnami server here as though I was sitting at a console with the old crash carts that used to go push in the data center. Well, we don't have a physical machine anymore, so I can't go plug into the back of the server anymore. I have to come in and connect through a virtual console like this, right? But this would be, I could watch this system boot if I needed to, that kind of stuff. So, all right, system CTL cat SSH shows us all that, good, right? So we come down here, and then what's our next one? So that's cool. That's how it started. Can you edit the file that changes the kernel the system boots to? Oh, so we got a file out there that causes the kernel to boot to, it's in grub. It's definitely a grub file, the Grand Unified Bootloader. It's probably a version 2. But where is that file at? Can you edit the file? Can I edit that? Ah, you do have some stuff in Etsy on some more modern Linux systems. Yeah. Can I? Let's see if I can cat Etsy grub. Whoops, grub. Are there any grub things in here? Sometimes there's some stuff in here that you can mess with. Yep. And this is probably the preferred way to do it nowadays, right? But let's go see. I don't know. I don't know any of these. This is where it's going to go grab a bunch of things. I'll show you the way we used to do it. By the way, I use Red Hat almost exclusively at work, so I just use a little tool called Grubby, and I can set all this shit without. Grubby is like one of the best things ever for sysadmins that don't want to go and change grub files anymore. But we used to do it down in boot grub. And down in boot grub, you've got a menu.list or a grub.cfg. So vi grub.cfg in here. And I could come down here and it says, do not edit this file. It's automatically generated from this. Oh, you are wrong. I'm going to edit this file all I want. Anyways, the point is you can come in here and you can change the menu entries if you wanted to here's your recovery mode. Here's your other stuff. And again, it says right there, it doesn't really want us modifying these anymore. But these are where we used to modify things. Oops, grub dot. And then now all of these. So if I just cat everything, looks like that's where it's generating all of that file from. So that's fine. I don't really advise mucking around in here very often, but you absolutely could, if you needed to, cause one of these to boot, or as you boot the system, you can pick a different one. But I've had to edit these over the years, and we used to do them by hand back in the day. Just make sure you had a copy, and if you didn't have a copy, you had to make sure you had a rescue disk that you could boot in, get in there, and fix it. But yeah, I wouldn't advise doing that too much anymore nowadays. So yeah, you can get in there. I would just say muck around in maybe Vue, right? Vue is a non-editing VI. Etsy grub, grub.conf, and then it says don't change it. So that's what the Vue automatically puts you in edit only mode, unless you choose to override it with an exclamation mark, which you're root. You can do whatever you want, right? How about this? Can you tell me the version of Linux you're using? So we know uname-r, but that's only half of it. There's another half of it. Let's say you get called in the middle of the night and you've got a set of servers that are having a problem, and you're probably going to have to go to the vendor. Well, how do you know what version of the kernel can tell you some of it, especially like in rel 7, 8, 9. I can tell you what version of the kernel goes with each up. Yeah, that's my favorite. So cat OS release, I do like this because this has been the most correct for me across all versions of Linux. But OS release, rel release, there's all kinds of them. Uh-oh, hold on. Guys, you gotta always let me know if that breaks. There's actually a command on the Twitch side if that breaks. Like if I'm talking and it's not doing it anymore, you guys have a command that'll alert me. All right, what did I do? Hold on. Can you tell me the version that you're using? Yeah, we're on 20.04.5 long-term support. Or that fun command that shows you the ASCII art. Oh gosh, I've never played with NeoFetch. I've played with there's the Calsay BS, right? But can you tell me the version of Linux you're on? Yeah, there we go. Boom. So can you tell me? Okay. Here we go. LSB release -A. There we go. I like it. And for some of you, the most important thing may be the Ubuntu piece or any of these other pieces, but it's good to know where this data can be gathered from, because we also have other tools, like in our Ansible tools, we can pull Ansible distribution, Ansible kernel version to get these things as well. So then we can make decisions in Ansible based on, I can run Ansible against a bunch of Debian servers, a bunch of Ubuntu boxes, a bunch of Red Hat boxes, and a bunch of Fedora boxes, and I can have 4 different things happen depending on what what they are. And we can use blocks for that. We can use inherited decisions, so we can inherit roles only based on the certain version. So I could have 4 different roles made up, and you only fall into the role that you want. Or it can all be in the same playbook, and I can just use blocks to which are almost like functions, and you only get called into the one function based on, it's like a little Plinko machine where you go. If you guys have ever seen Plinko or the Marbles on Stream game. All right, anyways. So can you tell me the version of Linux you're on? I think we did that pretty good. I like that LSB release with the -A. I think that's pretty good. All right. Can you describe the 7 fields? Head, etc pass WD. Do you know the 7 fields? And that should be explicit without going to ChatGPT or Google. Do you know what those are? This may be less useful nowadays. I mean, to just have them all memorized. But I think you should know what they are at a high level, right? Even if you don't memorize them hardcore, have somewhere to reference them, I think if you do it long enough, you're going to know them all anyways, but, right? Can you describe the 7 fields of the etc pass WD? Why is the second one always an X? Anybody know? 1 is user name. Yep. 2 is your password, but your password no longer goes in there because everybody can read it. So that just tells the system that it's over in shadow. 3 is the user ID by number. Yep. 4 is the primary group of your user. Yep. What's 5? Yeah, that's your primary group ID. 5 is a description field, which is most people leave out. 6 is your home directory, right? And 7 is your default shell. There you go. There's your fields. So you should know those. I'm just going to write yes because I can do it. But you should know those at a high level. And you should know, maybe if you wanted to, and by the way, one of my buddies worked at American Express a few years back, and he wrote auditing tools that did this, and he would search within the tooling that he had. You would grep for no login, maybe grep-v. We went a little more in depth, and I actually helped him with some of these, but it was funny. So get rid of all the no logins, because we know that they can't log in. And maybe get rid of all the bin false. I like to make things bin false as well. These are all the things that could possibly log in on your system. Bin bash, bin bash, bin bash, bin bash. There's only 4 that can log in. That bin sync isn't going to log into anything. But now I know what users, and then maybe we've got a requirement that a user that can log into the interactive shell must be either 0 or higher than 1,000. Well, 1,000 is where normal user space starts. 0 to 199 is considered system. 200 through 999 are applications and software that's installed. And then 1,000 up are the user IDs. A few years ago, it was only up to 500. Now it's up to 1,000. And then all the software spaces in between there. But 0 to 199 is reserved for the system. Right? Root being 0. Root's always 0. What does he use a tool that wrote, and how often did he run it? Oh, they used to run it all the time. It was before they went to Tenable Security eventually. Nessus scanner. But he wrote that, and they used to run it. He would audit things and send them to the other teams. He was on audit. That's what he originally did, and then he moved out of there, and he doesn't work for him anymore. He actually moved up to manager for a while, and then he moved out of that space. But yeah, one of my good buddies was over at American Express for quite some time. All right. So, anyways, we did 7 fields. Can you show me all the unique? Oh well, I stole my own thunder there. But can you show me all the unique shells that exist in PassWD? And can you count them? Can you show me all the unique shells in Etsy PassWD? I think we did this one earlier too, but it falls into more than one context. Could we cat Etsy PassWD and then awk dash capital F colon and look only at the last field, which is the 7th field, get all those, and then could we sort them and unique dash C them to count them all up? There's all of our, here's all the types of things in the system. There's all the unique shells in the system. Not by user or anything. I didn't ask for that. I just needed to know, to let management know, you know, some scope, some thing out of the approximately, I don't know, what is that, 47 or so. There are, you know, 37 that can't even log in, and then some other set of them, right? Does all the time mean every? Oh, I don't know how often they did it. I think they did it every few hours or something. Nike Strike, yeah, I don't know, or Night Strike, I don't know how often they did. I would say they probably did it once a day, but some of his scans were also more deep, and then they would go to the teams for immediate remediation, and then they had other stuff that was actually like scanning all the time and keeping stuff secure. I don't know their exact posture, but I just helped him write some of the stuff that looked, because with awk you can search for greater than and less than. Awk is its own programming language. So I use awk for very simple things, grabbing columns, but you can do a lot of powerful stuff inside of awk as well if you're so inclined to do that kind of stuff. So, also, I think I missed some follows, Algeria. Hopefully this stuff's useful to you. Yeah, so we did that. And can you set one variable? This will be fun. Can we set a variable? Set one variable that is inherited by child processes and one that is not, and then prove it. All right, we can try that. So how would I know what shell I'm in now? Does anybody remember how I know what shell I'm in now? I mean, I know I'm in bash, right? But does anybody know how I know which bash I'm in right now? What actual process I'm running? Does anybody remember that? I need this for this next part. But what is it? It's $, right? That is a special variable that ties back to whatever process you're in. That's your process ID, right? So it's the thing. If I were to search for that right now, ps tree-p30575, like we were doing, that's my bash right there. That's my bash of the environment that I'm in. Okay, good. How do I set a variable in here? Anybody remember that? Can't I just set the variable? Can't I just say rar? Okay, so I have a variable. But if I were to bash and then echo $, I'm down here, and if I echo dyno, there's nothing in there. So that variable did not come with me to my child process. Then I come back here, and I'm back in my original process. Do you guys see that? I'm doing this to show you because there's no other change to see that you dropped into a child process. So can we, let's make a, let's say dyno 2 equals RWAR2, right? And then we'll export dyno 2, right? And let's see if I can just export dyno 2. I think that'll work. and then I'll go down into my bash, right? And then echo, or echo. If I could type $dyno2, and there's my rar2, and then hold on, echo $, make sure I'm in some new shell, echo $, I'm back in my original shell. So that might seem like an exercise in silliness right there. Like you might look at that and go, that's the dumbest thing I've ever seen somebody do. It is dumb the way I just did it. Why would I do any of that stupid stuff? But it's not dumb if I'm writing a shell script, and in my shell script, I need to fork processes or go to a child process or run something that's going to happen off in the background and come back. And I need to know that it can write to the same variables that I'm already using or not. And if I set variables at the beginning, but I did not export them, my children cannot use them. Does that make sense? The children of my processes that I've spawned, the process that I'm in, I can export as many things as I want or nothing, but they're not useful outside of my shell unless I make them explicitly exported. And I think Horizon was right. I could have exported it in the same command that I created it. I just did it in two separate commands like this. I could have exported this command. So there's that. Hey, Say Fenton, hopefully this stuff's useful to you. We are just doing Linux out here. Trying to get the whole world doing more Linux, right? Get more people into systems engineering, get more people into all this stuff, right? Like this is very attainable for you guys and girls that want to do systems engineering. Fun fact, YouTube keeps track of how many people watch me, and I have like a 98.5% guys watching me rate, which I think is hilarious. My wife thinks it's hilarious. It's man, I guess I'm like ASMR for nerds or something, but anyways, that's kind of funny. But could I do it? Yeah. How did I inherit? So let's say dyno equals rar is not inherited, and export dyno2 equals rar2 is inherited. Fair? I think that right there probably looks really silly. Like you're like, oh man, that's like the dumbest thing. But later on, as you get to doing this, and I mean, gone are the days of like deep bash scripting. You're not going to do a lot of that stuff. Most stuff we can do in Ansible and blows all this stuff away because the framework's so good. But the concepts of what gets inherited and what doesn't are truly important when you're down digging around in what happened in the system, right? So anyways, just put that in your back pocket and think, Scott said I'm going to need this for my lunchbox one day, and just, you know, and then you'll be good. All right. Can you set a process to run every 5 minutes on a server? Does that not? Oh, it doesn't come to wall because I'm not in a. Oh, it would help if I typed things right. All right. So anyways, when you're SSH'd in, guys, when you're SSH'd in, you'll see this message. If you're just at a console like I was, you won't see the message. See how I'm at the I'm here. So now I want this to pop out, this message right here. I want this to pop out every few minutes. All right. So I'm going to go to cron tab -E, cron tab that doesn't exist. It asked me what do I want. I'm going to do Vim Basic. I'm going to hit Shift G, and down here I've got these 4 fields. I've got 5 fields. 1, 2, 3, 4, 5. I've got minute, and I want it every 5 minutes. And then I want my command, which can just be that. Now, my command, I might need to do escape :WQ, which echo, And I might need to know that it's user bin echo, but how would I know the path? So if I cat etc cron tab, in cron tab I can see my paths, and is that one of my paths? User bin echo is there. Okay, so I could just use it, or I would need to use the full path. So cron tab -e, every 5 minutes, do that, and I don't need to put the whole thing. Cron.guru is a good source to learn how to. There's some really good cron tab type stuff out there. Cron tab -e, that bin echo hello into temp file. Yeah, you can throw it in there. In fact, Horizon, your example would be every 2 minutes. Mine would be every 5 minutes. And it's fine. It depends on whatever you need. Escape colon Q date. So we would expect this to run in about, let's go sleep 90. We would expect this to run before our sleep is up right here. And what it should do, should come up. Yeah, that's fine. That's fine. The way we used to have to do it's actually kind of funny. So the way we used to have to do this, I'm going to leave this line here. And then I'm going to grab it, and I'm going to make another one. And I show you guys, this is the way we used to have to do it back in the day on servers. You used to have to say, well, so this is every minute, but divided by 5. So anytime when there's no remainder. So it's like a modulus function. But we used to have to do 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 50. That's how we used to have to write that. That's funny. Okay, so yeah, that is actually funny. But yeah, that's that can happen without the grep. I forget grep all the damn time. So if I hit when this is done, technically that should have ran. But could we run every 5 minutes on server? I think we can run that. By the way, one thing I didn't check is cron tab running. Cron has to be running. The cron daemon, not cron tab, cron daemon has to be running. And this should pop up and go to our screen here. Give me 1 second. I'm gonna grab a couple water bottles here. So let me know if it comes up. We don't see it, so that's scary. It didn't pop up in the time right there, so that's scary. Let me check real quick. I might have messed that up. I think I know what I did there. And for now, while we're messing with it, we're gonna make it every minute. And you know what? Let's just take this off. We should be able to get away with that. Every minute, this should start annoying us by just popping up in our screen. And it should start in about 40 seconds. I'll turn my video back on. All right. So let's see if we can get this to run, which it should. And then we won't do that monstrosity because that's just absolutely terrible. Who would ever want to see that thing? Okay. We'll get in here. Does this lab include NTP Crony? I don't have a NTP Crony lab, strictly speaking, but I do have some stuff down in the Discord that talks about it. We don't. Yeah, I don't go over it like in this. I don't have any talks on it directly. No. There it goes. Boom. Popped up. See that? And that's gonna keep happening every minute forever. That's gonna be super annoying. So let's go cron tab, and then we'll just change that to like every 10 minutes, because then it'll only happen a few more times before the end of this lab. But can you set a process to run every 5 minutes on server? I think we can do that. How about user environment? Let's do some user environment stuff. What is your user's home directory, and what is root's home directory? So what is the user's home directory, and what's root's? So user add -m Scott, and then do I have any LVM content? Yeah, Sean Alvarado, I have LVM that I talk about and do in my home lab setup, but I don't have any out here because I talked to the guys a few years, well, like a year or two back on the Slack for this Killer Coda. And I said, hey guys, can I have a little environment where I just have like 3 just little tiny 1 gig or 2 gig data disks that I can just have people do LVM on? And they said, no, we don't have any plan for it. So I would love to put you guys up in here and just get you guys doing LVM, but I don't have anything like that. I do have actual labs in my home lab on it, and that we used to do with the AAA guys back when I used to teach all their engineers. But no, I don't have any. I don't have any up here that you can do, unfortunately, because there's like a limitation of the lab, so it's unfortunate. But how would I find? So if I just maybe grep Scott from Etsy Pass WD, I told you guys the 6th field is the home directory. So if I ls-l on home, there are all the users in the system, and they own their home directories. And their home directories are 755, but most, like, well, I mean, I think that's just like an Ubuntu thing because Red Hat does 700 for home directories. And then what is the root's home directory? It's root, and root is set at 700 like I expect. So users are down in home username, right? And then root, oh geez. Not what I wanted. Oh God, it's all bad. That was terrible. All right, hold on a second. Root is always in root's home is always root in a system, right? So I think we know that. Every 10 minutes, right? Every 10 minutes on the 10-minute mark. So we know that. So we know, I mean, our home directory and root's home directory. Can you show an alias? So can you show all the aliases your user has available? Where do we find our aliases at? How do I find what aliases my user has available to him right here? How do I find things that are different than what the base system has because they were set maybe to protect me or for other reasons? What things are there? Where would I find those? Alias, right? Yeah, alias is a great command for that. And an interesting thing about alias, it does not matter the order these are set. They will always come out here in alphabetical order. They will always be in alphabetical order. I don't care if you set it last, it'll always be in alphabetical order. So that's not super interesting, but it's just the point is you can't tell. Yep, so stacks, that's how we find where they're set for sure, for alias. Yep. But how can we show the ones that are available for right now? There they are right there. Alias is the king for that. How do I unalias one of these? Like, maybe I want to unalias ls. Can I just do that? And then if I ls like home, it doesn't give me the colors anymore, right? The colors are gone. Yeah, the colors on those directories are no longer there because I'm not getting that color auto as part of my alias anymore, right? So my ls was to cf, but if I do an ls-cf again, which is what I was aliased to, where is it? Ah, no, it was ls color equals auto. Boom. There's my colors again. Who redeemed that? It doesn't tell me who redeemed it. Oh, Renoia, just spending those points. Yeah, I can do an infrastructure as code deployment. Let me do that real quick. So, in my home lab, I'll show you guys a basic little infrastructure as code deploy. Let's go over here, and then in my home lab, So I had over on the Twitch side, somebody redeemed an infrastructure as code deploy. So whenever they do that, I got to go do a deployment. Let's look at our prod Ubuntu. I don't want that one. Let's just look at our server deploy. That'll just do the lab test ones. Okay, I should be able to do that. And it'll go, I think those templates exist. And if they don't exist, I'll fix them. Okay, so here's a simple little infrastructure as code. I don't have the server lab test 1 or lab test 2 up in my environment over here. Lab test, I have lab, and I have the C router and the blue nodes, but I don't have any lab test servers. So I'm going to say Ansible playbook. Doesn't matter. Okay, all that should work. Oh, I might have to ask vault pass. Hold on. This will break, but give it a second. Give it a second to break, and then we'll go fix it. All right, ask vault pass. Ask pass vault. I always forget. I always get the order of that wrong. Now this is going to go out and it's going to run and it's going to try to deploy those 2 nodes into my environment. It's going to create a VM from template. Lab test 1. Is he there? Oh, he was already there. All right, let's go make lab test 2 then. Because that server was already there. This one's commented out, that one's commented out. We'll just make this one lab test stream. What it's doing is it's doing all this deployment stuff, and it's grabbing this set of variables, the deploy name and the template variable, and it's putting them up there, and it's going and it's sending it over to my XCP NG, and it's going to deploy a lab test stream. I didn't realize lab test 1 was up. Lab test stream is what the name's going to be over here in my environment. There's my stupid cows, and yeah, that'll be that. So this is in the Twitch side of things, people have points can redeem and ask me to do things. I used to always do these up into the cloud, but I've torn down a lot of that infrastructure and I don't have that up as much. I need to get back into building my cloud stuff again now that I'm moving out of simply being in the high performance compute space. I'm kind of going back to I'm going to a few different tasks soon, but a lot of it's automation, and I'll probably be bringing cloud into a lot of my environments. So yeah, we used export earlier. No, so alias is just a command in the environment you're in, DPR. Export is to set your... We used export a little while ago. Export is when you want a further, a child process to have access to your variables. That's typically what that's going to be. By the way, this is taking a little while to run, but soon we're going to see lab test streamer up here, or streamers, or whatever I called it. Lab test stream. That'll be the name of the server right there. That will pop up right here in a few seconds. Look, nothing up my sleeves. I'm not going and typing and building the server some other way. It's getting built from that Ubuntu hardened template, I believe. The template is DB8F. So let's see which one it is. DB8F. Yeah, it's coming from this Ubuntu hardened template that I have. And I hardened that on stream like a year ago. I don't even remember how long ago I built that. Probably have to get off here soon. I hear the wife around downstairs somewhere, so I know she's back home. She's probably gonna want me to. Oh, I missed this. I missed a text from her. All right. This will deploy. Yeah, there's a lab test stream coming up right there. Boom, and then it deployed. And then we can go in there and we can actually watch that box boot up if we wanted to. Actually, that server might already be booted. We might have missed the fun part of watching that come up. But that's an infrastructure as code deployment. That's the infrastructure being deployed from some code somewhere. In this case, it just happened to be Ansible. I also use Terraform. I'll use any tool. Guys, I don't get bogged down in any of the tools. If I can figure out how to get it to work, I will get it to work. But okay. All right, that's enough of that. Let's go back to the lab. We're 22 minutes left on this lab. But can you show the aliases that a user has? Yep, we did that. And then it was alias. And oops, alias. What's our next thing? Can you create or remove an alias? Yeah. That's just unalias or alias and then whatever your thing equals, right? So that's all you need for that. That's a pretty straightforward one, I think. Can you tell us if the user has a password set? So my user, ID Scott on here, he doesn't have a password set, but how do I know that? Anybody know how you know that? How can I tell if a user has a password set? Let's see. Let's grep Scott from Etsy Shadow. He does not have a password set. That's one way to do it. What about how about that? That's pretty good. Does my password... There was a password change today, supposedly. That's information about my user. That's pretty good. But I don't actually have a password for this user. So maybe... Can I see... I got warn days root, min days list, inactive, ISO, help, expired date, and last day. So that gives me a lot of good info. But I think mostly I would use something like this to see if I was in shadow. Okay. So how about let's go to another one. Can you create or remove an alias and make that persistent? So that alias stuff we did earlier, can you make that persistent? There's a bunch of alias stuff in there. So I could put it in there and then I could source that. That would be good, right? bi root.bash rc. You just put it at the bottom here. Alias dino equals rar. Right, so dino will equal dino equals rar, escape colon wq. Oops. That should source it. Alias will have dino in there, and then if I do dino, I should say roar. Right? Yeah, bash rc is one of the easiest ways. If I wanted everybody to have that alias going forward, I could go put it in Etsy profile.d as a root administrator, and then everybody would get that alias for dinosaur if I wanted to. So yeah. Can you create an alias and make it permanent. Yes. Dot bash rc or dot profile dot d. So it's etc profile dot d if you want to like make it system wide. Check this out though. Users can change that. Users can get rid of aliases if they don't want them. Yeah, and then the dot root, so that's called sourcing. So I sourced the file without having to reload my shell. So I sourced that file without leaving and coming back. That's what the dot root bash rc did. Was it kind of reran through that file without me having to exit a shell or go into a new bash or anything like that. So that's a little trick. If I was in that directory, I could have done dot bash rc like that. That would have done it as well. So you can, there's different ways. I mean, you could also say, I want to just leave and come back into the system and re-see it, but that will go reread. That'll make sure there's no errors in my bash before I leave and come back. And then, you know, hammer up or ruin my bash and then have to go fix everything again. That's a mess, right? All right. Do you know where the user's default home directory's files populate from? Where do the home directories, so when I made that user, Scott, so cd home Scott, ls-al, these all came from somewhere. And how do I know that that's where they came from? Who knows where that is? Somebody here knows. Yeah, Etsy Skell. You guys got it. Etsy Skell. And ls-al in here. There's a bunch of them. I'm just going to touch a dot super file, right? And then ls-al. So now there's a super file in here. And then I'm going to exit. Actually, I'm not going to exit. I'm going to cd back to roots home. And I'm going to user add -m scott2. And then if I cd to home scott2, ls-l, ls-al, there is super file, got populated. But what about home Scott from before? Did Scott that got made like 40 minutes ago have that file in there? Is the Etsy Skell backwards, does it backwards populate? Or does it only go for new creations of users? We're about to test and find out, but what do you guys think? Or does anybody here know? Does Etsy Skell only populate once for users, or does it backwards propagate? This is not a super important question. It's easy to go find out, but it's a good thing to think about. Does Etsy Skell backwards populate to users? And the answer, Stacks is completely right. It's no, it doesn't. This user was set once, fire and forget. Etsy Skell does not repopulate that user. So that's an important thing to know. I mean, it's important-ish. If I was going to modify something for users, I might just go push it to all there. Or even better would be just to put an Etsy profile.d, and then it becomes part of login to my systems, right? And that's the thing. There's the things that you own as the administrator, and there's things that the users own that they can change over time because it's them. So, yeah, I mean, we're just hanging out. Segarain, you didn't really miss too much. We're just kind of hanging out and talking shop and going through a bunch of Linux, right? We're doing the most basic Linux stuff that I can think to do, and we're just walking through it and answering questions, and I'm just writing this stuff. So profile, where does the default home directory files populate? Etsy Skell, right? They don't backwards propagate, and that's important to know. Can you set a script that automatically runs on any user login? Could we do that? Could I go take this? bi.bashrc. What? Yeah, I thought I had that. I'm going to grab this line for myself. And I'm going to say, well, can I set a script? Can you set a script that automatically runs on any user login. Where would you put it? Where would you put something? That will always run. Will always run in there. Doesn't even need to be executable. None of these are executable. But then if I su to Scott as a user, alias, he got that. That alias was not set to his thing. We can even go to Scott 2. I know I didn't set it and muck around with Scott 2 any. Oops. Got it. Because anything you put in Etsy profile.d is going to run on all the users. But the only person that can do that is admin, like a root user in your system. So this is a place that you can put things. We put stuff that is bash rc motd. Yeah, you can put motd. That would be something when people log in they could see it. But I'm thinking down in Etsy profile.d. And they don't even need to be executable in there. So that's pretty good. All right. What about this? Can you check your current users? Do you know what your primary and secondary groups are? So, can you check all your current users? Etsy pass WD. There's all my users. Okay. Can I check their primary and secondary groups? ID Scott 2. And then, you know, our groups, we were talking about this earlier. We were doing our pseudo stuff. Maybe I do a VI of Etsy group and I go to, you know, pseudo, and then on pseudo I add Scott 2 because maybe Scott 2 has more powers. Oh, there was my message, right, with 10 minutes left. Now I do my ID for Scott and he's still Scott, and then ID for Scott 2 shows pseudo, and then I do a pseudo -L -U for Scott. He doesn't have any permissions, but Scott 2 has permissions to do everything as pseudo. So your primary group is your group ID. Your secondary groups are anything that fall under what's called groups. And then you can be added to different groups. There's also group add and group mod commands and stuff, but I like to do stuff like that. Can you check current users? Etsy pass WD, right? Just cap that file out. Super simple stuff. Can you check, wait, do you know your primary and secondary groups? Yeah, it's just an ID username or an ID without anything. You can do who am I? Oh, sorry. Yeah, can you check your current users? Yeah, who am I? And ID can tell me what user I am, absolutely. And there we go, I'm root. I'm the root user even though my PS1 variable, every time I have to reset this lab, my PS1 variable's busted. But if you are a stickler for that, you know, your stickler meeseeks, there you go. Now we're on a clean, now we're the root user, right? We were already the root user. Who am I? ID, boom, all this stuff. So look, I mean, so a group member of a group that has RWX but is not owner of the group cannot remove files. Is that correct? Something I noticed experimenting on. So Mr. Extremely, what you have is when you're the group, so let's go to let's su dash to Scott 2, and then we'll do our ID in here, and I've got the pseudo group, right? And actually let's go over here. Let's ID, so I'm the root user. Let's make a directory called test, and we'll just touch a file. Right, and then we'll change ownership -R to sudo for everything in test, right? Sudo's a group. We'll make root sudo because sudo's a group. That's valid, right? Then we'll come and then watch. So if we do an ls-ld on test and ls-l on test, we can see the the group ownership is read and execute for that. So actually, let's do one other thing. We're going to chmod -r, and on everything in test, we're going to make it 77. We'll do 775. That's fine. Actually, we'll do 770 because that'll prove it even better. Do those same things. ls-l test, ls-ld test, boom. Those directories are owned. The directory is owned by root, and the sudo group can get in there and do whatever they want. And the file is owned by root, but sudo can get in there as a group and do everything they want. Now my su to Scott2, his ID shows that he's sudo. So he should be able to cd into test. Yes. He should be able to read file 1 and edit it. Oops. With no... He should be able to do anything in there he wants. Scott can't even get in there. He can't even get it. He's not in the group. Right? So, to answer the question, group ownership is group ownership. If the group owner has read, write, execute, they can delete that file. Let's prove it. I've got group ownership. I can read, write, and execute it. There is an LSATTR value. You can make a file immutable. So I could make that file not be able to be deleted. However, the user still has read, write, execute. He could just empty the file. He can echo 0 and just clobber the file. I could echo this. Now file 1 exists, right? But it doesn't have anything in it. So you could do all this stuff, right? Man, I mean, file system permissions. That's one of the reasons I like just being rude, is because I can do whatever I want. But file system permissions, Mr. Extremely, are all about reading what groups people are in and then looking at what they have. Mr. Extremely, it's probably just a bit set somewhere weird or something. There are hidden things. If you do an LS. LSATTR looks like this. And there's all these other file system permissions that you can set against a file and that kind of stuff, and you can play with. There's like a set ATTR. I don't know. I don't really play with that much because I don't like mucking around with that crap. And then when you really want to get into crazy labeling, do SE Linux, because now you have context around how things can be accessed in a file system. SE Linux at the end of the day is simply another bit of labeling on the file system, and then a new controller that controls how access to files are. That's all it is. It is no more difficult than that. But people turn it into something more complex. And yeah, ACLs are basic access control lists are right here, and it's just an extended access control list at the end of the day. That's what SE Linux is, and then it's an engine around it. All right, so we got down to bash scripting. I'm gonna tell you guys what, I'm about to hit 7 hours. I think I'm gonna stay on for 3 more minutes just to hit 7 hours, and then I'll probably have to get off of here. But we did a lot of stuff. Hopefully this stuff was valuable to most of you. If it wasn't valuable, then come hang out and get faculty checks on ACLs and files under. Yeah. So get FACLs. You can have all kinds of other file system attributes added with extended access control lists as well. So there's so much stuff. Let's see how far we got. We got to 85. We had all this bash scripting stuff that we could have done. Then we had all this software package stuff that I added. So there's a fair amount of other stuff that we could have done. Oh, where are we at? We were at 85. We got down to 85, guys. We did 85 of these slides. Just asking ourselves questions, figuring out things. In which channel will you share your notes? Horizon, when I finish this, which will probably be maybe tomorrow night, then I will put all of these notes up in probably the streamer or in the meeting notes. That's typically where I put things. This might be so long it might have to just be a file. It might just have to be like a file attached like that. Sean Alvarado, will I do a session like this on Ansible? Yeah, I actually hit Ansible pretty regularly, But I will do the one on this with Ansible. Yeah, we can schedule that for later in this week probably. I think that would be acceptable for most of you guys. I think most of you'd be like, yeah, that's okay. Let's find somebody to raid. There's got to be somebody online doing fun stuff on the Twitch side. On the YouTube side, unfortunately, I don't have any cool raiding ability. So I don't, or if there is a raid, I don't know how to do it. But let's go find on the Twitch side, is anybody doing science and technology stuff? Anybody that I'm following online right now? Let's see, Ross is on. We raid Practical when he's up. So if you guys don't know Practical, he's building a really awesome looking game, and he's a coder. He's always on here coding and doing cool stuff. So we're gonna raid over to him. I definitely appreciate people that stuck it out with me this long. But if you want a raid message, you can do. I think do all the Linux. I think most of you guys have that one. If you don't, that's fine. But we're gonna raid over to him, and I appreciate you guys that hung out the whole time and stuck it out with me. So take care.